Hello everyone, am I audible? Can you hear me? Hi Pranav, hi Priyanka, can you hear me? Please confirm if you can hear me. And am I clearly audible? So hello all of you. I'm going to take maths for you. You have that information already. You must have seen that killing and thrilling teaser. Not that bit of a actor or hero, but yeah, tried to do the best I could. So some of you might know me already who are there in the session, and many of you will get to know me. So for the starters, I can say my name is Ayush Patni, and I'm going to be teaching you mathematics for class 11th and JEE aspirants. Especially for JEE aspirants, we are going to take these sessions. So stick tight and grab your notebooks and your rough notebooks, whatever you can. Just don't sit idle or without anything. I would say please just bring your notebooks and sit on a table, sit with a table and a chair, so that we can have a good fun with this session. Right? I hope I'm clearly audible and visible to everybody. So today we are going to start with a very important topic which is introduced in class 11th, and as per the JEE exam, be it mains or advanced, this topic is definitely very important for you, right? Sequence and series. Many of you must have read and studied this chapter in your earlier classes, maybe 9th or 10th, and many of you might be learning this for the first time. So no problem, no issue, just stick tight and let's start. Okay, so I've told my name, please don't forget my name. That's the only thing I love about my students, that they can remember my name and they can remember me. And I'll try my best to give you or deliver you the best of mathematics, which we'll be needing for preparing the best for our examinations. Whichever goals you have, the JEE mains or JEE advanced, this session I'll try my best to make it most beneficial and most helpful for you. Okay, so I don't think I should waste any of the time, and we should start. Keep commenting if you have any doubts, if you want to say something or whatever it is. Please keep keep connected, so that I'll also stay charged and motivated to teach the best. All right, so starting sequence and series. Yeah, so first of all, I'll give you a brief idea about this chapter, that what kind of chapter this is, like what all can we expect from this chapter, and why is this chapter this important, or this prior as per the JEE mains or JEE advanced. So chapter is very important for JEE aspirants. That's one disclaimer I've already given you. Next, it is easy to understand. There is no problem in understanding the chapter, but yeah, the chapter is calculative. You have to deal with a lot of calculations in this chapter. So that's not a problem. We are good at calculations. We know how to manipulate our terms and find the answers. One thing I would like to tell before starting is that practice is what is going to make this chapter perfect. It's not that you attend a session, or you read a book, or you attend some 5 sessions and just watch it. Do not write it and practice it on your own. Unless you do that, it's not going to come to you. So I would recommend that please sit with your notebooks, or wherever you can write and solve. Questions are frequently asked in mains or advanced. If we talk about mains or advanced, generally I would say that somewhere around 12 marks questions will be asked in mains, and in advance also the questions can be asked from this topic. General topics are geometric progressions, AM/GM inequality, and sigma notation, AGP. There are different topics which we are going to study in this chapter, and many of them are important for class 11th as well as class 12th. Why am I saying class 12th? Because many topics, many subtopics from this chapter are going to be used in class 12th. Okay. Yeah, Arvind sir is taking some topics of class 12th right now for you, like there are live sessions and videos. Please allow me to take some topics from class 11 so that we can cover up the portion faster. Do you get this? Yeah? Okay. What all are we going to study? Too many topics. A lot of topics are there. So yeah, I already told you, right, that the chapter is lengthy. The chapter is definitely lengthy. It's okay. We'll be prepared. We'll try to cover up all of these in this session. Okay, we'll learn the concept, we'll practice the question, we'll see some questions from the previous years of the examination and some general questions. What topics are going to be important? Sum of AP and GP. Generally, the questions are asked, many questions are asked from sum of AP and GP. Questions are asked from AM, GM, HM inequality, and this concept is also used in class 12. So this is going to be important. Then summation concept or sigma notation. We also call it sigma notation. This is also called as, we can say, this is sigma notation. You must have heard this word, right? Summation concept or sigma notation, properties of AP and GP, right? And then AGP is there. There are more topics. Definitely not only these, it's not necessary that the question which is going to come in the examination is going to be from these topics only. It can be from some other topics as well. Before starting the chapter, I always say that, yeah, first understand what the chapter means. What is the name of the chapter? Okay, what is the name of the chapter? Name is sequence and series. Can somebody tell me in the comment section that what do we mean by a sequence and what do we mean by a series? Come on. What do we mean by a sequence and what do we mean by a series? Sequence, we must have, seen some questions of reasoning or, logical ability or any puzzle based questions where we see a lot of numbers randomly placed 1, 3, 9, 24, 33, 26 or x to the power 3, x to the power 9, x to the power 43. Right, randomly if I place the numbers, this is called a sequence. Sequence means arrangement of numbers in an order, right? That is called sequence. Now what is series then? Series means if we just add these terms of the sequence, we'll get a series. Simple to understand? Any problem? Simple to understand, very simple to understand, there is no problem. If we add the terms of a sequence, we get a series. X plus x cube plus x to the power 9 plus x to the power 43, and this is going to give us a series. So what is the difference between a sequence and series? Series means summation of the sequence, addition, adding all the terms of the sequence. Now comes one more thing which is called progression. In our previous classes, we must have heard or learned about arithmetic progression. Progression means something which progresses. Progresses means which follows a definite order where we can find the next term or some given term for that sequence. For example, if I write 1, 3, 5, 7, you can simply tell me that this is a sequence of odd numbers and this is progressing. Progressing means this is increasing by 2, right? If I keep adding 2 in the terms, this is increasing by 2. Now, if I ask you that what will be the 10th or 12th or 15th term of this progression, you can easily tell me the term, right? Definitely you can easily tell me any term of this progression. But you need to find the general rule for finding that. You know the rule. You know the rule. The rule is the odd numbers. How do we represent an odd number? 2 into n minus 1. This is how we can represent an odd number. Or we can also write 2 into n plus 1. But here, what do we want to find is, we want to find when we want to say when we put n is equal to 1, n equal to 1, we should get the first term. Are we getting the first term? Are we getting the first term? Yeah? 2 into 1 minus 1? No? Can we get the first term? 2 into 1 is 2, 2 minus 1, 1. 2 into 2 is 4, 4 minus 1, 3. Yes, we are getting every term. So, any nth term, if I want to find 12th term, if I want to find the 11th term, if I want to find the 11th term over here, I can just put n as 11. So, 2 into 11 minus 1. That is 22 minus 1, that is 21. Simple to understand. There is no problem. Right? So, this is a progression. Progression, everybody understood? There can be other progressions also. There can be other progressions also. There can be 2, 4, 8, 16, 32 and so on. What do we understand by the term progression? That it is following a specific order. Every next term can be found by the previous term. 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32, 32 into 2, 64. So, yeah, we are able to tell, right, the next term. There is a specific order, there is a specific defined rule which this progression is following. Right? Progression means a sequence which is following or going by a definite rule, a fixed rule, where we can find the next term using the previous term. Alright, very nice. Any problem till now? Okay. General term. What do we understand by the general term? General term, just now we saw a general term, right? What was this? We just now saw a general term. This 2n minus 1 was nothing but a general term. This 2n minus 1 was nothing but a general term. If I name it as Tn, if I name this general term as Tn, what do I understand by this? I understand that T1, when I put n is equal to 1, I am going to get 2 into 1 minus 1, that is 1. When I am going to put T2, that means n equal to 2, I am going to get 2 into 2 minus 1, that is 3. T3 is going to be 5. T4 is going to be 7. Right? So, this is how I have defined the general term. Now, this general term can be defined for any progression. There has to be a method for it, but it can be defined for any progression, because in progression there is a defined rule. We are able to find the next term. We are able to find any nth term of that progression. So, we define that nth term by the general term. General term of odd numbers. Now, if I say Tn is equal to 2 times of n. So, this is going to give me T1 is equal to 2, T2 is equal to 4, T3 is equal to 6 and so on. If my Tn is equal to n cube, this means T1 is equal to 1 cube, T2 is equal to 2 cube, right? T3 is equal to 3 cube and so on. General term, the way of writing it in a generalized manner, so that changing the value of n will also change the term. But yeah, one thing to notice and understand over here, what is n representing? What is n representing? What is n representing here? N is representing the position, right? N is representing the position of the term. Now, can n be 1.5? Tell me in the comment section. Can we say n is 1.5 or something? Can we say that? Tell me. No, we cannot say that n is fractional. N has to be natural. N even cannot be 0. Position. 0 position. Does that make any sense? That doesn't make any sense. 1.5. I am the 1.5th term. Either it will be first term, second term, third term, natural term. Right? Get my point, everybody? Okay. Next. Now, let's do a question based on general term. Very simple question, very easily we will be able to understand this question. Okay, what are they saying here? Find the third, fourth and fifth term of a sequence which is defined as A1 is equal to 3, A2 is equal to 4 and ak plus 2 is equal to ak plus 1 plus ak. Now instead of n, they are telling k. Okay, no problem. ak plus 2 is equal to ak plus 1 plus ak. Any problem till now? No problem. We understand this. Instead of n, there is k. Instead of t, there is a. What I was writing tn, right? Right. Instead of t, I have written a. It's all variables. Be comfortable with them. Right. Instead of n, I'm writing k plus 2 or k plus 1 or k plus 5. That's it. Not a problem. Now, if I put k is equal to 1, let's say, if I put over here k is equal to 1, let's say, so what will I get? Or let's start with, yeah, because we have to put k is equal to 1 only, right? We cannot put k is equal to 0. Why? Because k is always greater than equal to 1, and we'll understand why am I saying that. So now k is equal to 1 will give us a3 is equal to ak plus 2 means a1 plus 2, a3. ak plus 1 will mean a1 plus 1, that means a2, plus ak will mean a1. Very good. a3 is equal to a2 plus a1. We have a2, we have a1. That means my a3 is going to be equal to 4 plus 3. That means 7. What will be a4? What will be a4? a4 means, what will be a4? Can you tell me a4 in the comment sections? Come on. I'm not able to read your comment sections. Let me. Okay. If I put k is equal to 2, if I put k is equal to 2, I'm simply getting a4 also. a4. What is a4 now? a4 is equal to a3 plus a2. I have a3. So my a4 is going to be 7 plus, what is a2? 4. 11. a3 is 7. a5, can you tell me? a5, will you be able to tell me? Yes, simply a5 also we can tell. If we put k is equal to 3, we'll get a5. 3 plus 2, 5 is equal to 3 plus 1, 4. That means a4 plus a3. Yes, we have these two. a4 is 11 and a3 is 7. So we get a5 is equal to 18. What terms are we getting? We are getting we have a1, a2, a3, a4 and so on. Now, what is a1? a1 is already given to us. 3, a2 is 4, a3 is, what we got? 7, a4 is 11, a5 is 18. Tell me, this is an AP? We didn't talk about AP yet, sir. Any specific rule over here, can you tell me, which is being followed? Any specific rule can you tell me over here, which is being followed? Okay, we'll talk about rules. Okay. Now, a sequence is set. What is AP? AP is Ayush Patni. No, definitely not. AP means, yeah, it definitely does, but AP also means arithmetic progression. Arithmetic progression. Okay. Arithmetic progressions, a sequence is said to be an AP where successive terms is obtained by adding a fixed constant number to the preceding term. Just like this. 1, 5, 9, 13, 17 and so on. Now, what am I adding here? What am I adding here? I am adding 4, here also 4, here also 4, here also I am adding 4. So, a fixed term is being added. What is written? A sequence is said to be an arithmetic progression where successive terms, that means every next term, is obtained by adding a fixed constant number to the preceding term. Okay, now here, two important things are there. Now, two important things are there. What are we adding? Can I write 1 plus 4? This is 5. Then 1 plus, yeah, 1 plus 4 I'm writing as 5. If I write 1 plus 2 into 4, what will I get? 9. 1 plus 3 into 4, will I get the fourth term? Yes, I'll get the fourth term. 4 3s are 12 plus 1, 13. Right? So it starts with 1. Now the general form. First term, if I say that the first term is A, this is how a AP looks like. This is how an AP will look like. Can you see that? A plus D, A plus 2D, A plus 3D, A plus 4D. Now this is what? First term. This is our first term. Or can we call it T1? Do you mind? Do you mind if I call it T1? No. This will be T2. This will be T3 and this will be T4, this will be T5. Do you observe one thing? T1 is A, T2 is A plus 1 into D, T3 is A plus 2 into D, T4 is A plus 3 into D and T5 is A plus 4 into D. So Tn is going to be A plus n minus 1 into D. Correct or not? Now can I write T2 is equal to T1 plus D? Simple to write, not a problem. T2 is equal to T1 plus D, or I can say T2 minus T1 is always going to be D, and this is going to be there. T4 minus T3 is also D, T5 minus T4 is also D, T6 minus T5 also D, all are going to be D. What does it mean? It means that if I write any nth term minus its previous term, it is always going to be giving me a fixed value, which will be the difference, the common difference. What does A represent here? What does A represent here? A represents first term. What does D represent here? Common difference. We'll start with very basics, but we'll grasp more, we'll understand more, we'll go to the greater level as well. But let's start with the very basics so that we can get into the feel of the chapter. We can get into the shape with the chapter. Are we clear? A means first term, common difference means D. D means common difference. Any term minus its previous term is always going to give me the constant common difference, which is going to be followed throughout the arithmetic progression. Tn is the nth term. Now, if I want to write T22, what is it going to be? A plus n minus 1, that means 22 minus 1 into D. That's it. So, it is going to be A plus 21D. Now, we'll be writing it directly. 22nd term means A plus 21D. 40th term means A plus 39D. 100th term means A plus 99D. Okay, try solving this. What is the question asking? Baby question this is. Easy, right? Right? The students who have passed and are in class 11th or in class 12th or in the droppers repeating for the competition or anything, they'll find it very easy. They know how to do it. How to do it? But can minus 351 be a term of AP? Now, one thing to notice. If D is greater than 0, what are we going to have? We are going to have an increasing AP. The AP will increase, right? It will grow and grow more. If my D is less than 0, the AP will decrease. Correct or not? What is D over here? What? Achha, D equal to 0? That will also be an AP. That will also be an AP. If I put D equal to 0, then also I'll get an AP. Not a problem. D equal to 0. But what kind of AP it will be? 2 plus 0, 2. 2 plus 0, 2. 2 plus 0, 2. It will be a constant AP. It will be a constant AP. All the terms are going to be same. Okay, note this. so that you remember. Now the question is asking us minus 351 be a term of AP. If yes, then which term will of this AP will be minus 351? How many of you have solved it? Please comment in the chat. Comment or answer in the comment section. Keep answering so that you'll be engaged, you'll be interested and not lethargic at all. Okay. Now, minus 351, okay. If minus 351 is a term in this AP, I'll call it Tn. Any nth term is minus 351. Any nth term, how do I write any nth term? A plus n minus 1 into D. A means the first term. That means 21. D means the common difference. What is the common difference? Subtract any two terms, 15 minus 18 or 18 minus 21. That's always going to be constant. What is it? Minus 3. So, common difference is negative. It's less than 0. That is why the AP is decreasing. That means minus 351 when I'm putting A plus n in A plus n minus 1D. What is A? 21 plus n minus 1 into minus 3. Minus 351 is equal to 21 plus 3 it will become. So 24 plus 24 minus 3n we are going to get. Now 3n will become equal to 24 plus 351, that means 375, and n, what am I getting for n? N is equal to 375 by 3. Can we cancel it? Yes, we are getting 125. That means n is equal to 125. That means this term is 125th term. Simple to understand. Now, what I want to tell over here, the concept is that n, what if n was not a natural number? What if we got a fraction or a negative number or 0? That means that term does not exist. Obviously, position cannot be fractional, 0 or negative. N is telling us the position of the term. Na? Get my point? Okay, very easy to understand. No problem, sir. Let's do the next question. The fourth term of an AP is 3 times the first term and 7th term exceeds twice the third term by 1. Come on, give it a try. For every question, I'll give you a little bit time. If possible, not sure, but yeah, if possible. Come on. Okay, got it. Very good, guys. What are we getting? Fourth term of AP is 3 times the first term. So, fourth term, can I write it as T4? T4, A4, A1, A2, anything. Okay, you should understand when n is in subscript, that means it's telling the term's position. That's it. T4 of an AP is equal to 3 times the first term. That means 3 times of T1. And 7th term exceeds twice the third term by 1. That means T7 exceeds the twice the third term by 1. Have I written it correct? Is it correct? T7 is equal to 2 into T3 plus 1. Now just put the values. What values? Sir, T4. What is T4 going to be? How will we write T4? T4. From here, what am I getting? I am getting A plus 3D is equal to 3 times of A. T1 means term 1. Term 1 itself, right? Term 1 is A. So, I'll just put A. Okay, no problem. 3 times of A minus A. 3. What am I getting from here? Okay, before that, let's write the next equation also. So, T7 is equal to 2 into T3 plus 1. So, A plus 6D is equal to 2 times of A plus 2D. Third term, can I write it as A plus 2D? Plus 1. Another equation I have. Now, this is one equation that I have. And this is one equation that I have. And we are very good at solving the equations. Are we or are we not? Tell me the values of A and D quickly. From here, what are we getting? 6D minus 4D. So, we'll get 2D and 2a, this will give us a plus 1. This can be summarized to this, right? And from here 3a minus a, that means 3d is equal to 2 times of a, can we say? This is an equation in a and d. What we will get? D is equals to 2a by 3. So I think values you can write in the chat box. When you'll find, I think D should come out to be 2. Yeah, D will come out to be 2. And when D is 2, 4 minus 1, 3. That means A will be equal to 3. And if D is 2, A is 3, what will be the 11th term? 11th term, T11. T11 is going to be A plus 11 minus 1D, that means 10D. That means 3 plus 10 into 2, that means 20, that means 23. The 11th term over here is 23, that is our answer. Simple to understand, right? Simple equations. These kind of questions you can also you can expect. It's not like that easy question won't come only. Okay. All right. Next, try this. Is 0 a term of this AP? Can we say that 0 is a term of this AP? Can we say that 0 is a term of this AP? 0 is a term of, if we'll check. We'll just put Tn is equal to 0. We'll just assume that there is a term at nth position, at some position which is 0. Okay, what is Tn? I know Tn is a plus n minus 1 d. Always start with what you have. Okay, for the entire session we are going to follow this approach. Confidently start with what you know. Concept you know. See, you'll reach to the solution if you try and apply the concept very well. Okay, a plus n minus 1 into d is equal to 0. I want this, and if my n comes out to be natural, that means this term exists. Is it a decreasing AP? Yes, this is a decreasing AP because d is 28 minus 31 minus 3, right? 25 minus 28 or 28 minus 31 minus 3. D is less than 0, decreasing AP. 0 can be a term. Okay, now a, what is a? 31 plus n minus 1 into minus 3 is equal to 0. What do we get? 31 plus 3. So 34 minus 3n is equal to 0. That means 34 is equal to 3n. That means n is equal to 34 by 3. 34 by 3 is not natural. 34 by 3 cannot be the position of a term. That means 0 does not exist in this AP. 0 is not a term. Can we conclude that? Okay, next. If 6th term of an AP is 5 and 5th term of AP of the same AP is 6, then what will be the 11th term of that AP? Oh my god, this question definitely previous year or this year you must have solved, and you must have made the equations and everything, but I can directly tell you over here that answer is going to be 0. Why? Why? Let's solve this first. Let's read this note. If pth term of an AP is Q and qth term of an AP is P, then P plus qth term of the same AP will be 0. Huh? How? Arey Baba, simple. Okay, not simple. Let's see this. No, let's see how is it coming. How is this note written? How am I able to say this? Pth term of an AP, that means A plus P minus 1 D. This is equal to Q. And qth term, that means A plus Q minus 1 equal to D. This is equal to P. Subtract both the sides. A minus A. Subtract both the sides. This will become minus minus and we'll have minus. A minus A will become 0. P minus 1 minus Q plus 1. That means P minus Q into D is equal to Q minus P. This is what we are going to have. What will be D? Q minus P can be written as? Can I write this Q minus P as minus of P minus Q? Yeah. So D is going to be minus 1. I got D as minus 1. If D is minus 1, over here I can put D as -1 and I'm going to get A plus minus P plus 1. A plus 1 minus P is equal to Q. So what is my A over here? A is going to be Q plus P minus 1. Now what is P plus Qth term? P plus Qth means P plus Q. That's it. That means A plus P plus Q minus 1 into D. When we'll put these values over here, no? When we'll put these values, what we'll get? What is A? A is Q plus P minus 1 plus P plus Q minus 1 into D. That means D is minus 1 already. So minus of P plus Q can I write? So I'll write minus of P plus Q plus 1. 0, 0. Minus 1 plus 1, 0. P plus Q minus P plus Q, 0. This is going to be 0. That is why I am confidently saying in this question that the answer is always going to be 0. Whenever your Tm, let's say, is equal to n and Tn is equal to m, you'll always have Tm plus n is equal to 0. Note this down. Remember this. It will be helpful. It's not necessary that the same question or same type can come in an exam, but yeah, you should remember the concept to be able to apply further in the further questions where it's going to be needed. Alright, so here, Tm plus n, very important. It's not like if they are asking about T10, T9, then we are not going to apply the same concept. Okay, so T6 is given to us as 5, T5 is given to us as 6. Sixth term is 5, fifth term is 6. Now what is it asking? T5 plus 6, definitely 0. That means T11 is going to be 0. Yes or no? Do we get this? Okay. But sir, what if some other term was given? What? No, I mean, what if they asked about, here they are asking about 11th term, which is 5 plus 6. What if they asked about some other term? What will we do in that case? There is a rule. In that case also, suppose if pth term is given to you as Q and qth term is given to you as R. R. Qth term is given to you as P. Then they are asking about rth term. Rth term will always come out to be P plus Q minus R. Okay, for example, in this case only, if they asked about the 10th term, so it will be 5 plus 6 minus 10. That means 1. Okay. Clear this rule? Remember this as it is. Okay, it can be applicable anywhere. You don't know, you never know where you can use this trick or this rule, right? What am I trying to say? If pth term is given to you as Q and qth term is given to you as P, if they are asking you P plus Q, that will be 0, you know that. If they are asking you some rth term, then that will be equal to P plus Q minus R, and you can derive it the same way we derived for 0. Same way. Subtract the equation, you'll get this. Okay. Now, which term of the sequence, this term, which term of this sequence is minus 403? Also find, is there any term which is going to be equal to minus 500? Come on, let's see if you can give me the answer in within 1 minute, or even less than this. Solve it quickly. I want to see an answer in the chat box. Check whether minus 403 is a term here or not. Come on. Yeah, we'll come to the other topics as well. Please wait. Clearly, now we have A. What is A? Minus 3. Simply, what we know, we have to start with what we already know. So what do we have? A, first term we have minus 3. D we have minus 7 minus minus 3. Minus 4. D is going to be minus 4. Minus 7 minus minus 3 is going to give us minus 4. Okay, no problem. We want to know whether Tn is Tn equal to 403, negative of 403. Is it even possible or not? Negative of 403. Is it even possible or not? We'll check. How will we check? We'll simply just put A plus n minus 1 D is equal to negative of 403. If n comes out to be natural, then we have this term. If it doesn't, then we don't have this term. Crystal clear, simple, very easy. Nothing to complicate, or nothing complicated over here. Already very easy. Yeah, tell me, minus 3 plus n minus 1 into minus 4 is equal to minus 403. What do we get? Plus 4 and then 4. What are we getting? Tell me in the comment section. So this minus 3 plus 4 is going to go that side. So we are going to have 4 and minus 1 is equal to 400. Are we getting this? 4, yeah, like this. 4 and minus 4. 4 n minus 1 is equal to 400, or from here I can say n minus 1 is equal to 100. So n is going to be equal to 101. That means 101st term is going to be 403. Now 500 minus 500, that means 403 is 101st term of this AP. Now check for minus 500. Simply we'll put minus 500 is equal to A. A means minus 3 plus n minus 1 into D, that is minus 4. So we'll get minus of 497 plus 4 is equal to minus 4n. So what is, no, yep, it's n I'm putting because I'm just assuming. We can put it as n also, not a problem. Yeah, we can put it as n also. We can put it as m. Let's take m actually, because nth term we have already found, right? Nth term is 101. So we can take some other variable. We can say that this is nothing but m minus 1 into D. Okay, and we'll call it Tm. So what are we getting for m? Minus 4, this will go this side, and then we'll have minus 4 into m. So m will come out to be 501. I think we have done something over here. This will become minus 500, we'll have this side, this will be minus 3 minus 4m plus 4, okay, yeah, is equal to our mth term. So what is the value of m that we are getting? M is coming out to be plus minus 500 plus 3 plus 4, 501 divided by 4. Is it correct? 501 divided by 4, not integer, not natural. This is not natural. So that means this term does not exist at all. In this AP, it does not exist. That's what it means. Now, very important thing, sum of an arithmetic progression. How do we find the sum of terms in a given arithmetic progression, which is very important and easy also, easy thing to also know. So an, we already know what is nth term. Tn is equal to a plus n minus 1 d. We call it Tn. Okay. Now let's say I want to add T1 plus T2 plus T3 plus T4 till Tn. I call this as sum of n terms. I'll call this as sum of n terms. It is very important to understand what do we mean by sum of n terms also? Sometimes you might make a mistake in this also. Very simple and basic concept, but yeah, possible. Now, what is written? Sum of n terms will be given by n by 2 into 2a plus n minus 1 into d. How? How? How do we find that? Okay. So we know any AP, suppose, let's say I want to denote the sum of n terms as Sn. So my terms are a, first term will be a, then I'll add a plus d, then I'll add a plus 2d, then I'll add a plus 3d and a plus till a plus n minus 1 into d I'll keep adding. What if I write the same AP in the reverse order? That's how a great mathematician found this formula. Very important formula. Okay. Reverse order में, just write it in reverse order. A plus n minus 1 into d. Now, a one term before this. What will be one term before this? What will be the one term before this? For example, over here, I am writing this is the first term. Then a plus d plus a plus n minus 2 into d plus a plus n minus 3 into d. Can I say that? And in the end, I'll have a. Now, when I'll sum these terms, this sum, this particular sum and the other, all these sums, Sn plus Sn will become 2 times of Sn and all these terms, 2d minus 2d. Okay, this will come out to be 2 times of a plus a, 2a plus n minus 1 into d. And how many times it is repeating? It is repeating n times. So, there will be an n over here. Now, they just put this 2 below this n. So, n by 2 into 2a plus n minus 1 into d. Simple to understand. Any problem? This proof, this method of finding is also very important, I can say. Now, one more thing is given over here. There is one more thing given over here. Sn is equal to n by 2 into a plus L. L means last term. L just means last term of the AP. What is the last term of this AP? Last term means Tn. Whatever nth term, last term means nth term will be the last term. Na? What is the doubt in that? That means if I write the same formula, Sn is equal to n by 2 into a plus n minus 1 into d, this part, if you observe, this particular part, isn't it becoming Tn? This is only Tn, na? This only is Tn. That means last term. So, that is why we say Sn is equal to n by 2 into a plus Tn. Tn means the last term. If we are finding a sum of 10 terms, then first term and 10th term. Okay. Simple to understand. Now, let's do some questions on it. If Sn denote the sum of first n terms of an arithmetic progression, S10 is equal to 530, S5 is equal to 140, then S20 minus S6 is equal to what? Give it a minute. Try. Let's see if we can get the answer. What is given? Sn is given to us, sum of first n terms. S10 is given to us. We have a lot of information. We are happy. There is no problem in that. Until unless we have information, we should be happy. Less information is more difficult. So whenever you see a long or lengthy question, no, you should get happy. Why you should get happy? Because there is a lot of information to solve that question. Small and short questions are difficult. Generally our perception is smaller the question, easier it will be, but it's not like that. Okay, answers. No answers yet. S10 is given to you. What is S10 given to you? S10 is given to you by 10 by 2. We know n by 2 into 2a. What? 2a into n minus 1 into d. That means 2a plus n. What is n? N is 10. We are finding the sum of 10 terms. So n will become 10. So n minus 1 means 9 into d. That means 9d. Okay. This is what is it giving us? S10 is equal to 5 into 2a plus 9d. Okay, no problem. S5 is also given to us. S5 is also there with us. We'll get one more information from here. So S5 is going to be 5 by 2 into 2a plus 4d. Can I write? 4d. Now this is given to us as 140 and this is given to us as how much? 530. So my 5 into 2a plus 9d is equal to 530, can I say? And here 5 by 2 multiplied with 2a plus 4d, can I say this is equal to 140? These two equations I have in a and d, I can solve and get the answer. What will I get the answer? No, I will not get the answer. I will get the values of a and d. Can you quickly tell me the values of a and d? You can simply multiply inside, right? 5a plus this will become 5a plus 10d is equal to 140. And from here we'll get 10a plus 45d is equal to 530. When we'll solve this, what are the values are we getting? We are getting a plus 2d is equal to 28. So a is equal to 8 and d is equal to 10. We'll get a equal 8 and d equal 10. And once we have that, can't we just simply find S20 minus S6? S20 minus S6. That means 20 by 2 into 2a plus 19d minus 6 by 2 into 2a plus 5d. I'll just put the values of a and d and I can get the answer very easily. Yes. 1862 will be your answer. You just have to calculate this. So 2a you'll put as 8. So it will be 16 plus 190 over here and we'll have 16 plus 50 over here. When we'll solve this, we'll get 1862 as our answer. Shall we move ahead? Any doubt? Any problem? Anything? You can tell in the comment section. Okay, thank you so much. Great. If the first and last term of AP are 1 and 11, this question, see, baby question this is, and this has come in JEE exam, JEE Mains exam of 2022. Don't you think this is a baby question? First and last term are given and the sum of its sum of its terms is also given to us. Sum of n terms is given to us. If first and last means first and last term is already given to us, right? Last term is already given to us. We just need to find the number of terms. So can I say sum of n terms? Can I say sum of n terms is given to me as 36, where n by 2 multiplied with 2a plus n minus 1 into d. This is given to me. This is equal to 36. This thing is given to me. But here, sir, A, D, and too many things are there. We are given with the information of first and last term and we already know our formula that n by 2 into A plus Tn, that means last term. A plus n minus 1d is Tn, that means last term. Simply I can just write over here that 1 plus 11, first term plus last term. Right, I told you, this formula Sn is equal to n by 2 multiplied with a plus Tn, where a is the first term and Tn is the last term. Simple thing to understand. What is a? 1. What is the last term? 11. 1 plus 11 divided by 2 into 36. Clear? So what do we get? 72 divided by 12. N is equal to 72 divided by 12. So I think 6 we are getting. Answer was already marked, but okay, we have to solve. We should know how to solve. Okay, this is an interesting question, common question. Many times you must have gone through this question. We'll solve it once again. What is it saying? The sum of n terms of two arithmetic progressions are in ratio 3n plus 8, ratio 7n plus 15. Find the ratio of their 12th terms. Oh, how? Sum of n terms of the arithmetic progression is given to me. A good amount of information is given to me, so I should be confident and happy that I can solve this. Sum of n terms of two arithmetic progressions is given to me. Sum of n terms. Achha. Let's say this is Sn, first arithmetic progression, sum of n terms. There are two different arithmetic progressions, no? So both the sums are going to be different, but sum is for n terms only. So can I say sum of n terms for first arithmetic progression and second arithmetic progression? I'm representing it as S dash n. N terms of the first arithmetic progression divided by the n terms of the second arithmetic progression is given to me as 3n plus 8 divided by 7n plus 15. Did you understand this or not? Any problem here? Now, okay, but obviously if there are two different arithmetic progressions, their A and D also are going to be different. Their terms are going to be different, but number of terms are same. N is same, that means the number of terms are same. That is what we have to pay attention at. Now here n by 2 formula. Let's say the first term of this AP is A, so 2A plus n minus 1 and the common difference is D, so I've written like this. And for the other AP which also has n terms, let's say it's okay, I'll call it A1 and D1 and I'll call it A2 and D2, or we can write capital A, any other term, n minus 1 into D2. Okay, this will get cancelled. What are they asking me? Sum of the 12 terms. That means S12 divided by S dash 12. S dash 12 means sum of 12 terms of the second AP. First, sum of 12 terms of the first AP to the sum of 12 terms of the second AP. That is what it is asking me. Okay. So that means what are they asking me? A plus 11D. A1 plus 11D1 divided by A2, which is the first term of the second AP, plus 11D2. This is what they are asking me. How? What do I have? I already have this. This I have as 3n plus 8 divided by 7n plus 15. What idea should click in my mind? See, concept we know, we have written down the information. Now it's about how to manipulate or how to reach to the solution. Now we know, we want to get this. We want to get this ratio. What do we have? We have this. Can we make this look like that? Can we make this look like that? Let's try. Now, first of all, I don't want any 2 multiplied to A1. So what I can do over here, first I'm removing this n by 2. Okay. So what I can do over here is that I'm going to divide it by 2. 1 by 2. I'm going to write 1 by 2 here, and here also I'm going to write 1 by 2. I'm just going to divide it by 2. So when I'm dividing by 2, what do I get? I get A1 plus n minus 1 by 2D1 divided by A2 plus n minus 1 by 2D2. Yes or no? This is what I get. But sir, how does this help? How does this help? That we'll understand. This is 3n plus 8 divided by 7n plus 15. Now, I want this thing. I want A plus 11D. Okay. If I want A plus 11D, can I put some value of n over here to get 11 as this coefficient of D1? Can I put some value for n over here so that I can get 11? Sir, if you do 23 minus 1 by 2, that means 22 by 2, you'll get 11. Okay. Understood. That means I just want to put over here, I'll just put a plus n minus 1 by 2 into d1 divided by a2 plus n minus 1 by 2 into d2 is equal to, which is given to me as 3n by 8, 3n plus 8 divided by 7n plus 15. Okay. So what I'm trying to do, I'm trying to make an 11, the coefficient of d1 as 11. I can easily make it. How I can make it? If I put n is equal to 23, check it. Can we say that if I put n is equal to 23, I'll get this thing, a plus 11 d1, a1 plus 11 d1 divided by a2 plus 11 d2. Will I get this or not? Okay, I'll get. Now put n equal to 23. Now if I'm putting n equal to 23, I have to put it everywhere. I have to be fair with it. I cannot be partial. If I'm putting this side, I'll have to put this side also. Over this side, I'm getting help by putting n equals 23. So I'm getting a1 plus 23 minus 1, 22 by 2, 11 d1 divided by a2 plus 23 minus 1, 22 divided by 2, that means 11 d2 equal to, this is what I wanted. How did I get it? I got it by putting n is equal to 23. So I'll put n is equal to 23 here also, not a problem. If I'm putting here n is n only, right? If I'm putting a value for n, I have to put it everywhere. So here also I'm putting 3 into 23 plus 8 divided by 7 into 23 plus 1. Not an issue. Is there any issue in this? No. Don't get confused. It's very simple to understand. What did we want? We wanted this. We wanted this. I know that I can, from here I can come to this. Only one thing I have to do, I have to put n is equal to 23. If I can do that, I can get, this is what I wanted and I can get this ratio. There you have the ratio. Now, this is what we wanted, right? We wanted a1 plus 11 d1 divided by a2 plus 11 d2, 23 into 3 plus 8. Correct or not? So 23 into 3 plus 8 will get us 77. And what will we get for 23 into 7 plus 1? 126. Am I correct? 176. 176 will get. Right? 7, I think by 11 it will go. 7s and 16. 7 by 16 will be the ratio of 11 of 12th term of the same AP, of these two APs. Did we understand this or not? Okay, easy to understand. Let's move to the next question. See. Okay. Suppose that all the terms of an arithmetic progression, this question is from JEE Advanced 2015. If we, long question, first of all, stay happy, get happy when you see a long question, a lot of information is there. You just have to understand and write down the information correctly. Suppose that all the terms of an arithmetic progression are natural numbers if the ratio of the first 7 terms to the sum of the first 11 terms is 6, ratio 11, and the 7th term lies between 130 and 140, then common difference of this AP will be what? What kind of question is this? 7th term lies between 130 and 140. All the terms of arithmetic, this is an important information, that all the terms are natural numbers. Ratio of the sum of first 7 terms to ratio of the sum of first 11 terms is given to us as 6. Okay, same AP only, not two different APs, it's the same AP only. So can I write a ratio of the sum of first 7 terms? So S7 by S11, right? S7 by sum of first 11 terms, yes. S7 by S11 is given to me. Correct. So this is going to be 7 by 2, 7 by 2 into 2a plus 6d divided by 11 by 2 into 2a plus 10d. Yes or no? This is given equal to 6 by 11. This is given to us equal to 6 by 11. Now, what do we get from here? Achha, 2 and 2 we can cancel, 11 we can cancel here. So, what will we finally get? We'll get 2a plus 6d, 2a plus 6d divided by 2a plus 10d is equal to, this 7 will come down, so we'll get 6 by 7. Okay, not a problem. From here, what are we getting? Any information? We can solve. We can get an expression in a and d. 7 2s are 14a, 12a. So 2a will get, and this will become 42 minus 60. So minus 18, right? So 18d. So is equal to 0. That means a is equal to 9d. Can we say that? This is what we are getting, a relation between a and d. We are getting a relation between a and d, and that's enough. Something we got, right? Now we'll approach what is the question asking us. Now we'll approach towards what the question is trying to ask us. What is the question trying to ask us? Question is trying to ask us the common difference, where the 7th term is between 130 and 140. It is telling us that the 7th term is between 130 and 140 and common difference of the AP is being asked. Okay, 7th term, that means a plus 6d. Can I say that? 7th term or 17th, yes, 7th term is between 130 and 140. Achha, a is 9d, so 9d plus 6d. A is 9d, 9d plus 6d, what are we getting? I think we've got 9d, did we do any? 7 2s are 14a. Correct, a is equal to 9d is correct, not a problem. 7th term lies between, a plus 6d lies between 130 and 140, and a is equal to 9d. So 130, a is equal to 9d if I put over here, this thing if I put over here, what do I get? 9d plus 6d, that means 14d less than 140. Oh, 9d plus 6d, 15d. 9d plus 6d, I'll get as 15d. Now what? Achha, d, what? All natural numbers. One very important information I has told you in the starting, that all the AP is of natural numbers. If AP is of natural numbers, that means A and D both have to be natural. Do you agree with me or not? Do you agree with me or not? Definitely yes. If D is fractional, then terms will come fractional. If all the terms are natural, then definitely A and D are natural numbers. Now what all values can we put for D such that this 7th term comes between 130 and 140. If I put D as 10, 150 I'll get. If I put D as 8, what do I get? 120, no, we are not getting 120. Then if I put D as 9, over here, does that work? 15 into D, 15 into 9, what do we get? 135 we are getting. That means yes, this term is lying between, this is 135, 135 is lying between 130 and 140. That means, simple thing, that means my 15D is equal to 35, my D is equal to 9. That means my D is equal to 9. Only then this term can lie between 130 and 140. Simple to understand. There is no other go. Are we clear with this? Wait, first I equated 7th term, the sum of 7 terms divided by the sum of 11 terms. We got this, we got an equation in A and D, we got a relation in A and D. Then we know that the 7th term lies between 130 and 140. That means the 1 plus 6d lies between 130 and 140. In 1 plus 6d, I already have a is equal to 9d from this relation. And if a is equal to 9d, 9d plus 6d, 15d will lie between 130 and 140. And this should be a natural number. D1, when we put D 1, 2, 3, 4 at 9, when D is equal to 9, then only it is lying between 130 and 140. Simple to understand. If we put D as 8, 120 also will not lie in between them. Let's come to the next. Answer is 9. Okay. For a sequence, if for a sequence Sn is equal to 5n square plus 3n. Now, okay, when we say Tn, that means nth term of an AP. Tn, just write it down, that expression of nth term of AP will always be linear. Can we say that? Be linear in n. The nth term of an AP is always going to be linear in n, and also Sn will be quadratic in n. This will be quadratic in n, and you can see this also. Sum of n terms is given as 5n square plus 3n. Acha, what do we understand? And there is one observation also, we'll talk about it. If I say Sn, what does Sn means? Sn means T1 plus T2 plus T3 plus T4 till Tn. Okay, so if I only sum up this part, that means T1 to, let's say this term I am leaving. So this sum, can I say this sum is going to be sum of n minus 1 terms. So can I say sum of n terms is equal to sum of n minus 1 terms plus nth term. Take any G, like obviously, right, sum of, suppose if there is an AP, okay, let's make one AP, not a problem. Let's say 1, 4, 7, 10, 13, this is an AP. Now, if I want to find 1, 2, 3, 4, 5, sum of 5 terms, if I want to find, fine, sum of 5 terms, minus, suppose if I am doing sum of 5 terms minus sum of 4 terms, sum of all these terms minus these terms, what will I remain with? 13. That means 1 plus 4 plus 7 plus 10 plus 13 minus 1 plus 4 plus 7 plus 10. I will only remain with 13. That means, can I say sum of n terms, and from here also I am getting, that sum of n terms minus sum of n minus 1 terms will always give me the nth term, Tn. Very important relationship. Okay, now here find the nth term of the sequence. Now using this only or this expression, we can find this relation. Using this or this expression, both we can find this relation. One more thing I would like to tell you over here, that why I was saying that the expression of sum of n terms is always going to be linear, because if we observe this, n by 2 into 2a plus n minus 1, n minus 1 into d, right? N by 2 into 2a will give me na, okay, plus n by 2 into n minus 1 into d, okay. So this will become na plus n square by 2 into d minus d by 2, minus dn by 2, right? So can I say n into a minus d by 2 plus n square by 2 into d. This is what we are getting. And here we can observe that the coefficient of d is always equal to n square by 2. The coefficient of d is n square by 2. It is quadratic in n. And the coefficient of n is a minus d. The coefficient of n square by 2 is d and coefficient of n is a minus d by 2. Vice versa, both the things we can say not a problem. Okay, let's come back to the question. Yeah, what was asked? Sn is given as 5n square plus 3n. Now Sn, can you directly tell me from here? Can you directly tell me Sn is given as 5n square plus 3n? Sn is given as 5n square plus 3n. Now, okay, suppose what will be S1? Sum of one term. That means 5 into 1 square 5 plus 3. That means 8. Sum of one term is 8. Sum of one term means first term only. That means A. This is our A. Sum of one term, sum of first term itself will be the first term only. So, A is 8. A is given to us as 8. We found A is equal to 8. Now, sum of two terms. Sum of two terms will be given to us as 2 square 4, 4 5s are 20 plus 2 into 3 6. So, that is 26. This is my A plus D. Correct or not? This is my A plus D. So, what do I understand from this? Can I find the nth term of sequence using this? Can I say S2 minus S1 is equal to T? What is written? Sn minus 1 is equal to An. So, S2 minus S1 will be equal to T2. We can use this also. This is not T2. Is this T2? I have written A plus D, which is wrong. This is not my T2. This is sum of two terms. Right? This is sum of two terms, not T2. Sum of two terms and second term. There is a difference. But what will be the second term? It will be 26 minus 8. That will be my second term. So, second term is going to be 18. First term I got as 8. Second term, that means A plus D I am getting as 18. That means D is 10. Now, I can write the nth term. Tn will be equal to 8 plus n minus 1 into 10. Can't I simply write over here? Any problem? So, it will become minus 10, 8 minus 10 minus 2 and 10n minus 2. We'll get Tn as 10n minus 2. And I already told you that the expression of our nth term is going to be linear, definitely linear. No doubt in that. Thank you, Malika. Thanks a lot. Thanks a lot. Okay, shall we move ahead? Yeah, look, An is any common, any term. Here also if we put T1, what will be T1? 10 minus 2, 8. T2, 20 minus 2, 18. T3, 30 minus 2, 28. 38, 48. Like that it will keep going on. We can check also, not a problem. Common terms of two APs with common differences D1 and D2 are also in AP with common difference is equal to LCM D1, D2. My God. Something complex is written. It feels like something complex is written over here. Something complex is written over here. Do we believe that? Acha, suppose if we have 1, 3, 5, 7, 9 and we have one more AP which is 2, 7, 13, 20. Oh, sorry. There is a common term. It is saying that suppose there are two APs which have two different common differences. Okay. D1 is the common difference of first AP and D2 is the common difference of second AP. Then the common difference of the AP formed by the common terms of these two APs will be given by LCM of first common difference and second common difference. Here can we see that any terms are common. Okay, 7 is a common, term, will there be more terms which will be common? How do we know? What is the common difference over here? What is the common difference over here? The common difference over here is 2. Okay. What is the common difference over here? 7 plus 5 is 12, so it is 5. 5. Right? It will be 5. Now it's saying that 5 and 2 are the common differences. Now if I write this AP a little further, we'll get 11, we'll get 13, 15 and 17. Correct? 17 is also going to be common. That's what exactly this particular observation is trying to say. If we have two different APs with two different common differences, but they have terms in common, then there will be an AP formed in the common terms also. 7, 17, 27, 37, 47. It will be like that. These terms will be common to both the APs. These will be common terms for both the APs. How 10 only I am saying? Because this D1, the first common difference is 2, second common difference is 5, and I already know that the common difference of the AP formed by common terms is going to be LCM of D1 and D2. LCM of 5 and 2 is 10. So this is the AP. This will be the common difference of the two. First term also, let's do a question and understand about this concept a little bit more. Okay. Now 3, 7, 11, 15, 19, so on, 1, 6, oh my god, this pen, 1, 6, 11, 16 and 21. These two are the APs. Okay, AP1 is, let's say this is 3, 7, 11, 15, 19. So next term will be 4 difference is there, 23 will be there, then 27 will be there, and it will keep going on like this. This AP 1, 6, 11, 16, 21, 26, 31, and it will keep going on like this. Now the point is that 11 is one common term. Yes, 11 is one common term, but how do I know the other common term? This is one common term. How do I know the next common term? If I can find the first common term, no, most of the things are sorted for me. Believe me, most of the things are sorted if I can just find the first common term. Achha. So first common term over here is 11. Now what is the common difference of this one? 4. What is the common difference of this one? 5. Next common term will come at after 20. The next common term will come after a difference of 20. That means first common term will be 11. Next common term will be 31. This 31 is already appeared here. It will also be in the first one. Why am I saying? Because the common difference will be the LCM of 4 and 5. 11, 31 and so on. We'll keep adding 20. Right? Find the 10th common term. We just have to find the 10th common term. So for this AP, we are finding T10. T10 means first term plus n minus 1. That means 9 into D. What is D? 20. That is our answer. That is our answer. Any trouble in understanding? Simple thing to understand, right? 11 plus 9 into 20. That means 11 plus 180. 11 plus 180 is going to give me 191. That means 10th common term is 191. Pay attention, what did I do? I knew the first common term. I knew the common differences for both of them. I knew that the LCM of the common differences of both of these is going to give me the common difference of the AP formed by the common terms of these two APs. Right? There will be an AP formed by the common terms of these two APs. Okay. If there are terms common in two APs, then that will definitely form another AP. Okay, remember that, and its common difference will be LCM of the common differences of the two APs. Nothing to worry about. T10 is 191. Okay. Any problem in understanding this? I hope no problem. Now find the 10th term. We simply found that 11 was the first common term, so the common terms will be T10 is, that's what we are getting. Common difference we found as 4 and 5 over here, so 20. That's why we got the terms. Okay. Again, a previous year question. Let's try to solve it. How? Now 3, 7, 11, 15 ... 403 and 2, 5, 8, 11 ... 404 be two arithmetic progressions, then the sum of the common terms in them is equal to. God, how? I don't think much problematic this question can be if you just apply and write the concept clearly. Okay. So 3, 7, 11, 15, this is one AP. 2, 5, 8, 11 and so on, this is one AP. Let me write 3, 7, 11, 15 and till 403, and this AP is 2, 5, 8, 11 and so on till 404. These are the two APs that I have. Now, sorry. Now in this AP, what is the common difference? What is the common difference over here? The common difference is 4. What is the common difference over here? Common difference is 3. First common term. What is the first common term that we have? First common term is 11. Okay, no problem now. First common term if we can find, then there is no issue, right? Issue arises when we are not even able to find the first common term. So if you have the first common term, no problem. The common difference of the AP of common terms, the common difference of the AP of common terms will be equal to 4 LCM of 4 and 3. LCM of 4 and 3, that means 12. And first term, that means A is going to be 11. Not a problem at all. Not a problem at all. Okay. The sum of then the sum of common terms in them is equal to. You just have to find the sum of common terms in them. Now, first term 11, common difference 12. That means next term 23, next term 35 and so on. Right? Common difference 12. It will keep going on. Now they are asking one AP is ending at 403 and one AP is ending at 404. So can there be any common term after 403? Is it possible? Can we say that? No. If the terms are common, even if 403 is a common term, last common term will be 403 only, no? It cannot be more than that. Of this AP, this is the AP of common terms. This is our AP of common terms. Now 11 plus, so how do we write? How do we write? How many, first we need to know how many terms are there. To find the sum of common terms, first we need to know, right, how many terms are possible. So we just need to find out Tn which is less than 403. What will be our Tn? Tn will be 11 plus n minus 1 into d. D is 12. That means 11 plus 11 minus 12 minus 11 minus 12 plus 12n. So 12n minus 1. What do we get? 12 12n minus 1. 12n minus 1 should be less than 403. That means my 12n should be less than 404. That means n should be less than 404 by 12. How much are we getting? 12 3s are 36, 4, 4. 12 3s are 36 again. So this is going to be, n will be less than 33.3333 something. 33 point something. So obviously n has to be natural. So can I say that the number of terms over here, this AP 11, 23, 35, this has how many terms? 33 terms. And now I just need to find out the sum of 33 terms, which will be equal to 33 by 2 into 2a, that means 11 into 2, 22, plus n minus 1, that means 33 minus 1, that means 32, into d, that means 12. Just find it out and we are sorted. What answer will come out to be 157. This will come out to be 157. Please check on your own once again. All the questions, guys, please try that you can revise and solve once on your own. Be it an easy one, be it the one you got, be it the one you did not get, but still try to solve all the questions at least once in your notebooks on your own. See, I have seen many students having the habit of reading and trying to understand. That won't give you anything. That's not going to give you an answer in the examination. Okay, so write, solve on your own, and then, yeah, 157 is the answer. Okay, another question. Advanced, so what? Yeah, one thing, advanced question will look very horrible. But again, they'll have enough information. If we can interpret the information and work accordingly, we can easily find the answer. What is it saying? Let AP be of A and D. There is an AP which has first term A and D as common difference. Infinite arithmetic progression with first term A and common difference D greater than 0. D is greater than 0. Increasing AP. Okay. AP 1 and 3. 1 and 3 means 1 is the first term and 3 is the common difference. I am writing AP 1. So 1 is the first term and 3 is the common difference. That means next term 3 is the common difference. Right. So next term will be 4, then 7, then what do we have? 10, then 13, and it will keep going on like this. Okay. Then AP2, there is another AP. What is this AP saying? First term 2, common difference 5. So first term 2, common difference 5, 2 plus 5, 7, 7 plus 5, 12, 12 plus 5, 17, 17 plus 5, 22, and it will keep going on like that. Now AP3, what is AP3? AP3 is first term 3 and common difference 7. First term 3 and common difference is 7 over here. Are we getting it? 3 and common difference is 7. So 3 plus 7, next term will be 10. Then next term will be 13. Then next term will be 13 plus 7, that means 20. Can you tell me any first term which is common in all the 3 APs? Do you have any term which is common in all the 3 APs? Can you give me any term which is common in all the 3 APs? Come on, try to find it out. Take a minute and try to find it out. Any term which is common in all the 3 APs. This is first AP with first term A, first term 1 and common difference 3. This is second AP with first term 2 and common difference 5. Now, which will be the first common term to these 3 APs? How will we find it out? Even write some more terms if you want to, but try to find if there is any common term which you are able to find in these APs. No, sir, we are not able to find. Okay, but we can assume, right? We can say, what can we say? That let me say, what can we say? Let me say. M, let's say there is some M term which is there in his AP, and there is some N term which is there in AP2, and there is some R term which is there in AP3. Obviously, because first term will not be able to find out like this. If we keep writing it, what if D is very, very big? We'll have to write a lot of terms, then we'll come at first term. Although the common difference of new AP, common difference of common terms AP. What will be the common difference of common terms AP? What will be the common difference of the new AP of common terms which will be formed by common term? That I can find. Why? 3, 5 and 7. LCM of 3, 5 and 7. That will be the common difference of new AP. Just now we learned, right? The common difference of the AP formed by common terms of 2 or 3 APs will be equal to the LCM of the common differences of the APs which we are using. So LCM of 3, 5 and 7 we are going to have. 3, 5 and 7 LCM will be equal to 105. Okay, but what about the first term? Still we are not able to find the first term. First common term if we don't have, we cannot do anything with 105. Okay. First common term. I am saying, let's say there is some mth term which is equal to nth term which is equal to rth term. There is some mth term of AP1 which is equal to nth term of AP2 and which is equal to rth term of AP3. Okay. That means for this, for mth term of AP1, that means A plus m minus 1 into D, that means 3, will be equal to A 2 plus n minus 1, which is the nth term of this AP. What is D here? 5 plus A plus, that means 3 plus r minus 1 into D which is 7. Now can these be equal? How to make them equal? Now I want a value which is going to give me natural numbers for all the three. Why? Natural numbers for m, n and r. Why? Because m, n and r are the positions. So what I'm going to do, simple thing, you can just try this technique. Whenever you have such a situation, write any one variable write the other variables in terms of any one variable. For example, if I want to write m in terms of n and r in terms of n. So if I want to write m in terms of n using this, what am I getting over here? 1 plus 3m minus 3. So 3m minus 2 is equal to 2 plus 5n minus 5 minus 3. So 5n minus 3. 5n minus 3. So this will give me minus 2 will go that side and m will come out to be 5n minus 3 plus 2, 5n minus 1 by 3. M will come out to be 5n minus 1 by 3. This will be my value of m in terms of n. Now in terms of r, can I do the same? In terms of r, can I do the same thing? Let's try. So 2 plus n minus 1 into 5, that means 5n minus 3 is equal to 3 plus 7r minus 7, that means 7r minus 4. Now r in terms of n, so what do I get? 5n minus 3 plus 4 and minus 7r. So 5, I can say r is equal to, I can say 5 correct or not? 5n plus 1 by 7. My r is also in terms of n now. Now I just need to find an n for which m and r both are natural, and n I'll put obviously as a natural number. If I can do that, then I can say that mth term, nth term and rth term of these three APs are equal. That means the first common term. That means the first common term. What if I put n is equal to 1, 5 minus 1, 4 by 3. M is coming 4 by 3. M cannot be 4 by 3, it's a position. N equal to 2, 5 into 2, 10 minus 1, 9 by 3. M is equal to 3. Okay, no problem. If I put n is equal to 2, I am getting m is equal to 3. But if I am putting n is equal to 2, I am getting 10 plus 1, 11 by 7, which is not natural again. R should also be natural. Now start putting n with the gaps of 3. Don't put all the natural numbers. Look at this denominator and now you put your n's, the values of n with the gaps of 3. You put 1, now you put 4. 5 into 4, 20 minus 1, 19 by 3. Not getting. Now put, after 4 put 7. 5 into 7, 35 minus 1, 34 by 3. Not working. Now after 7, 7 plus 3, 11 you will put. So 5 into 7, 5 into 11, 55 minus 1 by 3, 54 by 3. 54 by 3. What is 54 by 3? 18. That means when n, can I say when when my n is equal to 11, my m is coming out to be 18. Right? When n is 11 here, 55 minus 1, 54 by 3, m will come out to be 18. But I didn't check over here, I just wrote directly. Let's check. Is it coming? Yes. 55 plus 1, 56 by 7 is also a natural number. That means R will be 8. That means 11th term of this AP, 18th term of this, 18th term of this AP will be equal to 11th term of this AP and will be equal to 8th term of this AP. Now you can find the first common term very easily from any of these three. From any of these three. That means either I'll find the 11th term of this AP or I'll find the 18th term of this AP. M is 18, right? Or I'll find the 11th term of this AP, or I'll find the 8th term of this AP. So 8th term of this AP we can find 3 plus, here we can simply find the 8th term, T8 of this AP will be 3 plus 7 into D. What will be D? D will be 105. D will be 105. That we know, right? D is going to be 105. So that is my 8th term. What will be the value of 8th term? First common term. First common term. No, I'm sorry. We have put something 105, no, right? The common difference over here. We have put 105, the common difference of the 3 APs. We have to put common difference of this AP, right? We cannot put the common difference of the AP formed by common terms. So 3 plus 7, 8 minus 1, that means 7 into D. D for this one only. That means 7. Right? That means first common term. Right? First common term. This is 49 plus 3, 52. That means first common term. We got the first common term as 52, and you can even check the 11th term of this AP will also be 52, the 18th term of this AP, 18th term of the first AP will be 52, 11th term of the second AP will also be 52. Do we understand that? Simple to understand. First common term we got as 52. Now what? We got the first common term. We got the first common term 52. Common difference is 105. Right? This is our A, and what is D? D is 105. What is the question asking us? What is the question asking us? Question is asking us A plus D only. So 105 plus 52, that means A plus D, that means 105 plus 52 will give us 157. That will be our answer. Easy to calculate, nothing we did. It was just about finding the first common term. It is just about finding the first common term. Remember this question, practice or revise this once again. If you have solved it, that's okay. But here the point or the main thing which we learn is how to find the first common term. If we are not able to find the first common term, then we cannot proceed. In the 3 APs, we can find the common difference by finding the LCM. But sometimes first common term itself might not be available. Okay. Arithmetic progression, main and major and key points. What are the key points or the major points of an arithmetic progression? Key points of an AP. Key points of an AP. First key point you know, right? Any term, any nth term minus n minus 1th term. Any term of an AP minus its previous term. What will it give me? It will give me common difference. This is the major point. Right? It is going to give me common difference. Common terms of 2 APs form an AP. Always remember, we learned this just now, that the common terms, if there are common terms in 2 different APs, then those common terms is also going to form an AP. Simple to understand. Second thing, if A1, A2, A3 are in AP, if A1, A2, A3, these terms are in AP. If I multiply something with all the terms, if I multiply any number, non-zero number, if I multiply any number to all the terms, then this will also form an AP. I have multiplied K to all the terms. That will also form an AP. Very important thing, sometimes it is applied. If I add or subtract some constant from all the terms, for example, if I have an AP 1, 3, 7, 5, let's 1, 7, 13, 19, 25 and so on. Correct only I have written, right? 7 plus 6, 13, 30. Now, if I add 2 in all the numbers, suppose I am adding 2 in all the numbers, 2, 9, 15, 21, 27. These are also in AP. What was the common difference here? 6. What is the common difference over here? 7. Correct. So this is also, if we add or subtract a term in an AP, a constant term in an AP, then that is also going to form an AP. Some of the terms very important thing, this is very important, please pay attention at this. Some of the terms equidistance from beginning and end is same. Some of the terms equidistant from beginning and the end, both the sides. Suppose if I have T1, T2, T3, T4, T5, T6, T7. Okay, then sum of T1 and T7 is going to be equal to sum of T2 and T6, and it is also going to be equal to sum of T3 and T5. Sum of the terms equidistant. This is the first term. Equidistant means first term and from the end first term. First term from the beginning and first term from the end will have the whatever sum they have, that sum will be same to the second term from the beginning and second term from the end. Simple to understand. Some of the terms equidistant from beginning and the end are same. Very important. Now what about the middle term? They'll be equal to the twice of middle term, right? This will get doubled. T4 just will get doubled. Okay. If you must be thinking in case of even terms, there'll be 2 terms over here, right? So not a problem. Here in this case, 1 term, so it will be doubled. Now assuming how to assume the terms. Suppose you are given in a question that there are 3 terms whose sum is given to you and product is given to you, or there is some information about given to you about 3 or 4 or 5 terms of an AP. Now, although we know that first term is going to be A, then A plus D, then A plus 2D, then A plus 3D, we know. If you want to choose, sir, if you want to choose the terms, then why do we have to take some different, these type of expressions? We already know, right? A plus D, A plus 2D, A plus 3D. But the problem is that when we'll deal with this, we'll get an equation in A and D, right? Which will be difficult to solve. But suppose if we use these terms, that means if we want to use 3 terms, then we use, if we want to use 3 terms, and in that case, we'll use A minus D, A plus D. Yeah, their common difference, A minus D, D. A plus D minus A, D. The common difference between these 2 is D. Common difference between these 2 is also D. You can check. Here, common difference between, now, when choosing 4 terms, while choosing 4 terms, sir, we could have written just like we have chosen 3 terms. No, we could also choose 4 terms. What a problem? A, then A minus D, then A plus D, then A plus let's say 2D. First of all, common difference. If you will put A plus 2D over here, and when you will add all of this, what benefit are you getting? What I am trying to say, when you will add these 3 terms, A minus D, A plus D, what are you getting? Minus D plus D is getting cancelled and 3A you are getting. 3A will be equal to something. Sum will be given to you, now, right? Sum will be given to you. If sum will be given to you, then 3A will be equal to something, right? So you'll directly get an equation in A. D should get cancelled. That is why we are taking the terms like this. If 3 terms are asked, then A minus D, A plus D. If 4 terms are asked, A minus 3D, A minus D, A plus D and A plus 3D. Remember this, know this, and you have to use these terms only if some of the terms are given to you. Right? If 5 terms, then A minus 2D, A minus D, A plus D, A plus 2D. Yeah, these are the specified terms. This you should take. Why? Because D is getting cancelled, only A is remaining, and one more thing, the common difference is same. Common difference is same. A plus D minus A is also D, and A minus D minus A minus 2D is also D. That is also there. Don't just randomly take. Suppose you take A minus 2D, A minus D, A plus D and A plus 2D. Can we do this? 4 terms. What is the difference here? What is the difference here? A plus D minus A plus A plus D minus A minus D. That means 2D. And what is the difference here? D plus 2D, 3D. No, common difference is not same. That means we cannot do this. Okay, so don't just randomly take these terms only if some of the terms of an AP is given to you. The digits of a positive integer having 3 digits are in AP. Wow. We must have done these type of questions, you know, in our junior classes, where we have to form a number, right? Where we have to form a number. Suppose 493 is formed by 4 into 100 plus 10 into 99 plus 3 into 1. Okay, so 3-digit number, if 3-digit number has, let's say, X, Y and Z as its digits, then it will be 100 into X plus 10 into Y plus Z into 1 plus Z into 1. Okay, this is the information we need to know to solve this question, not a problem. Now, what is the question saying? Question is telling me the digits of a positive integer having 3, of a positive integer is positive. Okay, having 3 digits are in AP. If the digits are in AP, let the digits of the number be A minus D, A plus D. Okay, let these 3 be the digits, and the sum of these 3 digits is given to me. That means A minus D plus A plus D is given to me. That means 3A will be equal to 15, and it gives me A is equal to 5. Simple, directly. That is why we are using these terms. Remember that. Okay, now A is equal to 5. Now second information, long question, lot of information, happy, good, no problem. Second information is saying that the number obtained by reversing the digits is 594 less than the original number. Number obtained by reversing the digits. That means number obtained will be 100 into A plus D plus 10 into A. Originally these 3 are the digits. Reversing, number formed will be this one. Plus 10 into A plus A minus D will be 594 than the original number. What will be the original number? Original number will be 100 into A minus D plus 10 into A plus A plus D. 1 into A plus D, that means this, minus 594. 594 less, so it will be 594 less than the original number. Now you have the equation in A and D, where A you can simply put as 5. Why do so much of problem? 5 plus D plus 10 into 5 plus 5 minus D is equal to 100 into 5 minus D plus 10 into 5 plus 5 plus D minus 594. This is one equation you have got in terms of D. Now you can simply find the value of D. Can you tell me the value of D? D should come out to be, let's see, minus 3. D will come out to be minus 3 over here. Right? When we get D, find the number. That means 5 minus D. 5 minus 3, 5 minus minus 3, or 5 minus minus 3, then A is 5 and 5 plus D, that means 5 minus 3. So this will become 8, 5, 2. Number will be 852. Find the number. Number is going to be 852. Can we simply understand this? Right? Information, interpreted the information, solve the question. Nothing different or advanced we are doing. We are just trying to understand the information carefully, interpreting it and writing it down to solve the question using the concepts. Brain obviously will have to use. There is no other go. Right? Brain definitely will have to use. Without that, I don't think anything can be done. Now, the digits of a positive integer having 3 digits are in, this question we have done. Again, a question from advanced, a question from JEE Advanced. The sides of a right triangle are in arithmetic progression. If the area of triangle has area 24, then what is the length of its smallest side? What information do we have? The sides of right angle triangle are in arithmetic progression. Let the sides be A minus D, A plus D. Correct? Can these be the sides? Yes, these can be the sides because sides are in AP. So I have to choose 3 terms in AP. I chose 3 terms in AP. A minus D, A plus D. Not an issue so far. Now, these 3 terms are in AP and these 3 are also the sides of right angle triangle. What does that mean? Acha, longest side, can I say A plus D? Can I say longest side will be A plus D? Why? Because if now, D has to be smaller than A. One more thing I can say over here, that D has to be smaller than A. D will be smaller than A. And why am I saying that? Can you tell me? I am saying that because if D is not smaller than A, then this side will become negative, which triangle side cannot be negative. Now what we can do? We know the information, the thing that we know is Pythagoras theorem. If the area of triangle directly if we'll apply, we'll get an equation in A and D. We want 2 equations. So first, we'll use the right angle triangle. That means we'll use the Pythagoras theorem. That means my A plus D hypotenuse square is going to be A minus D whole square plus A square. Yes or no? Right? And when I solve this, A plus D whole square minus A minus D whole square will be equal to A square. This will become A plus D whole square minus A minus D whole square, which will be equal to A square. So, what are we getting? A square, we'll get A is equal to 4D. We'll get 4D is equal to A. This is what we're getting. We'll get A is equal to 4D from this. And once we get this, we can find the area of triangle also. What is the area of triangle? Half into base into altitude. Now, these 3, if A is equal to 4D, can I simply write the sides? A is equal to 4D. So, 4D minus D, 3D. Correct? A is equal to 4D. This will be 4D. This will be 5D. The 3 sides are going to be 3D, 4D and 5D. 6D, 7D also has come into the world nowadays. But yeah, till so far we'll work just with 3D, 4D and 5D. Now, area of triangle, 3D, obviously 3D, 5D is going to be the largest, right? So, 5D will not use, half into 4, 5D will be the hypotenuse. So, base and altitude will be 4D and 3D. And this is given equal to 24. Come on, if there is any doubt or anything which you want to ask, please ask me. Sir, kabhi aap AP kabhi samajh nahi aaya. Okay, you'll understand now. Don't worry. Okay, don't worry. Try to understand. See, anything you have to understand, you have to put in effort. Don't just believe that God will or a fairy will come to you, will just, shovel a stick and you'll get everything. It's not magic. You have to actually work with the questions, understand the concept and practice some amount of question. Then mathematics is not only on theory, right? Theory you have to understand, but application of theory, whatever you have learned, you have to apply it several number of times, then you get a good hold on it. Then you get a confidence on that particular chapter. For example, if I ask you, how confidently can you apply Pythagoras theorem? You can say, sir, very easily we can apply Pythagoras theorem, because you have practiced it a couple of times. Okay. Now, 2, 3 2s are 6, 6 d square is equal to 24, d square is equal to 24 by 6, that means d square is equal to 4. That means my d can be what? 2 or minus 2 also. Can d be minus 2? No, d cannot be minus 2, right? Can d be minus 2? You tell me, this is equal to 24, right? D cannot be minus 2. Sides, no? Sides. Now, my d square is equal to 4 and d is equal to 2. What was asked? Find its smallest side. Find its smallest side. That means the three sides are just going to be 3d, 4d and 5d. That means I can say that sides are going to be 3 into 2, 6, 4 into 2, 8, 5 into 2, 10. Smallest side will be 6. The smallest side is going to be 6. Okay, any problem till here? Any problem in this one? The smallest side will come out to be 6. Okay, I've written my handwriting, I'm just trying to improve, guys. Don't mind. The students that know me already know that I've been struggling from quite a while with the handwriting. So that's something which is still worked upon. So D is going to be 2. Okay, let's move ahead. Next question. Again, a question from advanced. If A1, A2, A3, A4 till AN are in AP and A1, A4, A7, A16 is equal to 114. This question has repeated, or maybe this information I have not put correctly. I'll update it and I'll send. Yeah, this question has also repeated recently in the JEE exam, maybe mains. Okay, A1, A2, A3, A4, AN till AN there is an AP, and in this AP, A1 plus A4 plus A7 so on till A16 is 114. Acha, what do we know? Sir, we know the sum of AP, we know the common term of AP, we know the common difference, we know the sum of n terms of AP, we know some properties that if we multiply and divide, anything is not working. But what is given? This is something which is giving me an indication that I should use the idea of equidistant terms. How? Because let's open this, let's write this completely. A1 plus A4 plus A7 plus A10 plus A13 plus A16 is equal to 114. Correct? No, these two terms are missing only. For that they have put dot 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 just to confuse you. If they had written it like this, no, you'll be better, you'll have a better understanding. Correct or not? If they can write it, if they would have written it this way, you'll have a better understanding of this. Why? Because see, first term, 16 is the last term, equidistant term, not last term. Let's say these many terms are there only in the AP. We are only considering the AP till from A1 to A16, right? So whatever will be the sum of A1 and A16, that same will be the sum of A4 and A13. Yes or no? A4 means fourth term from the starting. 13 means 16, 15, 14, 13. Fourth term from the end. And you can also say A4 is fourth term from the starting. There are total 16 terms. So from the end, it will be 16 minus 4 plus 1. That means 13th term. Fourth term from the end will be 16 total terms minus 4 plus 1. Fourth term from the end will be 16 minus 4 plus 1. that means 13. So 4th term from the end will be 13. Now similarly 7th term from the starting is A7 and 7th term from the end will be 16 minus 7 plus 1, that means 10. That means these are also equidistant. So whatever will be A1 plus A16 will same be A4 plus A13 and that same will be A7 plus A10. So for this big sum, can I just simply going to write this same thing 3 times, right? This same thing 3 times. So 3 times of A1 plus A16 is equal to 114. What is it giving me? It is giving me A1 plus A6, A16 is equal to 38. Simply, I got A1 plus A16 is equal to 38, and if I am having A1 plus A16 is equal to 38, this thing is also solved. A1 plus A16 is 38. 6th term from the starting end will be 11th term. 16 minus 6 plus 1, right? 6th term from the starting will be equal to 6th term from the starting will be A6. So 6th term from the end will be 16 minus 6 plus 1, that means A11, right? So the sum of these two will be equal to the sum of these two. So what I can simply write, I'll write over here only. So I can write 2 times of A1 plus A16. That's all. Sorted. That means 38 into 2, that is 76. Are we clear at this? Advanced question from, it's not necessary that every question is going to be difficult only. If you can write, interpret and understand what is the question trying to tell you. Always there will be information in the question, and the question does not always want you to calculate a lot. It wants you to put your brains in and use the concepts. That's it. Not any rocket science is going to be there in this. Nth odd number is, now some simple notes that we have. This we already spoke about, this we already have spoken about and talked about, that nth odd number, any nth odd number, the nth term for an odd number sequence is going to be 2n minus 1, and sum of first n odd numbers is always going to be n square. This thing you must have studied in your earlier classes also. For example, 1 plus 3 plus 5 plus 7 plus 9. The sum of first 5 odd numbers will be equal to 5 square. Sum of first n odd numbers will be equal to n square. Any nth odd number, if we put n is equal to 1, we get 1. If we put n equal to 2, we get 3. If we put n equal to 3, we'll get 5. So, right, this is the general form. Now, about the next progression, we are going to study about general highlights. You know about the AP. Many questions we have observed in JEE exam from arithmetic progression specifically. So understand and practice this part also very carefully. Many of you think that, no sir, this part we have read in 10th class, so this is not going to be that difficult. But yeah, it can be difficult if you have not practiced enough. Now, next thing, geometric progression. Geometric progression, another type of progression. Sequence of the form AR square. For example, if I just write 1, 2, 4, 8, 16, 32, 64 and so on. This is a geometric progression. What is good? What is the thing to note down about geometric progression? Achha, geometric progression, AP you have already studied in your earlier classes. Geometric progression might be new to you. Many questions are asked from this part also, so pay attention, stick tight, keep listening. Okay. So, what is common over here? Obviously, the difference is not common, but something else is common. What is common? Ratio is common. 2 by 1 is 2, 4 by 2 is 2, 8 by 4 is 2, 16 by 8 is 2, 32 by 16 is 2, 64 by 32 is also 2. So, first term if I am writing as A, second term, if I am writing first term as A, common ratio, R over here is the common ratio. The R over here is going to be the common ratio of GP, that means geometric progression. That means the terms are going to be A into R, then A into R into R, that means AR square, then A into R into R into R, that means AR cube. First term is A, second term is AR, third term is AR square, fourth term is AR to the power 3, AR cube. So any nth term is going to be AR to the power n minus 1. See, fourth term is AR cube. So nth term will be AR to the power n minus 1. That's all. This is the nth term of a GP. Any nth term. First term A, common ratio R. If I take first term as A and common ratio as R, then the nth term of my GP is going to be AR to the power n minus 1. Nothing difficult to understand over here. Okay. Now, sum of GP. How will we find? Nth term we could find. Simple questions also we can do, like for suppose this one only. If I asked you find the 18th term of this AP. If I ask you what is the 18th term of this AP itself, then 18th term will be A. That means 1 into R. That means 2 to the power 18 minus 1. That means 17. That means 2 to the power 17 will be the 18th term of this AP. Of this GP. Sorry. Now, next part. Finding the sum. An, that means nth term we got. Now, finding the sum of n terms in an GP. That means sum of n terms. That means I want to add A, AR square, AR cube. Now, the approach which we are going to use, this approach we are going to use further also. The approach which we are going to use to understand the sum of a GP is going to be used further. So, stick tight. Now, sum of n terms is equal to is equal to the sum of all these terms. What am I going to do is, I am just going to multiply R in S of n. I am just going to multiply this entire thing with R. So, this will become AR. Now, if AR I am getting, what I want to do is, do you get the feeling, if I am getting A into R as AR, then AR should be written over here, no? Just beyond this. Why to create a hustle? Why to create a mess? Right? Simply I am just writing AR below this term. So, R into S and AR plus R into AR, that means AR square. R into this AR. R into this AR, that means AR cube. Correct. So, R into this one. Now, one term I have shifted one term. So, here also I have to shift A into R to the power n minus 1 into R. That means AR to the power n. Can we say that? Can we say that? Now, what am I going to do? I am going to subtract the two equations. If I am subtracting Sn minus R times of Sn, this will become Sn multiplied with 1 minus R, and this will be equal to A minus 1. If I am subtracting this side also I will have to subtract. So, A minus nothing, there is nothing for A. I am not subtracting A with anything. So, what do I do? A minus what? A minus nothing. So, A only. AR minus AR, 0. AR square minus AR square, 0 again. Oh, very good. We are loving it. We are loving it. Try to understand. Oh, see. What am I asking you? Just multiplied this with R, shifted all the terms. Now I am subtracting. So, A minus nothing will be A only. AR minus AR 0, AR square minus AR square, AR cube. All these terms are getting cancelled. This term also will get cancelled because the previous term will be AR to the power n minus 1. Right? But this term will have a negative sign here. Right? So, what will I have? A minus, this will be, this is subtracted. So, there will be a negative sign here. A minus AR to the power n. So, sum of n terms is going to be A into 1 minus R to the power n divided by 1 minus R. Or you can also write it like this, A into R to the power n minus 1 divided by R minus 1 if we take minus common. Correct? Not a problem at all. Sum of n terms is given by A into 1 minus R to the power n divided by 1 minus R. Here R cannot be equal to 1, will create a 0 here. So, R is not going to be equal to 1. Now, one more important thing which we will talk about with the questions. is sum of infinite terms in an AP, in a GP. There can be infinitely many terms in a GP, right? There can be a GP which has many terms. But if there are many terms and if I am adding them up, many terms means terms equal to infinity, and if I am adding them up, then sum should be infinity only, no? What do you think? Sum should be infinity only. No, I think sum should be infinity. If I am adding all the terms of a GP and infinite terms are there, then sum should be infinity. But no, it can be defined if it is a decreasing DP and R, decreasing GP, and R is between -1 and 1. Mod R less than 1 means R is between 1 and -1. In this case, we'll be able to find the sum of infinite terms also in a GP. Why? Because this will become 0. If R is between -1 and 1, R is between -1 and 1, that means 1 by something or -1 by something. 1 by R to the power infinity will be infinity, 1 by infinity will become 0, and this is how sum of infinite terms, this part will become 0, R to the power n will become 0 if R lies between -1 and 1 and there are infinite terms, n is equal to infinity. In that case, what will happen? I'll get A into 1 minus R to the power n, 1 minus 0, 0 only. So, A upon 1 minus R. This happens only when R is between -1 and 1. Simple to understand. Okay. Did you understand why infinite terms can only be defined if R is between -1 and 1? Because if R is greater than 1, let's say, greater than 1, then anything greater than 1 to the power infinity will be infinity. A very big number that we cannot find. Answer will come out to be infinity. If it is beyond -2 or -1 also, then also we cannot solve it. We can only answer for infinite terms when R, the common ratio, is between -1 and 1. Any problem to understand? Okay. Next thing. If A, B, C are in AP, very important thing, then 2B is equal to A plus C. We already know this. Why? Because if A, B, C are in AP, we know B minus A is equal to C minus B. So, from here can we say 2B is equal to B plus B, 2B, C minus A. C plus A, that means A plus C. Can we say that? We know that if A, B, C are in AP, then difference here and difference here is going to be equal. So, we are going to have 2B is equal to A plus C. Similarly, if three numbers A, B, C are in GP, if A, B, C are in GP, then their ratio is going to be equal. That means B by A is going to be equal to C by B. This gives me B square is equal to AC. Or I can also say B is equal to square root of AC. Right? This is what we'll get. Very important thing. This is something which is going to be used in many questions and many other concepts also. So, please pay attention. 2B is equal to A plus C is for AP. If A, B, C are in AP, then twice of B or A plus C by 2 will be equal to B, or twice of B will be equal to ABC. If ABC are in GP, then B square is equal to AC. That means square of the middle term will be equal to the product of the extreme terms. No term of a GP can be 0. Can a term of GP be 0? Come on, tell me. Can a term, what happens if I make a term of GP be 0? Can I make a term of GP be 0? No, Baba. Don't make that mistake. If you make a term of GP is 0, that multiplied with any term will be 0. All terms will become 0. There is no point only. So, no term of a GP can be 0. Remember that sometimes what you will get is 2 answers for R. Generally, we form a quadratic in R. So, you will get 2 answers. In that case, you have to reject one of the answers which can be 0. Okay. Next thing. Come on, let's solve this. First term of a GP is -3 and second term is equal to the fourth term. Simple, easy question. Let's begin with easy question. Solve this, try this on your own once. Okay, first term of a GP is -3. That means A is equal to -3. Can I say that? A is equal to -3. and second term is equal to fourth term. That means A2 is equal to A4, or can I directly write second term? Second term is AR. Fourth term is equal to AR to the power 3. First term is A, second term is AR square, third term is AR, first term is A, second term is AR, third term is AR square, fourth term is AR cube. So, fourth term will be AR cube, nth term is AR to the power n minus 1, fourth term will be AR cube, second term will be AR. These two are equal. What do we get? A cancelled. Should we cancel AA? Simply. The first term of a GP is minus 3. So, and second term is equal to the fourth term. What should we do? If we'll cancel A and A, does that benefit us somehow, anyhow? Does that? Is it going to benefit us somehow? If I cancel A and A, can I cancel? But it cannot be. What if it's 0? What if it's 0? Can a term of AP be 0? No. Right, here also we can use that concept. So what should I do? Come on, try it once on your own. Find the 7th term. Give me the answer in the chat box. Find the 7th term of this AP. First term is minus 3. I think here there is a problem, and the square, this should be a square, otherwise that is why we are getting this problem. Right, we have a square here. The square of the second term, that means AR whole square is equal to fourth term, that means AR cube. This is what we have. My bad. Okay. So what do we have? A square R square is equal to AR cube. This A will cancel, 1A. This R will cancel, only 1 R will remain. So what do we have? A is equal to R. Can we say that? A is equal to R. If A is equal to R, then R is also equal to minus 3, because A is minus 3. Find the 7th term. 7th term, that means T7, or we should say T7 or A7, anything. T7 will be AR to the power 6. That means minus 3 into minus 3 to the power 6. That will be our answer. Minus 3 to the power 6 will be 729, positive, right? So minus 3 into minus 729. Calculate this. This should come out to be minus 2187. Minus 2187 will be our 7th term. Okay. Yeah, this was square of the second term. Okay, x 2x plus 2, 3x plus 3. Next question, x 2x plus 2, 3x plus 3 are the first 3 terms of GP. Then find the 4th term. The first 3 terms this time are given to me. We have to find the 4th term. First 3 terms or any 3 consecutive terms. That also I can say, right? X, 2x plus 2 and 3x plus 3 are the first 3 terms of GP. Now, what should I do? Because I can take that this is A, this is the first term, there should be something multiplied in the first term, then I must be getting 2x plus 2. Now, what should be my idea for solving this question? Idea should be, if this is the case, that means the question wants you to apply B square is equal to AC. If it is giving you 3 terms in a GP and finding some nth term, that means most probably it is asking you to apply B square is equal to AC. Simply square the middle term, that means 2x plus 2 whole square is equal to x into 3x plus 3. That you can do. 3x square plus 3x. Right, now you can solve this will form a quadratic equation in x. Can we solve this? Right, let's say 4x square plus 4 plus 8x is equal to 3x square plus 3x. So this is what we are getting. We'll be getting a quadratic in terms of x, And if we have x, then we can put these values, we can find the first term, we can find the common ratio, and we'll find the fourth term eventually anyway. So 4x square minus x square, 8x minus 3x, 5x plus 4, right? Right, equal to 0, right? Everything we shifted. So x square plus this will become 4x plus x. So I can write x into x plus 4 plus x plus 4 equal to 0. So I can have x plus 1 or x plus 4 equal to 0. So either x can be minus 1 or x can be minus 4. So what can be the terms? If x is minus 1, then minus 1, 2 into minus 1 plus 2, 0, and 3 into minus 1 plus 3, 0. Can 0 be a term of this AP? Any AP, any GP? No. So that means this value we cannot use. Now use minus 4. Minus 4, this will be rejected. Minus 4, that means x is minus 4. First term is minus 4. Minus 4 into 2, minus 8 plus 2, minus 6. And 3x plus 3, that means minus 4 into 3, minus 12 plus 3, minus 9. Minus 4, minus 6, minus 9 are the t terms of this GP. This we are rejecting because 0 is coming, and 0 is coming, that means we cannot use this. Next question, very interesting question. Here we'll get to use a expression or factorization technique, we'll get to use. So what is given in a GP? We have A1 plus A2 plus A3 is equal to 13, and A1 square plus A2 square plus A3 square is equal to 91. You have to find R. What do we do? Simply write A1. What information do we have? What thing we know? When we are given A1, A2, that means first term, second term and third term is given to us. If first term, second term and third term is given to us, I am just simply going to write first term as A. I'll simply write first term, let's say this is A, right? This is A. Then A2 will become AR, A plus AR. A3 will become AR square, right? Simply I can write this, right? This will become AR square. Now sum is given as 13, and here what do I have? Square of these only. So A square plus A square R square plus A square R to the power 4, this is given to me as 91. We have to find R. Now what is the idea for finding R? We have two equations, we have two variables. We can use some technique, or we can manipulate, and we can get to R, but it will take a lot of time. Smarter approach says that if this is given, no, that means A, AR and AR square is there. So what we can do is that I'll take A as common over here. If I take A as common, 1 plus R square I am getting, right? And sorry, and here I am getting, if I take A square as common, then I am getting 1 plus R square plus R to the power 4. And look what is written here. This you can derive also, but for now just understand and learn this. You can derive also, I can tell you how to derive this, but for now just understand this. Now this is 13, this is also given to us. What I can do is, I can square this. Can I square this one? If I square this, then I'll have square here and square here. And this side also I'll have 13 square. Divide this. Why would I divide this? Because A will get cancelled, right? So this will be 13 square divided by 91. Correct. So A square got cancelled. What do I have? R to the power R square plus R plus 1 divided by R to the power 4 plus R square plus 1 is equal to 169. 13 square divided by 91. Oh. Now what to do? Still, sir, now we'll use this thing. Now we are going to use this. You must be thinking, sir, still what is the use? We still have a biquadratic in R. We'll reduce it using this thing. We have to, ultimate idea should be reducing it, and we are going to reduce it using this particular identity, you can say, or a derivation, you can say, factorization, you can say. X, when we have x to the power 4, this expression and this expression, r to the power 4 plus r square plus 1, this and this are looking same, isn't it? Yes or no? Yes, they are looking same. If they are looking same, then I can do some manipulation. What I can do is, I am going to, in the numerator I have r square plus r plus 1. In the denominator, r to the power 4 plus r square plus 1 can be written as r square plus r plus 1 multiplied with r square minus r plus 1. So this and this is going to get cancelled. That is why I am factorizing. And this is equal to 169 by 91. Does it get, can we cancel it? 169 by 91. Tell me in the comment section if we can cancel it. 169 by 91. 7 and 13. 13 by 7, kya? I think 13 by 7 it will go. 13 are 169 and 91, 7. So ultimately what do we have? 1 by r square minus r plus 1 is equal to 13 by 7. We got a quadratic in R and we are sorted in peace. That's what we wanted, right? To find R, we want a quadratic in R. Nothing else do we want. Nothing else we want. We wanted a quadratic in R. Biquadratic was there. We used factorization to do this. Now I can tell you how to factorize this also, but first tell me, did you understand this? So 7 is going to be equal to 13 plus 13r square minus 13r. Oh, I'm sorry. One mistake we have done. What mistake we have done is that we did not square. Right? There is a problem here. This is the, this is the disadvantage of not having comments in the chat. You could say, right, this is squared. Why am I cutting this completely? This won't be cut. This won't be gone completely. This we'll still have over here. We are going to have this factor. One factor, r square plus r plus 1 will still be here because this was squared, right? So only one. This was squared. So only one got cancelled, not the entire thing, right? Not the entire thing. Right. So we have this one. Now on solving this, tell me what are we getting? How can we solve this? We can solve this 7r square plus 7r plus 7 and 13r square minus 7r. This here we'll have 13r square from minus 7r square. So we'll have 6r square. Right. Here we'll have minus 13r plus 7r. Minus 13r minus 7r actually. Right, minus 13r minus 7r will become minus 20r. And here we'll have 13 minus 7. 13 minus 7, that means plus 6. This will be equal to 0. If we can divide it by 2, what do we get? Right, either we can directly factorize it or we can divide by 2 and then factorize it. We'll get r is equal to, we'll get two values for r. And we'll get r equal to, let's see, we are getting r is equal to 3 or 1 by 3 then. R is equal to 3 or r is equal to 1 by 3. We have to be quick at solving quadratic equation also. Simple 6, 6, 12. The product is 12 and the sum is 20. So 80, minus 18 and minus 2. We split this middle term. Product should be 36 and sum should be equal to 20. So minus 18 and minus 2. Right. So two values of r are possible. R is equal to 3 or it can be equal to 1 by 3. Sum of infinite terms of GP is 20. There is a GP which has sum of infinite terms. This time infinite terms ka sum. The sum of infinite terms is given to us. And what is the formula for sum of infinite terms? We have already studied that. We have already gone through that. Sum of infinite terms of a GP in a GP is equal to 20 and sum of their squares is equal to 100. Wow. Sum of infinite terms in a GP is 20 and sum of their squares, infinite squares also, is equal to 100. Then find the common ratio. Give it a try for half a minute. You have to find the common ratio of this particular GP. Sum of infinite terms means that A plus AR plus AR square plus AR cube dot till infinity we have to find. This is sum of infinite terms. Sum of infinite terms of this GP is 20. What is the sum of infinites? S infinity is equal to, we already know, A upon 1 minus R. Remember this, A upon 1 minus R, and if they are talking about sum of infinite terms, that we have to already by default assume that R is between -1 and 1. Okay, that means we can directly say sum of infinite terms of this GP is going to be A upon 1 minus R, and sum of their squares, that means one more GP is there, sum of their squares, the new GP, then the other GP which is formed by squares of the same terms, that means A square plus A square R square plus A square R to the power 4 plus A square R to the power 6 and so on till infinity. This, the sum of this particular GP is given to us as 100. So what? No problem. S dash infinity, that means sum of infinite terms of this one is S dash infinity, means this is different sum, right? So if I cannot write as S infinity only. So that's why I am writing S dash infinity. Don't get confused in that, sir. S then S dash, sir. How many variables are you going to use? I'm not fond of using variables, but that's what the math requires, and we should actually never be afraid of using the variables. If we are, if we get afraid or if we get scared by looking at too many variables, that means we are doing something wrong with math. That means we are not justifying properly with math. Okay, so now S dash infinity, sum of these terms. Here, what is the first term? A square. So A square by 1 minus R square. Isn't that? What is the common ratio? R square, right? R square is the common ratio. So A square upon 1 minus R square. This was given to me as 20. This is given to me as 100. Now, what do I need to find? Common ratio. Common ratio. Now, sir, if I want to find R, I want only R. I know the idea I am getting already, that this is 1, this is 2. I am already getting the idea that, sir, something I have to do with, I have to cancel, I have to remove this A. I don't like A, because if I want to find common ratio, then I should just keep R in my expression or equation, whatever it is. Okay, so now what do we do? Here first only, if we multiply the first one, itself with, if we square the first one, let's say, not multiply, let's say first one only, if we square, then first one square will give us A square by 1 minus R whole square equal to 400. Can we say that? Now this one, let's not call this one as first, I'll call this one as the first one. Let's say this is the first equation for me. Now 1 by 2, that's it. S infinity by S dash infinity. I can just do S infinity divided by S dash infinity. What will I get? A upon 1 minus R upon A square upon 1 minus R square, right? Or shall I divide this? This is my first one. So A square will get cancelled. We'll get 1 minus R whole square in the numerator, and denominator will have 1 minus R square, which will be equal to 400 by 100, that means 4. Now 1 minus R square is 1 minus R into 1 plus R. So 1 minus R into 1 plus R, that 1 minus R will be getting cancelled by this. So 1 minus R will go, only 1 minus R will remain, and we'll have 1 plus R here, which will be equal to 4. solving this will easily give us the value of the common ratio, which will come out to be 5. Oh, not sorry, I'm sorry, 5, it should not be. 4 plus 4r. Tell me in the comment section what will be the value of r. We'll get 5r is, okay, we'll get 5r is equal to 3. So r is equal to 3 by 5, I think. R will come out to be 3 by 5. That's correct. Let's check also. I think there must be an answer. R is equal to 3 by 5. This is correct. Common ratio of GP we have found. The sum of n terms, horrible sequence. Sum of n terms in this case. I'll give you a hint. You try this on your own, okay? Because we'll solve more other questions. I'll give you a hint over here. So, sum of n terms of this sequence. We have to find the formula, we have to find the general formula for telling the sum of n terms of this particular sequence. That's what is required, that's what is needed. So how should we do? What should we do? Now this term, if I notice carefully, what will I have? X plus 1 by x whole square means x square plus 1 by x square plus 2 into x into 1 by x, that means plus 2. X square plus 1 by x square plus 2 into x into 1 by x. No problem. Sir, plus x to the power x square square, that means x to the power 4 plus 1 by x to the power 4 plus 2 again, 2 into x square into 1 by x square. Similarly here what will I have? Here also there is a square, right? So x to the power 6. Further I'll have x to the power 6 plus 1 by x to the power 6 plus 2. So what are we having? We are having one, look at these terms. Look at these terms, this one, this one, this one, x to the power 6, this is, right? So if we look at these terms, what are we getting? X square plus x to the power 4 plus x to the power 6 dot till x to the power 2n, 2 times n, because power is even, right? This will be one thing which we are getting, plus 1 by x square plus 1 by x to the power 4 plus 1 by x to the power 6 dot 1 by x to the power 2n plus 2 times n. This 2 is coming n times, right? There are n terms. So 2 will come, 2 will repeat itself n times, and 2 plus 2 plus 2, if we keep doing this n times, we'll get 2 times of n, nothing else. And this is how we can do it. This is GP, this is GP. This GP has first term a. So x square into 1 minus, what is r? R is x square, 1 minus x square to the power n divided by 1 minus x square. Remaining you can write. Here also you know the first term and you know the common difference also. Right? X square is the first term here. X square minus 1, x square minus 1 or x to the power 2n minus 1. We can write x to the power 2n minus 1, and here we can write x square minus 1. Here the first term, here your first term will become x square and 1 minus r square or r square minus 1. R is 1 by x to the power 4 upon 1 by x square. That means 1 by x square only. So what is r? X 1 by x square. 1 minus 1 by x square to the power n divided by 1 minus 1 by x square plus 2n. This will be the general formula. You can simplify it and that will be your answer. Okay, so we have to just split, we have to just square it and then break the terms which forms individual GPs. We'll get, yeah, here we are getting same, this is what we are getting. So this will reduce to this thing. This will reduce to x to the power 2n minus 1 upon x square minus 1 into x square plus 1 by x to the power 2n plus 2n. You can simplify it. You'll be able to do that. Try it on your own. A, B, C are in AP. A square, B square, C square are in GP. And one more thing is given to me. A is less than B and B is less than C. That means A is the smallest term, C is the largest term. Okay. A, B, C are in AP. What can we do? See, either for the 3 terms we can use A plus D, A plus 2D like that, or For the GP terms, we can use A, AR, AR square. One thing, but we'll have to choose. We'll have to choose one thing. We cannot use both. Otherwise, there'll be A, D, R. There'll be too many variables to solve. So, one important thing, one very useful thing which is given over here is this. Sum. If three terms, A, B, C are in AP and sum of these three terms is given to me. Sum of these three terms is given to me directly. Yes or no? The sum of these three terms is given to me. No? A plus B plus C is 3 by 2. These three only are in AP. Okay. So, how does this help me? How does this help me? I also have A square, B square, C square in GP. We studied about properties of AP and GP, where I said if A, B, C are in AP, then A plus C by 2 will be equal to B, or I can say A plus C is equal to 2B, or we can also say B square is equal to AC. If A, B, C are in GP, if A, B, C are in GP, then we can use B square is equal to AC. So, what should be my idea? My idea should be that either I use 3 terms of AP over here, or I use 3 terms of GP over here. Now, if A plus B plus C is given to me as equal to 3 by 2, can I write A as B minus D? There must be some common difference, right? Can I write B as B only, and can I write C as B plus D? Can I do that? Right. So, what I am trying to say that I am going to write the terms of AP in terms of B and D. So, B minus D plus B plus B plus D is equal to 3 by 2. This is what I am getting. 3 minus D, B minus D it will be. Minus D plus D will get cancelled. 3B will be equal to 3 by 2. So, B will come out to be equal to 1 by 2. Isn't it? B is going to come out to be equal to 1 by 2. Now, I have used this. Now, what can I do? Now, with this I have found B. With this I have found B. B is equal to 1 by 2. How can I use it ahead? A square, B square, C square, B in GP. Second thing I have to use. Second information I have to use. Now, it's upon me that how do I use it? If I start making it in terms of R, that if I say B is equal to AR, then C is equal to AR square, I'll get one more variable which is not my agenda, which should not be my agenda. Instead, I'll just use the property of GP. I've used the terms of AP here, right? Here I'll use the property of GP, where B square whole square, middle term square, will be equal to product of these two. That means A square into C square. Can't I use this? Is there anything wrong in using this? No, there is nothing wrong. So, B square whole square is equal to A square C square. B square ka value I have. B, the value of B I have, right? I want to find the value of A and this. I want to find the value of A. So, how can I do that? Let's move ahead. That means this term, that means this particular term, or I can say this term is 1 by 2 minus D. This term is 1 by 2 and this term is 1 by 2 plus D. Any problem in that? No problem in that. Okay. So, can we also find D with the help of it? No, we will not be able to find, because D will be cancelling over here. We have already used this. Don't make that mistake of doing that again. B square whole square is equal to A square C square. How does this help me? So, it will be B to the power 4 is equal to A square C square, or instead of doing this, I will just write B square is equal to square root of A square C square. Square root of A square C square, that will come out to be B square is equal to AC only. B square will come out to be equal to AC. Right, what is A and what is C now? So, my B square is going to be A into C. A is, what is A? 1 by 2 minus D, and B is 1 by 2 plus D. 1 by 2 minus D and D is 1 by 2 plus D. And B already I know. B square I can find, B is 1 by 2, so it will be 1 by 4. Right. So, I can, now B square is equal to I'll have b square is equal to 1 by 2 minus d and 1 by 2 plus d. B square is equal to AC, right? This is what we are getting. B square is equal to square, b square whole square, b square whole square, sorry, b square whole square, that means b to the power 4. B square whole square, square of the middle term will be equal to the square root of product of first term and second term. That means square root of a square c square, which is we are getting as AC. Correct? We have done something wrong here. B square is equal to, why are we getting b to the power 4? Should be getting we'll get b square is equal to AC only, right? We'll get b square is equal to AC. So b square will be equal to a into c. A is 1 by 2 minus d and c is 1 by 2 plus d. Now b I know, b is 1 by 2, so 1 by 4 is equal to 1 by 2 minus d into 1 by 2 plus d, that means 1 by 4 minus d square. Correct? Any other value can we get? Can we get any other value? Like 1 by 4 d square can be equal to 1 by 4 minus 1 by 4, that means d is coming out to be 0. That means d is coming out to be 0. But d could also come out to be, d had one more value, right? What was d? Here we found that d square, from here we are getting d square is equal, what did we get? D square is equal to 1 by 2 we got. That means d is equal to 1 by root 2 also we got, no? D is equal to plus or minus, either d is equal, d square is, either d will be equal to 0, from this one we will get d square is equal to 0, or d will be equal to 1 by root 2, here we will have 1 by root 2. So d will be equal to, if d is equal to 1 by root 2, then only it will be defined, because if d is equal to 0, this cannot be done, this cannot be defined. So what will be the value of a that we are getting? The value of a that we will get is b minus d. That means value of a will get is 1 by root 2 minus 1 by 2. This is what we'll get. Simple. Understanding question, nothing else. Okay. So next thing, let A, B, C be in an AP and same question only, right? Same answer we got correct, no? So here we can see 3 terms we chose. 3b is equal to 3, b is equal to 1 by 2 we got. Then a square, b square, c square in GP. So we used b square is equal to square root of AC. B square is equal to AC or b is equal to square root of a square, c square, same thing. So we are getting b square is equal to mod of AC. This will come out to be as mod of AC. That's why they have written as mod of AC. So either 1 by 4 will be equal to plus 1 by 4 minus d square, or 1 by 4 will be equal to minus of 1 by 4 minus d square. In that case, either our 1 by 4 minus d square, if that is equal to 1 by 4, right, or 1 by 4 minus d square will be equal to minus 1 by 4. Either way you can do it. In this case, we are getting d square is equal to 0. In this case, we are getting d square is equal to 2 by 4. That means d is equal to 1 by root 2, right? That is why 0 we cannot accept. It is an increase in an AP. 0 we cannot accept because a is less than b and less than c. It is already given, right? A is less than b and b is less than c, right? So if d is 0, then all the 3 will be equal. And in that case, we are not getting this also. So it is since it is an increasing AP, will have a is equal to b minus d, that is 1 by 2 minus 1 by root 2. Okay, let's move ahead. Key points of our GP, key points in our geometric progression. key points in our geometric progression. What can be the key points? Like we can multiply anything in the entire AP, it will still remain the AP. Similarly, we can multiply any constant in the entire GP, it will still remain the GP. In the same way, we can put the same power in all the terms of the GP, it will still remain a GP. Okay, very important points. In some questions, there can be a chance that we get to use them, that if we multiply a same constant term in all the terms of the GP, that will still remain the GP, and if we put the same constant power on all the terms of the GP, that will also still remain the GP. Product of terms, K should not be equal to 0, obviously over here, okay. K should not be equal to 0, otherwise all the terms will become 0. Product of terms equidistant and beginning. From beginning and end is same, just like AP. In GP also, product of terms from beginning and the end is same. For example, this is A, this is AR, this is AR square, this is AR cube, this is AR to the power 4. Now, if I see A into AR to the power 4, A, you can observe this like this also, A multiplied with AR to the power 4, A square R to the power 4, correct? AR multiplied with AR cube, A square R to the power 4, and this will also be equal to square of this, AR square whole square. If there is only one middle term, then square of that middle term will be equal to the product of equidistant terms from the starting and the end, right? This again can be used for writing, solving many questions or writing terms for a GP. Suppose we have to assume the terms for a GP. In that case, how should we assume? A, first term assume it as A, then while going backwards, just divide by R. If you are going forward, multiply by R. Okay. If you are going forward, multiply by R. Okay. Now, this term will become 1 by A by R square. This term will become AR square. Okay. So, you can do that. But suppose you have to, if the product is given to you, this is the case when you have to assume the terms, and sometimes product will be given to you. So, if you have to assume 4 terms, suppose you have to assume 4 terms and you want to cancel all the R's, choose A by 3R, A by R, AR and AR cube. That's how you have to choose. 5 terms suppose you have to choose, so that will be A by 2R, A by R, A, AR and AR square. Okay. Now, here also if we will multiply everything, R's will get cancelled and we will get an equation in A. That is why we are doing this. And why are we choosing 3R? To make the ratio 2R. To make the ratio, oh, this is R cube, not 3R. This is R cube. To make the ratio R square. Okay, ratio should be constant. While choosing the 3 terms, 4 terms or 5 terms in a GP, whenever you are choosing, just make sure that your ratio is coming out to be constant only. I'm not asking you to mug this up, but still, okay, generally you should use this and you should be sure that the ratio is coming out to be same. What is the product of first 5 terms of a GP if A3 is equal to 2? We can do this. Simple, easy question only. Nothing much difficult or something, simple information you have to write. What is the product of first 5 terms if A3 is equal to 2? Acha, if A3 is given to me as 2, suppose A3 is third term, the term before A3 will be A3, can I write the term before A3 as A3 by R, whatever is the common ratio, right? Whatever is the common ratio, right? Can I write before this one more term A3 by R square? Can I write a term over here A3 into R? And can I write a term over here A3 into R square? Now product, these are the 5 terms. These are the 5 terms that I am choosing. Why am I doing this? Because I am writing everything in terms of A3, because A3 is given to me, middle term is given to me. So that's why I am choosing like this, that's why I am writing like this. Okay, it's not the product, 5 terms you have to choose. Suppose here if we go this way, A by R square by A by R, A by R, A by R square, this way also we are doing the same thing, right? And generally also I told you that while moving back, keep dividing by R, while moving forward keep multiplying by R. Now, how will this benefit us? When we'll multiply all of them, when we'll multiply all of these, when we are going to multiply all of these, what are we getting? R square is getting cancelled, R is getting cancelled. We are getting A3 to the power 5 is equal to what? What will we get? A3 to the power of 5. A3 is 2. So that means 2 to the power of 5. That means we are getting 32. Simple. Right? The point, the agenda was that how to write the 5 terms. And when the product is given, write like this. That is general, that is important, that is defined. That if you write like this, then only it's better. You'll get the answer easily. What is, okay, 32 here. We got. The product of the 3 terms in GP is 216 and the sum of their product in pairs is equal to 156. See, one remark which I just told you, A by R, AR is beneficial when the product is given. What is given over here? Product of 3 numbers which are in GP. So, what will we choose? A by R, AR. And this is beneficial when the product of terms in GP is given to us. So, now, what do we have? A by R, AR. 3 terms we have to choose, right? So, we are choosing A by R, A and AR. This product is given to us as the product of these 3. That means A by R into A into AR is given to us as 216. That means directly from here what are we getting? A cube is equal to 216 and we will find that A is equal to 6. Now, the sum of their product in pairs, that means AR into A, that means A square by R, A into AR, A into AR, pairs means these two pair and these two pair, A into AR, that means A square R, plus A by R into AR, that means A square. This is given to us as 156. What shall we do? Try this once on your own. I'll just be back. Nothing much, simply just take A square common. So, 1 by R plus 1 you will get inside, 1 by R, right? Yes, is equal to, what was this? 156 is equal to 156 and you already have the value for A. So, you don't need to worry about anything. You already have the value of A, right? You just found out. So, 6 square, that means 216 multiplied with 1 by R plus 1, that means 1 plus R square plus R. This R I am going to shift here is equal to 156 R. We get a quadratic in R. We are getting a quadratic in terms of R. So, what are we getting? 216 R square. The quadratic which you will get is 3R square. When you will summarize this, you will get 3R square minus 10R plus 3. 3R square minus 10R plus 3 is equal to 0. Correct. So, from this can be factorized as 3R minus 1 multiplied with R minus 3, right? And this will be equal to 0. So, what can we expect from there? What are we getting? From this particular thing, what are we getting? We are getting R is equal to 1 by 3 or R is equal to 3. Any information which is given? R is equal to 1 by 3 or R is equal to 3. Now, if we take R is equal to 1 by 3, if we take R is equal to 1 by 3 and A is equal to 6, 6 upon 1 by 3, 18, first term, A is already 6 and 6 into 1 by 3, that means 2. 18, 6 or 2 can be our terms, or if we take R is equal to 3, suppose if we are taking this R is equal to 3, then in that case what are the terms which we are getting? If we take R is equal to 3, then A by R. A by R, that means 6 by 3. That means 2 A, that means 6, and AR, that means 18. 6 into 3. So there can be two sets of numbers which can be 18, 6, 2 or 6, 2, 6 and 18. Which can be 18, 6, 2 or 2, 6 and 18. Why? Because in R we are getting a quadratic and we are getting two values, and both can be acceptable because there is no condition mentioned for R. We cannot see any condition specific mentioned for R. Most important point over here, that whenever product is given to you, try to use the product of 3 or product of 4, try to use this concept. While moving back, keep dividing A by R's, and while moving ahead, keep multiplying A by R's. If this is AR, then next will be AR square. If this is A by R, next will be A by R square. Okay, next. Okay, this we have solved. Let's check. Okay. Okay, very important question, and a good question as well. I can say that very good question. I'll hint you about this. You can solve it on your own. But yeah, question looks very complicated. That we can definitely judge by the looks of the question. That looks very complicated. A1, A2, A3 dot 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 till AN is an increasing, first of all, increasing geometric progression. So what can be the points for increasing geometric progression? R is greater than 1, right? Increasing geometric progression means R is greater than 1 or between 0 and 1, right? If it is of positive terms, then R will be greater than 1. If it is of negative terms, then R can be between 0 and 1. It cannot be negative. Otherwise, the terms will be in alternative positive and negative, right? We'll talk about that. Let's pay attention on the question. A1, A2, A3 are the terms. Now, A1, A3, A5, A7 is given to me. Here what is given to me? A1, A3, A5 and A7. Sir, how does it even help? Shall I write them as A1? Can I write as A, then AR square, then AR to the power 4, then AR to the power 6. But then I am getting an expression which is in R to the power a very big number, right, where it will be very difficult to solve. I can use small a and R, I can use first term and R and then solve it. Suppose if I use A R square, A R to the power 4, A R to the power 6, then multiply all of them and equate it to 1 by 1296. It's not helping me anyhow. It's not helping me anyhow. So there should be some other idea, right? What should we do? We should pick A4, the concept which we are going to use in this one and we have used in the other ones as well, the previous ones as well, remains the same. That be smart and use A4, some term in terms of which you can write all the other terms. You have to choose pick any one terms which you can use to represent all these other terms so that the value of that term you can obtain. Which term? A4 is missing here, right, in between. So can I write A3 as A4 by R and A1 as A4 by R square? A4 by R will be A3, A4 by R square will be A2 and A4 by R cube will be, wait, let me write it completely properly. A4 by R cube multiplied with A4 by R square or R third, right, into A5, that means A4 multiplied with R, and A7 can I write it as A4 R square R cube, A4 multiplied with R cube. Okay, this product is given to me. So R cube cancelling R cube, R is cancelling R, A4 to the power 4 I am getting as 1 by 1296. How does that help me? Does that help me somehow? Yes, that helps me. 1296 is the fourth power of 6. 6 6 are 6, 36, 216, 216 into 6 will be 1296. So I'm getting A4 is equal to 4th root of 1 by 1296. That means 1 by 6. I got A4. Good. Great, in fact. If I'm getting A4, I'll also get A2. Will I also get A2? I'll also get A2, right? If I'm getting A4, then I'll also get A2. And can I write these terms, these three in terms of A4 only? Can I write these three in terms of A4 only? Is that okay? Or, hey, but I'll need R also, right? I'll need R also. If I want to write these in terms of R, in terms of A4, then I'll also need R. So what will I do? I know A4 I've got as 1 by 6. So A2 I'm going to get as 7 by 36 minus 1 by 6. From here I can get the value of A2. What will I get the value of A2 as? 1 by 36. 1 by 36. A2 I'm getting as 1 by 36. Can it help me to find? Can it help me to find R? Yes, it will help me to find R. A4 by R square, this was A4 by R square is equal to 1 by 36. What is A4? 1 by 6, right? So R square is equal to 1 by 6 into 1 by 36. Right, from here I can use A4's value. A4 1 by 6 upon R square will go this way, 1 by 6 into 36. We'll get 1 by 6 into 36. So R square will be 6, and we'll get R square. If we are getting 6, then A6 I can write as A4 into R into R, A4 into R square. Can I write A6 as A4 into R square? Can I write A8 as A4 into R cube R to the power 4 and A10 as A4 into R to the power 6? That's it. That's it. The question is solved. I have A4, I have R square's value. So R square, if I'll take common, I'll have 1 plus R square plus R cube. No, something, yeah, correct. So now you can solve. This one, A6 you can write in terms of A4 now, A8 you can write in terms of A4 now, A10 also you can write in terms of A4 now. Not a big problem. You have understood. How did we approach towards the question? First we saw this. When we saw this, we thought that, okay, we can use AR square and all, but it will make a big expression. So what we did, we tried to write all of them in terms of A4. We could write all of them in terms of A4. Then we found that A2, when we found A4, with the help of this we found A4. After finding A4, we found A2, which came out to be 7 by 36 minus A4. That means 7 by 36 minus 1 by 6. When we found that, when we found A2, we know A2 can be written as A4 by R square. If A2 is coming out to be 1 by 36, then R square is coming out to be 6. And that's how we are going to use this in this equation. A6 we wrote as AR square, A8, right, and A10, correct. Now you can use this. This will become R square to the power 3, right? Not a problem. A4 R square, that means 1 by 6 into 6, this will become 1. A4 R to the power 4, here also not a problem. R square whole square, that means 1 by 6 into 36, that means 6 will get, and here what we'll get, 1 by 6 into R square cube, that means 1 by 6 into 216, that means 36 again. So I think 42 and 43 we are getting, right? Good, important question. This same concept, this same strategy may help you in any other question which is similar to this one or related to this one. Okay. Now, next thing. arithmetico-geometric progression. The name looks weird. Does the name look weird to you? The name looks weird to me, definitely yes. The name looks definitely weird to me. Arithmetico-geometric progression. What can it mean? What can be the meaning of this? What do you think? What can be the meaning of this? Arithmetico-geometric progression. That means there must be a arithmetic progression and there must be a geometric progression, and if we combine them, right, if we combine them, then that must form an arithmetico-geometric progression. Suppose, for example, that we have 1, 3, 5, 7, 9, 11. This is an arithmetic progression, odd numbers. Then we have x, x square, x cube, x to the power 4, x to the power 5, a geometric progression. Now what if I write 1 into x, 3 into x square, 5 into x cube, 7 into x to the power 4 and 9 into x to the power 5. This will form an arithmetico-geometric progression. That means these terms are in AP. These terms 1, 3, 5, 7 are in AP, and there will be a product, and in product this side term, one side of terms will be in AP and the other side of terms, that means x, x square, x cube, x to the power 4, x to the power 5, these will be in GP. Simple thing to understand. Nothing very difficult in this. How will it look like? Let's see how will it look like. We only are saying no arithmetico-geometric progression. That means if A plus D, A plus 2D and A plus 3D, these are the terms of an AP. A plus n minus 1 into D, these are terms of an AP. Now what can be the terms of GP? AR square, AR cube, right? Or instead of using AR square, AR cube, what if I just use 1 R square, R cube, R to the power 4, R to the power 5. This is also a GP, right? This is also a GP. So, first term 1, A into 1, A plus D, A plus 2D. General form I am telling you, general form. How will an AGP look like? It's not general form anyway, you'll have to make. But how to recognize, how to know, how to recognize that there is a AGP, right? 1 R square, R cube, R to the power 4, R to the power 5, these terms are in GP, these terms are in AP. If we combine them, that means A plus D, A plus 2D, A plus n minus 1D, these terms are in AP. Here 1 R square till R to the power n minus 1. These are the terms of GP. That's why this can be called as a AGP, that means arithmetico-geometric progression. Alright. Now, okay. Now, 1, 3x, 5x square, 7x cube, 1, 3, 5, 7 are in AP. 1x, x square, x cube, these are in GP, right? 1x, x square and x cube, these terms are in GP. Similarly, 1, 40, 700, 10,000, these are in. Now, if we look at this 1, 4 into 10, what does this look like? What does this look like? This looks like this. 1, first term, 4 into 10, 7 into 10 square, 10 into 10 cube. Now 1, 4, 7 and 10 are in AP. 10, 1, 10, 10 square, 10 cube. These are in GP. 1 into 10, 10, 10 into 10, 10 square into 10, 10 cube. These are in GP. These terms are in GP. So this forms an arithmetico-geometric progression. Is this also an arithmetico-geometric progression? Let's see. 2 multiplied with 1 by 10 is 0.2. 4 multiplied with 1 by 100 is 0.04. 6 multiplied with 1 by 1000 is 0.006. Correct? So these terms are in AGP. Definitely 2, 4, 6, these terms are in AGP, these terms are in AP, and these terms 1 by 10, 1 by 100, 1 by 1000, these terms are in GP. So this progression can be called as arithmetico-geometric progression. Sir, you have told us what is arithmetico-geometric progression, but what about how to solve it? What about solving of this? What to do with this? This looks already horrible and difficult to us. Okay, let's see how to solve it. Sum of n terms. This is an arithmetico-geometric. 1, 3, 5, 7. These are in AP. Okay, 1x, x square, x cube. These are in GP. So arithmetico-geometric. Now, first one. Let's pick this one. Simple and strategic approach. Always you can believe and you can follow the same approach. You don't need to use different approach every time. You can follow the same approach. So sum of n terms is equal to 1 plus 3x plus 5x square plus 7x cube up to n terms. So you have to first write the general term. General term means n term. Right? Here you need a general term, something. There must be some general term. Can you tell me the general term in the comment box? Come on, tell me the general term for this. Come on. Anybody who can tell me the general term? General term means over here, if I have to write something, what should I write? Array, 1, 3, 5, 7. Odd numbers starting from 1. So this term will be 2n minus 1. 1x, x cube. Second term has x to the power 1. Third term has x square. Fourth term has x cube. So this term will have x to the power n minus 1, isn't it? The general term. The general term, if we talk about over here, then this will be the general term. Now, next step. Next step, what you should do is, just a minute. Next step, what you should do is, now sir, we cannot add like this. Although we know there is an AP here, we know that there is a GP here, but still we cannot add like this. We have to come up with some idea. How do we find the sum of n terms for a GP? That was also looking very difficult. No, so what did we do? We multiplied with common ratio of GP, right? We multiplied the entire Sn of GP with R. Remember that? So here also we can do the same thing. Just remember that we have to multiply with the common ratio of GP in this. What is the GP in this? 1x, x square. So what is the common ratio? X. So we'll multiply it with x. X Sn is equal to 1 plus 3. So 1 into x will become x. We'll have to shift. Again, we'll have to shift. So we'll shift like this. 1 into x will become x. 3x into x will become 3x square. 5x into x will become 5x cube. Correct. Similarly, this into x will become 2n minus 1 into x to the power n. And next term, this will also be multiplied, right? This will be multiplied. So this will be the, we have shifted. We are multiplying with x and we have shifted all the terms. So this term multiplied with x will come in the n. Correct. 2n minus 1 multiplied with x to the power n. Come on, keep telling me yes or no in the comment box. My right, keep telling me yes or no, whatever you are understanding in the comment box. Now here 2n minus 1 x to the power n. Again, what I can do is subtract this Sn minus x xn. That means 1 minus x multiplied with sum of n terms. If I am subtracting here also I have to subtract. Now what am I getting? 1 will keep as it is. 1 will not be subtracted. But 3x minus x, put a bracket. 3x minus x is 2x. 5x square minus 3x square is 2x square. 7x cube minus 5x cube is also 2x cube. Correct. Now till where will it go? It last term will not get subtracted, right? This will stay outside as 2n minus 1 into x to the power n. This will be in the end. So this term will get subtracted by the previous term of this, correct? What will we get? 2x to the power n. Why? How many terms will be there? How many terms? This is very important to know. Here we will have n minus 1 terms. It is very important to know here. In this particular part, we are going to have n minus 1 terms. N minus 1 terms. This term is here. So here we will have n minus 1 terms. That is very important and easy also to know, right? This is easy to understand also and important to know. But don't make this mistake. Sometimes students might make this mistake. Rest, there is a followed and there is a specific approach which every time you have to apply as soon as you see an AGP. So now it's done. Now we can simply define what do we have here? What do we have here? Here we have a GP. So Sn, sum of n terms is equal to 1 plus first term. This is a GP. So A into sum of GP will be A into 1 minus r to the power n. A into 1 minus r to the power n or r to the power n minus 1. R, what is r? X is r. X square by x. 2x square by 2x. That means x only. So r is x. X to the power how much? X to the power, sir, n minus 1 it will be. Why it will be n minus 1? 2x is the first term multiplied with x to the power of n minus 1. 1 minus r to the power n. So x to the power n minus 1 divided by 1 x minus 1. We have to, not 1 minus x, we will have to write x minus 1 over here. Or if we are writing 1 minus x to the power n minus 1, then we can write 1 minus x over here also. Okay. Actually, we should write 1 minus x instead of, because this we are going to bring down. So what I will do is I'll write this as 1 minus x to the power n minus 1, and here I'll write 1 minus x. That's okay. Okay. This is the sum of this part. This is going to be the sum of this part. Minus 2n minus 1. This as it is, we'll write 2n minus 1 x to the power n divided this. As it is, we'll write. Now what am I going to do is, I'm just going to bring this 1 minus x, which I forgot to write over here. Nobody told me. This 1 by x I'll bring down. So Sn, sum of n terms will be 1 by 1 minus x. See, it's not complicated. It is easy to understand but calculative. Do your calculations carefully. And very applicable and important chapter for the further chapters also of class 11 and class 12. Especially class 12. Most favorite chapter of JEE people or JEE examiners. Definitely. Very many questions are seen from this topic. So just calculations may be a little bit tricky, but it's not difficult to understand. Now what we are doing, 1 by x we are bringing down, 1 minus x we are bringing down. So this will become 1 by 1 minus x. This will become 2x into 1 minus x to the power n minus 1 divided by 1 minus x ka whole square minus 2n minus 1 x to the power n upon 1 minus x. This expression will be giving the sum of n terms of this particular GP. Okay. 1 by 1 minus x, 2x into 1 minus x to the power n minus 1 upon 1 minus x whole square and this thing. Okay. Is this also an AGP? Yes. Looks like an AGP, but it's better that, how do we write this AGP? S infinite. The main thing is that they have asked the sum of infinite terms of this AGP. How does this AGP look like? 2 into 1 by 10 plus 4 into 1 by 100 plus 6 into 1 by 1000. Okay. Not a problem. It will keep going on. Now 1000, instead of writing 1000, 100 and 10, I'll write 10 square and 10 cube. Okay, this will work, right? So this will go on till infinity. Now 2 into 1, S infinity, sum of infinite terms I am defining. First of all, sum of infinite terms I should be able to define. Let's see. General approach, what have we learned? We have learned that multiply with the common ratio. Here AP is 2, 4, 6 and so on. GP is 1 by 10, 1 by 10 square, 1 by 10 cube and so on. Now, major idea is multiply with the common ratio. Okay, multiplying with the common ratio. So, S infinity will be multiplied with 1 by 10 is equal to here also 1 by 10 if I'll multiply 2 into 1 by 10 square plus 4 into 1 by 10 cube and so on till infinity. Okay, what are we getting? 1 by 10 into sum of infinite terms is equal to 2 into 1 by 10, 2 into 1 by 10 square. 1 by 10 square, now 1 by 10 square, 1 by 10 cube. 4 into 1 by 10 square minus 2 into 1 by 10 square. This will come as it is. 2 into 1 by 10, that means 1 by 5 will come as it is. But what about this? 4 minus 2, 2. That means 2 into 1 by 10 square. 6 minus 4, 2 plus 2 into 1 by 10 cube. Again, next will be 8 minus 6, 2. So, 2 into 1 by 10 to the power 4 it will be. And it will keep going on till infinity. What can I do? 1 by 10 I can keep here only. So, this will become 1 by 5 plus 2 common. 1 by 10 square plus 1 by 10 cube plus 1 by 10 to the power 4 and this keeps going on till infinity. That's it, solved. This thing I know already. Right, now we have solved. This thing, what will be this thing? A upon 1 minus R, that means 1 by 10 square. 1 by 10 square upon 1 minus R. That means 1 minus, what is R? 1 by 10, 1 minus 1 by 10. Okay. This sum of infinite terms, here we can define the sum of infinite terms. R is less than and between minus 1 and 1. So, we can define the common ratio and we can define the sum of infinite terms, definitely. Are you getting my point? Here we are defining the sum of infinite terms because R is between minus 1 and 1 and we needed sum of infinite terms only. Here 1 by 5 plus 2 into just solve this now. Just multiply this and we can get the answer. And this 10 also you'll have to multiply that side. Don't forget that. So, I think answer, let's see. Okay. Hey, one thing we didn't do. One thing we have forgotten to do. S infinity minus 1 by 10th of S infinity we did, right? Why are we writing 1 by 10 only? My God. Right? Here we have not S infinity. So, this will be 1 by 10. S infinity 1 minus 1 by 10 S infinity. Correct? This minus this we did, right? So, this S infinity minus 1 by 10th of S infinity, that means 9 by 10th of S infinity it will be, right? This will be 1 by 5 plus 2 into the entire thing. So, that's one thing which we have forgotten. Rest everything is fine. So, here we can say 2 by 10, this will keep going on like this. 2 by 10, the entire GP is like that, 2 into 2 by 10, same thing. And in the final, we are getting our answer as Sn is equal to 20 by 81. The final answer we will get is 20 by 81, sum of n terms, sum of infinite terms, basically sum of infinite terms we will get. Anybody? Anything? Why one outside? Which one outside? Otherwise you are asking. Why plus 1 outside? In this case you are asking why plus 1 outside? Because see, this is getting subtracted, no? You remember this is getting subtracted. If we are subtracting each and every term, for example, if I am multiplying this with the common ratio, so the GP is shifting, right? So, this term will come as it is. This term is going to come as it is. For example, if we talk about this example if we talk about over here, yeah, 1 minus 0. Here nothing is there, so 1 will come as it is. Alright. Okay, 1 will come as it is. Then we'll have 2x, 2x square, 2x cube and n minus 1 terms. And this will also come minus 2n minus 1 into x minus n. We are subtracting Sn by x into Sn. Sn minus x into Sn. That will be 1 minus x into Sn. Clear? Simple. Any problem? Okay, let's move ahead. A weird arithmetico-geometric progressions. Can you find the terms? Can you relate it to AGP? Is there any method in which you can relate it to AGP? Do you think that this is an AGP? Do you really think this is an AGP? Sir, it is given that it is an AGP. I don't have to think. But I have to find, the best part of this question is that you have to find the sum of infinite terms, which is quite reasonable and normal. But the problem which I am feeling, that how to even look at the terms. 3, 4, 4, 32 by 9. I am not able to look at it like AGP. Getting my point? I am not able to look at it like an AGP. So that means I have to do something. I can hint you about it. So if this is an AGP, how will the terms look like? If this is an AGP, if first term is 3, right, this second term should be 3 plus d into r. Correct or not? And third term should be equal to 3 plus d into r square. Am I wrong or right? Correct. Into r square. Right. And then this term will also be, we can find the other terms, we can find the further terms, we can write the further terms like this. A plus d into r, a plus 2d, this will be a plus 2d, sorry. A plus 2d into r square, 3 plus d, 3 plus 2d in AP, 1 r square in GP. So what should we do? Now in this way an AGP should look like. This is how an AGP should look like. Correct or not? So can we say that 3 plus d, this 3 plus d into r is equal to 4? Can we say that 3 plus d into r, this 3 plus d into r, if we can write this, right? 3 plus d into r is equal to 4. There is no problem in that. Right? 3 plus d into r is equal to 4, and we can also say that 3 plus 2d into r square is also equal to 4. Very good. Now we have two equations. What can we do? What do we want? What do we want? We want a and d, or we want r? Obviously we want a and d. First we want a and d only. First we will want a and d only. Correct. So 3 plus d into r. Achha, 3 plus, this is my first equation. So this one I am squaring. 3 plus d whole square into r square is equal to 16. Correct. Divided by this one. That means 3 plus 2d into r square is equal to 4. So if I am dividing this side, this will be 16 by 4. Can we solve this? Now r square will get cancelled. What do we have? 3 plus d whole square divided by 3 plus 2d is equal to 4. There will be a quadratic formed in terms of d. There will be a quadratic formed in terms of d. 12 plus 8d is equal to 9 plus d square plus 6d. So what are we going to get? We'll get something like d plus d square minus 2d minus 3. So we'll get d square minus 2d minus 3 is equal to 0. And when we'll factorize this, we'll get d plus 1 minus d plus 1 and d minus 3, and we'll get d minus 3. This will be equal to 0. So from here what do we get? Either d will be equal to minus 1 or d will be equal to 3. These are the two possible values of d. Either d will be equal to minus 1 or d will be equal to 3. From this, what is R then? If D is equal to -1 I am taking, find R. If I am taking D is equal to -1, let's say, we have two values of D, right? So R, we know from the last one, what do we know? R is equal to 4 by 3 plus D. We know R is equal to 4 by 3 plus D. What are the values of D we got? D is equal to minus, what we have? D is equal to -1 and 3. Yeah, D is equal to -1 and 3 we have. Now, if R is equal to 4 by 3 plus D, that means either R will be equal to 4 by -1, oh sorry, 3 minus 1, that means 4 by 2, that is 2. Either R will be equal to 2. 4 by 3 minus 1. 3 plus D, no? So, if I am taking D as -1, then R can be equal to 4 by 3 minus 1, 2, that means 2. Or if I am taking D as 3, then R will be equal to 4 by 6, that is 2 by 3. R will be equal to 4 by 6, that is 2 by 3. But one important thing, it is asking us to find the infinite terms. R has to be between -1 and 1. That means this is the possible R. This R will be rejected. That means R has to be equal to 2 by 3. That is what we understand. And now if we have got R, there is no problem only. If we have got R, there is no problem, because how are we defining these terms? A plus D into R, A plus 2D into R square. This is how we are defining these terms. Correct? So, if we have got R, now just put the values, right? 3 plus 2 by 3, I am sorry, 3 plus, okay, D we have taken as 3, right? Our correct value of R is 2 by 3 and D is 3, right? D we have taken as 3, then only R we are getting as 2 by 3. The value of D as -1 is giving the wrong value for R. So, we have D as 3 and R as 2 by 3. We will just put the values here, right? We will just put the values here, 3 plus D into R, 3 plus 2D into R, and we can recognize also. First term 3, second term 3 plus 3, 6 into R, that means 6 into 2 by 3, 4. 3 plus 2D, that means 3 plus 2 into 2 by 3, that means, and multiplied with R square, that means multiplied, I am sorry, D is 3 only, so 3 plus 2 into 3, 6 plus 3, 9 into R square, 2 by 3 whole square. So, this is how you are going to form the AGP now. You will have to write the complete AGP now, or you can directly use a formula. You have a formula also for sum of infinite terms of AGP, or you can simply write the AGP. Simply write the AGP like this now, right? 3 simple terms, 3 plus D, 3 plus 3 into 2 by 3, and then 3 plus 6 into 2 by 3 ka whole square. This is how you will have to write the terms and add them. Multiply with the common ratio, apply the same approach, you will get the answer. Here they have used the formula for S infinity, which is not generally recommended. I won't say that you should use this formula for sum of infinite terms of an AGP. This is same way we found the sum of infinite terms of, this is found the same way we found the sum of n terms of an AGP, right? This is sum of infinite terms, but generally I don't recommend that you should use this formula. Instead, you should use the same approach of multiplying the sum with common ratio and start cancelling it. So finally you will get the answer as 27. Now again, is this an AGP? Is this an AGP? This looks like an AGP. 3 plus P, 3 plus 2 plus 3 plus 3. Not a problem. Now 1 by 4, 1 by 4 square, 1 by 4 square. What should be my general idea? That is equal to 3 plus 3 plus 3 plus 4 plus 3 plus 2 by 4 square plus 3 plus Yes or no? This definitely looks like proper AGP to me. These terms are in AP and there is a common ratio also following along. Answer I've given. Yeah, sorry. 8. Anyway, even if you know the answer, the main thing is to find it out. The main point is in finding the answer out. Okay. Now 8 is equal to 3 plus 3 plus p plus 3 plus 2p by 4 square plus 3 plus 3p by 4 cube. What is my general idea? That I'll multiply it with the common ratio. Okay, so I'll multiply it with 1 by 4. What is the common ratio? 1 by 4. 1 by 4 I'll multiply this with. This side I'll multiply with 1 by 4. So here also I'll have to multiply with 1 by 4. 3 into 1 by 4 will be 3 by 4 and 3 by 4 I'll write over here. Now 3 plus p upon 4 into 1 by 4. That will be 3 plus p upon 4 square. 3 plus 2p upon 4 square into 1 by 4 will be 3 plus 2p upon 4 cube, isn't it? Correct or not? Upon 4 cube. Right? Now this will keep going on till infinity. Now the life is sorted. Not a problem. This will become 2. This is becoming 2. 3 by 4. Now subtract. 3 minus nothing. So that we have 3 here. Now these terms will start subtracting. 3 by 4 plus p by 4 minus 3 by 4. That means we'll get p by 4. Plus 3 by 4 square plus 2p by 4 square minus 3 by 4 square plus p by 4 square. So 2p minus p by 4 square we'll get. We'll get p by 4 square only. Right? This will become p by 4 square. Plus again 3 plus 3p by 4 cube minus 3 plus 2p by 4 cube. That means 3 by 4 cube plus 3p by 4 cube minus 3 by 4 cube minus 2p by 4 cube. So what do we have? P by 4 cube, and this will keep going on like this. What do I have finally? 2 is equal to 3 plus p, if I take common, 1 by 4 plus 1 by 4 square plus 1 by 4 cube, and this keep going on till infinity. This keeps going on till the infinity. Now can you tell me the product? Now can you tell me the sum of infinite terms? You know the sum of infinite terms for a GP now. There is no issue at all. There is no problem now, right? Why? Because now you know the sum of infinite terms of this GP. 1 by 4 upon 1 minus 1 by 4. Right? You just have to find the value of p. 1 by 4 upon 1 minus 1 by 4. Can you find the value of p from here? P will come out to be 9. P should come out to be 9. Okay. This will become, here we will have a 2 is equal to 3 plus p into 1 by 4 first term upon 1 minus a upon 1 minus r. So 1 minus, what is the common ratio? Common ratio is 1 by 4 only. So 1 by 1 minus 4. Let me write a bit more neatly. Yeah, this is how you will find the value of p. This will become 3 by 4, 1 by 3, yeah. Okay. This question again, you can solve it on your own. Here the thing is that 2 to the power 1 by 4, 4 to the power 1 by 8, 8 to the power 1 by 16. The hint I can give you over here, not very tricky or anything much to do in this. What you have to just do is try to create a series in the powers. So 2 to the power 1 by 4 if I take plus 2 to the power 2 to the whole power 1 by 8. That means 2 to the power 2 by 8, 1 by 4. So this 4 to the power 1 by 8 I can write as 2 to the power 2 to the whole power 1 by 8, right? What will it become? 1 by 4 again, right? It will become 1 by 4 only again, or 1 by 8 it will become. We have to take in the powers of 2. We have to take these in the powers of 2, right? We want to write in the powers of 2. So 2 to the power 1 by 4, okay, multiplied with 2 to the power 2 to the power 1 by 8. That means 2 to the power 1 by 4. Multiplied with 2 to the power 3 to the power 1 by 16. That means 2 to the power 3 by 16. Right? Here what we'll have 2 to the power 4 by 32. That means 2 to the power 1 by 8. Now 2 will be in the base, and in the numerator we are getting a arithmetico-geometric progression. We are getting a geometric progression 1 by 4, 1 by 4. We'll get a GP in our power of 2. GP of infinite terms, right? We'll get a GP of infinite terms in our power of 2. So I think this question you can solve on your own, and we can move till infinite terms you have to find. So convert all of them in the powers of 2, and there will be a series formed in the powers in the exponent, right? Base will be 2, all these will be added, right? All these will be added. All these terms will be added. See, 2 to the power 4, 1 by 4, 4 to the power 1 by 8, they have written as 2 to the power 2 by 8. So 1 by 4, 2 by 8, 3 by 16, 4 by 32, till infinity. Now, if you observe at 1 by 4 plus 2 by 8 plus 3 by 16, 4 by 32, 1, 2, 3, 4 look like AP. 1 by 4, 1 by 8, 1 by 16, 1 by 32. What does it look like? GP. Right. So what is the common ratio of this GP? The common ratio of this GP is 1 by 2. So what am I going to do? I am just going to multiply. Here I have taken a different sum. This sum I am finding now. This sum I am finding now. If I am finding this sum, this is going to be denoted as a different term. So I have used that S dash infinity, which is 1 by 4 plus 2 by 8 dot 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 like this till infinity. Now this is AGP. This is not GP or AP. Okay, this is AGP. 1, 2, 3, 4 are in AP. 1 by 4, 1 by 8, 1 by 16, 1 by 32 are in GP. So we have to solve it with AGP approach. What is the AGP approach? We multiply with the common ratio. We multiplied with the common ratio, and this is what we are getting. So 1 by 2 into 1 by 4 will become 1 by 8. This will become 2 by 16. This will become 3 by 32. What will we have? We will have 1 by 4. 2 by 8 minus 1 by 8 will be 1 by 8. 3 by 16 minus 2 by 16 will be 1 by 16. So 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32. This will go on till infinity. This has the common ratio of 1 by 2. Correct? So what is this is sum of infinite terms of a GP. A upon A minus R, 1 by 4 upon 1 minus 1 by 2, which is equal to 1 by 2. So S dash, now S dash infinity is equal to 1. Why? Because here also there is 1 by 2. Remember, here also there is 1 by 2. 1 minus 1 by 2. S dash infinity minus S minus half of S dash infinity. That means 1 minus 1 by 2 will be 1 by 2. So here we have 1 by 2, right? So that 1 by 2 cancels this 1 by 2. S dash infinity will come out to be 1. But S infinity was what was the original sum? 2 to the power of S dash infinity, right? Can we, here we can write it like this, no? This can be written as S infinity is equal to 2 to the power of S dash infinity. S dash infinity is coming out to be 1, right? Okay, now harmonic progression, although very few questions nowadays are being asked, but harmonic progression is an easy concept. Applicable, definitely applicable for mains or advanced, you can say. It depends, like from the data says that the questions are rarely or very rarely asked. If we look at the papers of last 2-3 years, I don't think even one question from HP is there. If there is, it'll be an easy one. What is an HP? Hindustan Petroleum. and harmonic progression is also called an HP. Just give me a moment. I'll just be back. Okay. Harmonic progression. Harmonic progression, what does it mean? A sequence is in HP if its reciprocals are in AP. That means if A, B and C are in AP, then 1 by A, 1 by B, 1 by C are in HP. That's it. This much information is enough to solve the questions of HP. Trust me, I'm not making this up. This much information will be enough. You don't need more than this. Hi Shaurivir, how are you? Hi Dhanalakshmi. Okay. What if it starts from minus infinity to the number? No, it goes to infinity. Okay. Right. So A, B, C are in AP, 1 by A, 1 by B, 1 by C are in HP. Simple thing to understand. 3 numbers are in HP if their reciprocals are in AP. So these 3 numbers will be called as in HP if ABC, that means their reciprocals are in AP. Either way we can understand. Correct. Not very difficult to understand. Either way we can understand that if A, B, C are 3 numbers which are in AP, then reciprocals of these ABC will be in HP. Or we can also say if 1 by A, 1 by B, 1 by C are in HP, then ABC will be in AP. Both things are correct to say or not? Correct to say. Tips to crack IIT mains. Dhanalakshmi, study. Okay, keep stay tuned, keep learning, keep practicing whatever is being taught in the on the channel or wherever you're referring to, but it will require good amount of practice. Not too much, right? But at least all the concepts which are there in main syllabus should be covered, right? Should be covered. Definitely trigonometry is important and we'll take that very soon. Let's not deviate ourselves from the topic. So what are they saying? 1 by 3, 1 by 5, 1 by 7 are in HP. Why? Because 3, 5, 7 are in 3, 5, 7 are in AP. What do I say? That 1 by A, 1 by B, 1 by C will be in HP if A, B, C are in AP. Right? So now if A, B, C are in HP, if B is equal to 2AC upon A plus C. If I am saying that A, B, C are in HP, there is a difference. In the last slide I was saying 1 by A, 1 by B, 1 by C in HP. Here I am saying A, B, C are in HP. If A, B, C are in HP, that means 1 by A, 1 by B, 1 by C. This will be R in AP. These will be in AP for sure. Right? These will be in AP for sure. So now if these are in AP, I can simply say 2 multiplied with this term, that means 2 by B will be equal to 1 by A plus 1 by C. Yes, we have learned this. 2 multiplied with this term 1 by B. 2B is equal to A plus C, right? Or B is equal to A plus C by 2. That's what AP says. Arithmetic progression, we have learned this. 2 multiplied with 1 by B will be equal to 1 by A plus 1 by C. That means 2 by B is equal to A plus C by AC. That means B is equal to 2 times of AC by A plus C. That's how we are getting this. That's how we are getting this. A, B, C are in HP, then B will be equal to 2 times AC upon A plus C. Although for solving these questions, we just need to know that reciprocal is a difficult term. Reciprocaling the terms of HP will give us an AP. That's it. This much is sufficient. Okay. If we can follow this, we'll come up with some approach to solve these questions. Now look, 3, 4, 6 are in HP. 3, 4, 6 if they are in HP, then 1 by 3, 1 by 4, 1 by 6 should be in AP. Check. 1 by 3, 1 by 4, 1 by 6. Are they in AP? Can I say that? Are they in arithmetic progression? 1 by 3 plus 1 by 6 divided by 2 will be equal to 1 by 4. You can check that. You can check that. If 3, 4, 6 are only in, they can be in HP if 1 by 3, 1 by 4 and 1 by 6 are in AP. Right? Because reciprocals of HP will be in AP. Okay, reciprocals of HP will be in AP. Remember this. Okay, understood? 1 by 3, 1 by 4, 1 by 6 will be in AP. And we can check this. 1 by 3 plus 1 by 6 divided by 2 should be equal to 1 by 4. This should come out to be equal to 1 by 4. So this will be 2 plus 1, 3 by 6 upon 2, 1 by 2 upon 2, 1 by 4. Correct. Okay. Now 8th and 14th term of HP are 1 by 2 and 1 by 3. We can easily solve the questions of HP using same concepts of AP. 8th and 14th term of HP are 1 by 2 and 1 by 3. 8th and 14th term of HP are 1 by 2 and 1 by 3. Okay. That means first, like if I want to general, write the terms of HP, how will I write? 1 by A, 1 by A plus D, 1 by A plus 2D, correct, 1 by A plus 3D. This is how I'll write the terms. Why? Because reciprocal of these should be in AP. So these will be the terms. Now what will be the 8th term? 8th term, right? The 8th term or T8 you can write. Right, 8th term will be equal to 1 by A plus 7D. Do you agree? This is given equal to 1 by 2. This tells me that A plus 7D is equal to 2. Also 14th term. 14th term, let's write 14th term is going to be equal to 1 by A plus 7D. That means 1 by A plus 13D. 14th term, right? 14th term is equal to 1 by 3. Simple to write, not a problem. Okay. Now this two equations, two variables, A plus 13D is equal to 3. This is one equation and this is one equation. So I think we can subtract and solve, or anyhow you like, right? We have to find its general term. General term will be, how will the general term look like? 1 by A plus n minus 1 into D. That's it. General term will look like this. So general term you can write using A and D. Find A and D and just write the general term 1 by A plus n minus 1 into D. Nothing else. Okay. So what are the values? Can you tell me in the chat box? Please don't stop posting. Yeah, we won't stop. I'll try my best to keep teaching and keep delivering how much ever I can to help you in your preparations and achievements. Definitely. Stay tuned and keep listening. Can you find the general term here? Come on, comment box. Comment. Right, A plus 7D is 2, A plus 13D is 3. So 7D minus 13D, if we subtract these two, what do we get? 7D minus 13D, that means minus 6D is equal to minus 1. So D will come out to be 1 by 6 and A will come out to be 5 by 6. From here we can say D will come out to be 1 by 6 and A will come out to be 5 by 6. Now you can write the general term 1 upon 5 by 6 plus n minus 1 into 1 by 6. Is that okay? This much. Okay. Like this you can find your general term. So this will come as 5 by 6 plus n minus 1 into 1 by 6. That means this will, the final answer you will get is 6 by n plus 4. Right, you will get final answer as 6 by n plus 4. Okay, now try this one and post your answer in the comment box. I'll just be back in a jiffy. I'll be back quickly, but please post your answers. Whatever you're getting in the comment box, please post your answers. Okay, solve and post your answer. Okay, so 20th term, am I audible? Please confirm if I'm audible. Yeah, must be. Okay, now 20th term is given is 1 and 30th term is 1 by 7. Must have easily solved it, but I don't, yes, I tried, I'm getting 176 by 5. Sir, please solve this. Okay, I'll solve this, not a problem. 176 by 5, I think should be, no, I don't think so. Largest term we have to find. The problem is largest term, but largest term 176, okay, we'll check. I don't remember, but we'll check. If 20th term of HP is 1, that means, what do we understand by this? 1 by A plus 19D is equal to 1, or I can just simply write A plus 19D is equal to 1. Same thing, no? Same thing, not anything different. Now, 30th term is minus 1 by 17. That means, can I directly write A plus 29D is equal to minus 17? Because 1 by A plus 29D will be equal to minus 1 by 17. So, I directly wrote A plus 29D is equal to minus 17. Any problem in that? No problem. This is my equation green, this is my equation yellow. Now, I have to solve the two equations, find the value of A and D. Can you tell me the values? By A plus 19D, A minus A 0, 19 minus 29 minus 10D is equal to 1 minus minus 17. That means positive 18. Right? 90, A minus A 0, 19D minus 29D minus 10D 1. This will be 18. D will come out to be 18 by minus 10. D will come out to be minus 18 by 10. Right? Correct. I think some answers you have posted. Okay. I hope. Alright, so D will be equal to minus 18 by 10, that means minus 9 by 5. Okay, this is my D. Now what will be A? A plus 19 D, 19 into minus 9 by 5. 1 plus 19 into minus 9 by 5. Quickly find it. From here we'll get A is equal to 1 plus D is minus 9 by 5, right? So this side it will come plus 19 into 9 by 5. Calculate this. This should come out to be 176 by 5. A should be equal to 176 by 5. Check once. Please check once. A should be equal to 176 by 5. A will come out to be 176 by 5. And D is minus 9 by 5. Now what is remaining? We have to find the largest term. Now this is problematic. Largest term means how? Largest term, first let's observe the general term. Any general term of this HP will be looking like this: 1 upon A plus N minus 1 into D. What have we found A and D for otherwise? If we have found A and D to find the general term only, otherwise what were we doing with A and D? Right, general term only we need to write. General term will be 1 by A plus N minus 1 into D. That means 1 by A, that means minus 9 by 5 plus N minus 1 into minus into 1, oh sorry, A is 176 by 5, right? We have written wrong. A is 176 by 5 plus N minus 1 into minus 9 by 5. This is what we are going to get. And this will solve up to 5. 5 will go up. 176 minus 9. 176 plus 9. So 185. 185 minus 9n. Right? Minus 9n. Minus 9n. So 5 by 185 minus 9n. That's what we are getting. Correct? Now, this is my general term. That means any term if I have will be of this form only. Largest term they are asking. Largest term. This particular thing will be largest when the denominator is smallest. Any fraction, when the denominator is smallest, then only the value of the fraction is largest, right? So this number has to be the smallest. Now how will I make this number smallest? Okay, if I take 9 into 10, 185 minus 90, okay, 9 into 20, 185 minus 180. If I take n as 20, what will I have? 185 minus 180. If I take n as 21, 21 into 9. If I take n is equal to 21, 21 into 9, no, it will go above 185. That means this term will become negative. Negative, we don't have. This term will become negative, but we want the largest term. Largest term means this denominator should be maximum. This denominator should be maximum. If I put 9 as 1, 2, 3, at 20, 9 equal to 20, I'll have 5 here. Right? 9 equal to 20, at 9 equal to 20, I'll have 5 over here, and that will help me. If I put 9 is equal to, n is equal to 21, what will I have? (189). 185 minus 189, negative. That is not largest. So that means only value. I can take n is equal to 20. That's it. I can take n is equal to 20, and when n is equal to 20, that means 20th term is going to be the largest. 5 upon 185 minus 20 into 9, 180, that means 5 only. So this is going to be 1. That means 20th term, which is 1, is going to be the largest term of this entire HP. Clear everybody? Okay. Okay, sum of HP, no need to get into that. How much do you want? There is no generally defined or general formula for finding the sum of HP. Thank God, sir. One more, otherwise one more thing will come up. Okay, so there is nothing like that. Now, very important concept, arithmetic mean, geometric mean and harmonic mean. First of all, arithmetic mean. Arithmetic mean, many of you must have understood arithmetic mean as general arithmetic means. Suppose we have 10 terms, sum of all the 10 terms divided by 10. Suppose we have n terms, so sum of all those n terms divided by n. That's what we are going to have, right? So, AM of numbers, generally, if I have x1, x2, x3, x4, x5, so I'll add all of them and divide by the number of terms. AM of x1 and x2 will be x1 plus x2 by 2. Okay, and we also know one thing or understand one thing, if A, B and C are in AP, then B is equal to A plus C by 2. Can I say that? That means B is the AM of A and C. Correct? Arithmetic mean of A and C. If there are more numbers x1, x2, x3, 3 numbers, then x1 plus x2 plus x3 by 3 will be the AM of 3 numbers. Now, there is one more concept. One is arithmetic mean and one is putting arithmetic means between two given numbers. For example, suppose A and B are two given numbers to me. Okay. There was a chapter rational numbers, in that suppose if you have to put rational numbers between 2 and 3, how do you do it? 2 plus 3 by 2, that means 5 by 2, 2.5. Then you will do 2 plus 2.5 by 2, one more average you will get. Here also you will get same, almost similar thing you will be doing over here. Now, what does AM between A and B mean? Means you have to put such numbers between A and B that all complete sequence of these numbers should become an arithmetic progression. Sir, didn't understand. Explain again. What does it mean? It means that suppose if this is A, this is B, and if I am putting, let's say, A1, then I know A1 will be equal to A plus B by 2. But this time I don't just want to put one arithmetic mean. I want to put many arithmetic means. A1, A2, A3, A4, A5 and till AN I want to put between A and B, I want to put n arithmetic means. Okay. One arithmetic mean means A1, two arithmetic means A1, A2. Right? 3 arithmetic means, 4 arithmetic means, and this means n arithmetic means between A and B. Okay, simple to understand. Now, okay, sir, A1 will be equal to A plus D. Acha, what does it mean? It means that A, A1, A2, A3, A4, A5, all these are in AP. When I am saying A, A1 and B, A1 is the arithmetic mean of B. When I am saying A1 is the arithmetic mean of B, that means A, A1, B are in AP. Correct? When I am saying A1, A2, A3, A4, AN till AN are the n arithmetic means between A and B, that means that A, A1, A2, A3, all these are in arithmetic progression. So, can I say that A1 is equal to A plus D? Can I also say that A2 is equal to A plus 2D? And similarly, AN will be equal to A plus ND. Simple to understand. Right? Okay, sir. So, can we also say that B will be equal to AN? That means last arithmetic term plus D, because they are in AP. Common difference should be same. A1 should be equal to A plus D. Then B should be equal to AN plus D. What is AN? Sir, AN is equal to A plus ND. That means B minus A divided by ND plus D also, right? A plus ND plus D divided by, here we will have n plus 1, D into n plus 1. So, this will be n plus 1 is equal to D. This is what we are going to use. Okay. This we might need to use. So, all the M's, or A plus this D, A plus 2 times of this D, A plus, you must have been familiar with this formula also. Somewhere or the other in your curriculums you must have seen this formula, but this comes from here. We understand that all the AMs, this B will be equal to last AM plus D, and that's how we get D is equal to B minus A upon N plus 1. Okay. So, arithmetic mean is called one mean between this. Alright. In generally if you want, the main thing, the main target in arithmetic mean questions, direct arithmetic mean question should be finding D. Finding D. And what will be D? Difference of two numbers divided by number of AMs inserted plus 1. Simple thing. Number of AMs inserted plus 1. That's how you are going to find D. Okay, try this. AK is equal to A plus KD. AK is equal to A plus KD means any kth mean, arithmetic mean will be A plus K time D, not K minus 1D. Why? Because A1, remember here, A1 is equal to A plus D, A2 is equal to A plus 2D, AN is equal to A plus ND. So, AK will also be equal to A plus KD. Remember this. Okay, sometimes we make a mistake in this simple concept only. Alright, try to insert arithmetic means between 3 and 19 and comment. Hi Vihan. Yeah, same here Vihan, and I could not, you have to understand that I could not inform. Ping me. We'll talk. Give me a moment. Insert 3 arithmetic means between 3 and 19. So, how simple can that be? First, we will find D, that is 19 minus 3 upon 3 arithmetic means, so 3 plus 1, right? B minus A upon N plus 1. N means how many arithmetic means are you inserting there? So, what will we get for D? We will get D equal to 16 by 4, that is 4. D equals 4 we will get. Now, if D is equal to 4, then 3 plus 4, 7, 7 plus 4, 11, 11 plus 4, 15, 15 plus 4, 19. That means 7, 11 and 15 are 3 AMs between 3 and 19. Simple thing to understand, right? Now, if we see 11 plus 3 by 2 will be 7, 7 plus 15 by 2 will be 11, 11 plus 19 by 2 will also be 15, right? So, these middle terms will be the individual AMs of the extreme, the corner, the neighbor terms of them. You can say that. Alright, next thing. Next. Now, see a question based on AMGM only, which came in JEE. If n arithmetic means are inserted between A and 100, such that the ratio of first mean to the last mean is 1 by 7 and A plus N is equal to 33, then find the value of N. Okay, A plus N is given to us this time. What are they saying? First of all, n arithmetic means are inserted between A and 100. N arithmetic means are inserted between A and 100. A and 100, that means there is A and there is 100 and there are A1, A2, A3, A4, A5 and so on till AN. Okay. We have this. Now, next information what they are saying. Let's first try to interpret what the question is saying. So, simple thing question is saying that there are n AMs inserted between A and 100 such that the ratio of first mean, that means A1. What will be A1? A plus D. But I need D first. First, don't you think we should first find D? It's better that we first find D. And D is just simply going to be 100 minus A upon N plus 1. This is going to be my D. So now first A1 is going to be A plus D. That we also know. Then A1 will be equal to A plus 100 minus A upon N plus 1. Okay. A1 is equal to A plus D and AN will be equal to 100 minus D. That also we can say. One more thing we can say here, AN will be equal to 100 minus D. That also you can say, and you can use that. Now, such that the sum of first mean to the last mean is AN, 100 minus D, right? Or instead of, what I can do is, better idea is that A1 by AN I am writing, right? So, A1 by AN is 100 for me, 100 minus D. And they are simply asking me the ratio of first mean and last mean. That means they are asking me A plus D upon 100 minus D. This is what they are asking me, which is given equal to 1 by 7. This is given equal to 1 by 7. What can I find from here? We can find a relation in A and D. We can find a relation in A and D. What will be the relation? 7A plus 7D is equal to 100 minus D. So, 7A plus 8D is equal to 100. Are we getting 7A plus 8D plus 8D is equal to 100 we are getting. This is what we are getting. A relation between A and D. But D I already know in terms of A. Isn't it? D I already know in terms of A and also in terms of N. Correct. So, here what I am going to do, 7A plus 8 times of 100 minus A divided by N plus 1 is equal to 100. This is what we are going to have. One relation. Another relation is given to me. A plus N is equal to 33. Second relation I got. Number 1, number 2, solve. Both relations are between A and N. You can solve using the, I think quadratic will be formed. N can be 33 minus A if we'll put. Yeah, quadratic should be formed in terms of N, right? So, you'll take N as, or you'll take A as 33 minus N. So, here you'll put A as 33 minus N. Form the quadratic. Let's see. What answer do we have? 7A plus 8 into D, same thing, yes, is equal to 100. Same equation we are getting, right? Okay. So, A plus N is equal to 33, second equation, and then there will be a quadratic form. N is equal to 23 or N is equal to minus 29 by 7. N cannot be minus 29 by 7 because it is representing the number of arithmetic means inserted. It has to be natural, definitely. So, this will be our correct answer. Sum of n AMs inserted between A and B is equal to AM of both A and B. Result, this observation or this result is important. What does it say? That sum of all the n AMs, suppose from A to B, if I am putting A1, A2, A3, A4 till AN, then sum of all these ANs, all these AMs, the sum of n AMs between A and B is equal to n times of A and B. How? N times of A and B, n times AM of A and B, n times AM of A and B. How? Let's see. The sum of this A1 will be, sum means sum of AMs means a plus d first, then a plus 2d, then a plus 3d till a plus nd. Okay. How many AMs are there? How many terms are there? There are n by 2 terms. So n by 2 multiplied with first term, 2 times of first term. This is an AP, right? Sum of all AMs is AP. So we can apply the sum formula. So n by 2 into 2 times of first term. That means 2a plus 2d. 2a plus n minus 1 into d plus n minus 1 into d, that means nd minus d. Now, what does this look like? This looks like n by 2 into 2a plus 2d minus d and n plus 1 into d. Okay. So what? This can be written as n by 2 into a plus n plus 1 into d. Now pay attention at one thing. This b is an plus d. This b is equal to an plus d, right? An is a plus nd. B will be equal to a plus nd plus d. So a plus nd plus d, a plus n plus 1 into d. B will be equal to a plus n plus 1 into d. So that is why we are saying it will be equal to n by 2 into a plus b. That means the sum of n AMs, sum of all these AMs between a and b is equal to n times AM of a and b, n times the arithmetic mean of a and b itself. Get my point? Important result, can be useful or not, but yeah, we should know this. Some questions can be solved directly using this. Okay, some questions you will be able to solve directly using this one. Okay, for example, over here A, B, C, D, E, F are AMs between 2 and 12, then find the sum of A plus B plus C plus D plus E plus F. So sum of all AMs will be equal to how many? 1, 2, 3, 4, 5, 6. So 6 by 2 into first in plus last. So 2 plus 12 divided, multiplied with 6 by 2, directly you are getting answer as 42 in such cases. Now geometric mean, again important and applicable. First most important thing is that it is always defined only for positive numbers. Geometric mean is only defined for positive numbers. If x1, x2, x3 all are positive, then only we can define geometric mean. Geometric mean of two numbers x1 and x2 will be x1 into x to the power 1 by 2. For example, A, B, C, if they are in GP, then we say, right, B is equal to AC, square root AC, or B square is equal to AC, same thing. So we can also say B is equal to AC to the power 1 by 2. Correct. B by A is equal to C by B. That's how we do it. So geometric mean of two numbers A and C will be A into C divided to the power 1 by 2, and it will be equal to B, that we already know. So geometric mean over here, what will it mean? Geometric mean of two numbers will be x1 into x2 to the power 1 by 2. Geometric mean of three numbers x1, x2, x3 will be x1 into x2 into x3 divided to the power 1 by 3. Now G1 is called 1 GM between A and B if A, G1, B are in GP. 1 GM if you want to insert, that will be called G1. If you want to put G1, if you want to put 2 GMs, then what will be the scenario? In that case, G1 and G2. If you want to put 2 GMs, then G1 and D2. If you want to put n GMs, then G1, G2, G3, G4, Gn. So n GMs will look like G1, G2, G3, G4, like this. Okay, two different meanings, pay attention here. One is geometric mean of numbers. Geometric mean of numbers means numbers multiplied to the power of 1 by number of terms being multiplied. Okay, and here we are inserting geometric mean. Geometric mean between two numbers means we are inserting geometric mean. Here G1 will be equal to square root of AB. Okay. Now next thing, If n GMs G1, G2, Gn are inserted between AB, then R will be equal to B by A to the power of 1 by n minus n plus 1. It will be to the power of 1 by n plus 1. How? How? For example, suppose if I am putting between A and B, if I am putting G1, G2, G3, G4 till Gn. Okay. Now, main purpose over here is to find R. Find R so that we can put these GMs. Like for putting AMs, we were finding D. Here for putting GMs, we'll find the R. Now, G1, can I call G1 as AR? Can I call G1 as AR? Can I call G2 as AR square? Can I call G3 as AR cube? Gn as AR to the power n. Can we do that? Correct? So, AR to the power n multiplied with R, if I'll do, I'll get B. Then R will be equal to B by A, R to the power n plus 1. Here R to the power will get n plus 1. Can I say AR to the power n multiplied with R will give me B, right? So, AR to the power n, R to the power n plus 1 will be equal to B divided by this A. That means R, from here I am getting simply R is equal to B divided by A, power when shifted, that means reciprocal by n plus 1. That is why we are saying R is equal to B by A upon 1 by n plus 1. And any kth GM will be equal to AR to the power K. Any kth GM between the two numbers will be called as A, first number, into R to the power K. That's it. And main sole purpose over here should be to find R. Insert 4 GMs between 486 and 2. Simply find R. Nothing else. 486 divided by 2. What is R? B by A to the whole power of 1 by n plus 1. N is 4. 1 by 4 plus 1, that means 1 by 5. That means this is 243 to the power of 1 by 5. That means 3. R is 3. Right? First term 2. 2 into R, that means 6. 6 into R, 18. 54. And you can put 4 GMs simply like this. Alright. Two is not GM. 2 is not GM. Okay, 2 is not GM. First GM itself is 6. Okay, first GM is 6. 2 is not GM. 2 between 2 and 486 we are putting. First GM is 6, then 18, then 54. 54 into 3 if we'll do 162 we'll get 162. So 4 GMs will be this. Okay. Again, a previous year question. Let's see if we can solve it or not. If m arithmetic means and 3 geometric means are inserted between 3 and 243. M arithmetic means and 3 geometric means are inserted between 3 and 243 such that 4th AM is equal to 2nd GM. A lot of information is given to me. I should be happy. I should be happy because a lot of information is given to me. M AMs are and 3 GMs. So, if M AMs are inserted, M AMs means D of the AP will be, we can directly find D from here. If we know M AMs are inserted between 3 and 243, that means D will be equal to B minus A, that means 243 minus 3 upon M plus 1. M plus 1, correct. Now, if D I have got, next purpose is to, this will be 240 divided by M plus 1. This is my D. This is my D. Now, I can find the AMs with the help of D. Next purpose should be to find R. R will be 243 B by A to the whole power of 1 by n plus 1. How many geometric means we are inserting? 3. So, 1 by 4. This is 3. So this will give us 81 to the power 1 by 4, again 3. R will be 3, D is this. Now, 4th AM, next information which is given is 4th AM. That means 4th AM means A4, correct? And second GM. What will be second GM? Second GM is going to be G2. What is A4 going to be? A plus 4D. A plus, not A plus 3D. Okay, do not make that mistake. It will be A plus 4D. First AM will be A plus D, like that. Okay, second GM will be G2, second GM. That means AR square, right? AR square, that means A into R square. This will be my 4th AM and second GM. Now 4th AM is equal to second GM. That means A plus 4D. A plus 4D is equal to AR square. A is 3. 3 plus 4D, that means 3 plus 4 into 240 divided by M plus 1 will be equal to 3 into 3 square. That means 9. Okay. With this, I think we can solve the value. So we'll get 27, 27 minus 3, 24, 24 by 4. 6 4s are 24 again. So we'll get 40 by M plus 1 is equal to 1. So 40 will be equal to M. So directly we are getting, right? M is equal to 39 we'll get. We'll get M is equal to 39. What did we use? As you see such a question where you're inserting AM and GN between given numbers, and numbers are also given to you. First motive, first step should be finding the D and the R. The first step, the first approach which you should follow without even blinking an eye, without thinking, do this. In such a question, in such a case, in case of such a question. Alright, 39. Product of n GMs between A, B is equal to nth power of GM of A and B. Product of n GMs. That means G1, G2, G3 till Gn. All this product will be equal to nth power of GM of A and B. What is GM of A and B? GM of A and B is root AB and to the whole power of n. This is what. Try proving this. You can easily prove this. Use this as A. This is AR square, AR cube till AR to the power n, and use R is equal to B by A upon B by A to the whole power 1 by n plus 1. You will be easily able to prove this. Just remember that product of all the GMs is equal to GM of the two numbers in which we are putting GMs between to the whole power of n, right? If we are putting n GMs between, I'll rephrase it again. If we are putting n GMs between any two numbers A and B, let's say, then product of all those GMs will be equal to the GM of A and B, which is square root A by B to the whole power of n. N is number of AMs that we have inserted. Useful, sometimes you might get to use this, so remember this, okay? And you can easily derive this also, not a problem. We can try, okay? This will be AR, this will be AR multiplied with AR square multiplied with AR cube till AR to the power n. So A into A n times, right? A to the power n, right? And then we are getting R to the power 1 plus 2 plus 3 plus till n, correct? R to the power 1 plus 2 plus 3 plus 4 plus till n. What is this? N into n plus 1 by 2, right? And this so A to the power n multiplied with R, which is B by A to the whole power of n into n plus 1 divided by 2. Correct? Now you can solve this, I think. So n by n square, sorry, we have missed one step. R is b by 8 to the power 1 by n plus 1, right? This will have the whole power as n into n plus 1 divided by 2. Sum of natural numbers is n into n plus 1 divided by 2. So here n plus 1 will get cancelled. And finally, we are going to have a to the power n multiplied by b by a to the whole power n by 2. Right. So a to the power n minus a to the power n divided by a to the power n by 2 will be a to the power n minus n by 2, that is n by 2. So this will come out to be a to the power n by 2 multiplied with b to the power n by 2, which is nothing but square root of ab to the whole power of n. Hence proved. Harmonic mean, although we won't get to use this, but still listen, let's know what does it mean. So in case if somewhere out of the blue it comes in exam, we must be able to apply it at least. Correct? Okay. 2 upon 1 by x1 plus 1 by x2. Which question are you asking, question mark? Okay. Is that question solved? I hope. Okay. x1, x2. hm of x1, x2. hm of x1, x2 will be 2 by 1 upon x1 plus 1 by x2. Can be simplified this. hm of x1, x2, x3 will be 3 by 1 by x1, 1 by x2, 1 by x3. Remember this. hm of x1 and x2, hm of a and b. hm of a and b will be 2 upon 1 by a plus 1 by b. Remember that. And hm of x1, x2, x3 will be 3 upon 1 by x1 plus 1 by x2 plus 1 by x3. Just remember this much. Okay. You can definitely get this reciprocal and it will form an AP. That means if x1 and x2 are HMs, that means 1 by x1, 1 by x2 will be in AP. Okay. H1 is called 1 HM between A and B, and H1, H2 if we are putting, then there will be 2 HMs between A and B. Now, main thing, what is the main thing here? Why are we learning about AM, GM and HM? We are learning to actually see the inequality between AM, GM and HM. What is the inequality? It says that AM of two numbers is always greater than or equal to GM, and that is always greater than or equal to HM. That means if numbers are A and B, then A plus B by 2 will always be greater than or equal to square root AB. And that will be always greater than equal to 2 by 1 upon A plus 1 upon B. Okay. We can also write it as 2AB upon A plus B. AB upon A plus B we can write. This relation of AM, HM and GM, AM, GM and HM is going to be used multiple times in this class, in this chapter and the further chapters, many other chapters, right? Wherever you have to, wherever you see questions which are involving to find, which involve the finding of minimum and maximum, right? So there are many cases where you'll simply use AM, GM inequality and you'll be able to easily find maximum or minimum. Many times, not all of the times. For different type of expression, there will be different approach, but yeah, this is a foolproof approach to find. We'll also see in the questions. For any given positive numbers, AM is great, most important. HM, let's keep HM apart for a while and pay attention on AM and GM. AM is always greater than or equal to GM. Greater than or equal to. I just now told, right? A plus B by 2 is always greater than or equal to square root of AB. Or I can also say A plus B is greater than equal to 2 root of AB. Okay. Now, when will they be Greater than, okay, we can understand. Greater than, we can understand. But when will they be equal? That is main thing to understand. AM is equal to GM if all the terms are equal. That means if I put A plus A by 2, that will be equal to square root of A into A, isn't it? A plus A by 2, 2A by 2, A is equal to A square square root, that means A. That means the equality will hold when the terms which we are using in AM/GM are equal. Terms which we are using in AM and GM that are equal. For example, if we have x1 plus x2 plus x3 plus x4 by 4 greater than equal to x1, x2, x3 and x4 to the whole power of 1 by 4. This will always be greater than this one. This can be equal if x1, x2, x3 and x4 are equal terms. Understood? Shall we move ahead with questions? Simple thing to understand. Let's move ahead. When to use, most important thing is when to use AM/GM inequality. 3 key points. If minimum value of some expression is asked, minimum, sometimes maximum also it will work. If minimum value of some expression is asked, use it, right? Terms involved, whatever terms involved in, yeah, very important thing, I think I told you, right? This AM is greater than equal to GM. Inequality we are only going to use for positive numbers because GM itself is defined for positive numbers, right? Now, so if terms involved in expression are positive, then that means, then that's a hint that we have to use AM/GM inequality. Third point, product of terms involved in expression is good. Good means constant. Good means constant. Okay. By good we means then product of the terms involved. If we multiply all the terms, then the product should be constant. We should get a constant. Let's understand with the help of a question. Find the minimum value of 4 to the power x plus 4 by 4 to the power x. Terms. Minimum value of this. Let's say my two terms. This 4 to the power x is one term and 4 by 4 to the power x is one term. If these two are terms, then the AM of these two terms, that means 4 to the power x plus 4 by 4 to the power x by 2, the AM will be greater than or equal to. Now, first I didn't check. Before writing this, my step should be first check the terms involved, if their product is constant or not. 4 multiplied with 4 upon 4 to the power x, 4x, 4 to the power x, 4 to the power x will cancel and 4 will remain. So yes, it is constant. We are getting a constant product here. So we are good to go with this particular inequality. Get my point? We are good to go with this because product is constant now. Product is making us feel good, making us confident. When will it make us confident? When the product is some constant term, something constant. Okay. Right. How long? Yeah, this will go a bit more. Yeah, 2 hours, 3 hours. It's okay. I already told you in the starting, right? It's a long chapter. So it is going to take long time. So you should have taken some cushion to sit upon and with notebook and pen. Obviously, see, being a JEE aspirant, we should have a habit of increasing our attention time span. Keep increasing your attention time span to more and more. That is one major key to crack this exam. Definitely is. Learning time span. If it's okay, you can although watch this video in parts, later on it will be there on YouTube, but still like 2 to 3 hours, definitely without that much, 3 hours minimum. Do not get up before that. Otherwise, what will you do in the exam? How will you crack it? Okay. Now, this is greater than square root of 4 to the power x into 4 by 4 to the power x, cancelled 4. That means what am I getting? 4 to the power x plus 4 by 4 to the power x greater than or equal to square root of 4, 2. 2 into 2, 4. Very nice. That means minimum value. It is always greater than equal to 4. It is always greater than equal to 4. That means minimum of 4 to the power x plus 4 by 4 to the power x is equal to 4. It is always greater than or equal to 4. So the minimum value is 4. One more thing I told you, that minimum value means when it holds the equality. What does minimum value means? Minimum value means when this particular expression, when this particular inequality holds the equality. When this particular thing holds the equality. When will it hold the equality? When AM will be equal to GM. And when will AM be equal to GM? AM will be equal to GM when the terms are equal. That means 4 to the power x is equal to 4 by 4 to the power x. When will it be possible? It will be possible when 4 to the power x into 4 to the power x, that means 4 to the power 2x is equal to 4. That means x is equal to 1 by 2. Base is equal. Power 2x will be equal to 1, x is equal to 1 by 2. Put x is equal to 1 by 2 here. That means equality will hold at x is equal to 1 by 2. Very important thing to understand actually. Very small but important thing to understand. This way also we'll be able to find the minimum in shorter time. This way we'll be able to find the minimum in even shorter time. Trust me, because put x is equal to 1 by 2. 4 to the power x, that means 4 to the power 1 by 2 plus 4 upon 4 to the power 1 by 2. 4 to the power 1 by 2, 2 plus 4 upon 2. That means 2 plus 2, which is 4. And yes, we got the same answer. 4 is the minimum value. 4 is the minimum value, isn't it? Now, this one. Okay, 3 values are there. Now, first check. When will we apply? First condition, that the product is constant. Acha, first condition, even before that, are they all positive? Are they all positive? It is given. Here also it was positive. We didn't check, although. Right? I'm sorry to not notify that, but see, 4 to the power x, base is positive, so this is positive. 4 by 4 to the power x will also be positive, because be x positive or negative, x is 1, then also positive, x is minus 1, then also positive. Terms are positive. That is why we have applied. Terms are positive, product is good. Right? These conditions. Minimum value was asked, that we know already. Terms were positive and product was constant. So that is why we are using AM-GM inequality. Here again, if they are of same sign, then this will be positive, this will be positive, this will be positive. Okay. Product x by y into y by z into z by x. What are we getting? Y cancelled, z cancelled, x cancelled. 1. Amazing product. Not even good, it's the best. The most favorite number of our lives is 1. Okay, now x by y plus y by z plus z by x divided by 3 is equal to x by y plus y by z, oh sorry, not plus, multiplied with y by z multiplied with z by x to the whole power of 1 by 3. 3 terms are there, no? Right? So this cancelled, this cancelled, everything got cancelled. We'll get 1 to the power 1 by 3, which is 1 only, and this 3 will shift that side. This is always greater than or equal to, not equal to. X by y plus y by z plus z by x will always be greater than this 3. 1 to the power 1 by 3 will be 1, 3 into 1 will be 3. It is always greater than or equal to 3. That means minimum of x by y plus y by z plus z by x is equal to 3. That's it. And we can, when will this happen? If we use the other approach which we are asking, when will this happen? When all the 3 terms will equal. Minimum will be obtained when equality holds. When it is equal to 3. When will it be equal to 3? When all the 3 terms are. When will AM be equal to GM? Not 3. AM will be equal to GM when all the terms are equal. All the terms involved are equal. That means x by y is equal to y by z is equal to z by x. All the three will become 1. Right? This will happen when all the three becomes 1. That is why 1 plus 1 plus 1 will become equal to 3. Right? Xz is equal to y square and z square is equal to yx. If you will put any value from one side to another side, you will get x, y and z all are equal to 1, and 1 plus 1 plus 1 is giving us 3. Simple to understand. Okay. All right. Now, important observation. Important observation, x plus, this you know already, x plus 1 by x divided by 2 will be greater than equal to square root of x into 1 by x. Right? Square root of x into 1 by x. And this 2 went there. Right? So, this gives us that x plus 1 by x is always going to be greater than equal to this 2 into square root 1, that means 2. You can prove this easily. When x is greater than 0. This is the case when x is greater than 0. Now, if x is less than 0, put instead of x, just put minus x. You will get this one. You will get this one. Minus x minus 1 by x will be less than or equal to 2. Okay. Now, find the minimum value of this expression when x, y, z all are positive. If they all are positive, no problem. Product will check x by y by x, y by z, z by y, x by z, z by x. If we will multiply all of them, everything will get cancelled. What will remain? 1. Simply I can find the answer, x by y plus y by x plus y by z plus z by y plus x by z plus z by x. How many terms? 6 terms divided by 6 is greater than equal to product of all of them. So, product is 1. Right? I am not writing the product. Product of all of them is 1. 1 to the power of 1 by 6 is also 1. So, there is no need of writing 1 by 6. This 6 will go that side. So, basically it is going to become greater than, this thing will become greater than equal to 6. So, the minimum value is 6. Simple to understand. In this case, what can we do? We will open the bracket. Wait, in this case, we are not, product is given, no. Product is given to us right now. Product of two numbers, there is no addition, like terms are not separated. So, we will see how can we simplify this particular expression. So, x plus y plus z divided by x plus y plus z divided by y plus x plus y plus z divided by z. This is the expression and we have to find the minimum value of this. Achha, can we write x by x 1 plus y by x plus z by x plus y by y will be 1. So, 1 plus x by y plus z by y plus z by z will be 1. So, x by z plus y by z plus 1. Now, 1 plus 1 plus 1 will give us 3. 3 plus y by x plus z by x plus x by y plus z by y plus x by z plus y by z. Okay. Now, minimum value of this if I can find, I will just add 3 into that and then the minimum value of this entire expression will be obtained. What is the minimum value of this one? Let's check. So, this minimum value of this one will be entire of this, that means y by x by 6 greater than or equal to product of these, x cancelled, right, z by x by y, maybe I've written something, z by x here, yeah, everything is getting cancelled, everything is getting cancelled. So 1 and then this 6 multiplied is 6. Then what will I do? I'll just add this 3. The minimum value of this expression is 6. So if I add 3 here, I'll have to add 3 here also. Then minimum value of this entire expression will be 6 plus 3, that is always greater than equal to 9. Minimum value will be equal to 9. Last question only, right? Okay. This one can be x, y, z are positive and distinct numbers, then prove that x plus y, y plus z and z plus x is greater than 8xyz. 8xyz. Why are they not saying equal to, greater than or equal to? Generally it should be, the feeling, because we are doing AMGM inequality, the feeling should be that it should be greater than equal to, but it's not, and the reason is quite clear, because they are distinct numbers, different numbers, so it's not going to be equal to. The equality is not going to hold because numbers are different. How can we prove this? We know x plus y will be greater than equal to, not equal to, let's not put equal to because x and y are not equal. So x plus y will not put equal to, equality won't hold because the terms are not equal, it's already given, these are distinct numbers. Pay attention at these small points. Okay, these only will save our marks, like give us marks. Okay, x plus y is greater than 2 times of square root xy. Similarly, y plus z is greater than 2 times of square root yz. Similarly, which color? Okay, z plus x is greater than 2 times of zx. Now what? Multiply all the three. That's what the question is asking. Straight away it is giving the hint, right? X plus y multiplied with y plus z multiplied with z plus x will be greater than equal to 2 into 2 into 2, 8, square root of x square, y square, z square. That means it is always greater than equal to 8 times of x, y, z. Not equal to. Only greater than. Why only greater than? Because equality is not going to hold. X, y, z are distinct numbers, different numbers, clearly mentioned. Okay, now try this one. Oh, gave the answer already. The button clicks from my hand. I'm so sorry for that. Okay, 40, 41, 80, 81. The minimum value of 25 sec square theta plus 16 cosec square theta is given by. Now in this way, can you say something, like can you say something how to find the minimum value with AM and GM inequality? Although we are reading that chapter, so the basic idea is we should use that, but how? How is that going to happen? Simply, can we write sec square theta as 25 into 1 plus tan square theta? We know that already from previous classes. Cosec square theta, that means 16 multiplied with 1 plus cot square theta, and this gives me a good feeling. Why is it giving me a good feeling? Because I know tan and cot are reciprocal of each other. Their product is going to give me something good at least. That should be the feeling. That should be our approach. Okay. Now after this, 25, let's open this, right? 25 plus 25 tan square theta plus 16 cot, 16 cot square theta. This minimum value of this 25 plus 16, 41, we are getting 41 plus 25 tan square theta plus 16 cot square theta. After this, how to use AM-GM inequality. Come on, tell me in the comment box how to use the AM-GM inequality in this case. Very simple, right? We can find the minimum of this. Can we find the constant term? Anyway, we don't need to bother. We'll add or subtract that later. We need to bother about this one. We need to think about this one. How do we think about this part? So, let's write this separately. I want to find the minimum value of 25 tan square theta. We are finding the minimum of 25 tan square theta plus 16 1 by tan square theta. Can I write 16 by tan square theta? Why am I doing this? Because when I am going to multiply it, multiply these two terms, I am going to get a constant, because tan square theta is going to get cancelled. So 25 into 16 I am getting. Good. That's what I wanted to apply AM-GM. Sum of these two divided by 2, or shall I directly write, should be greater than equal to 2 into square root of 25 tan square theta multiplied with 16 by tan square theta. Good. This dot cancelled. 25 into 16 square root, 5 into 4 20, 20 into 2 40. Right. So 25 tan square theta plus 16 cot square theta, I am writing it same again, will be greater than or equal to 20 into 2, 40, will be always greater than equal to 40. Get my point? Will be always greater than equal to 40. So, what do I want? Do I want this? The minimum value of this part is always greater than equal to 40. So, minimum value of entire part will be always greater than equal to 40 plus this 41. Right, we add this 41 separately. Minimum value of this we found as 40. Right, this is minimum at 40 and total will be minimum at 41 plus 40. So, that is 81. Get my point? Right, what did we do? We observed that we created tan and cot so that reciprocal make the product as constant. That should be the idea. Okay, now let's move to the relation between AM, GM and HM with a different perspective. Different perspective means sometimes, your expression might look like this. For example, if I have A plus A plus A plus B divided by 1, 2, 3, 4, 5, 5 terms are there, right, will be greater than equal to A cube. A into A will be A cube multiplied with B square to the whole power of 1 by 5. Can I say that? Product of all these terms, A cube B square to the whole power of 1 by 5. That's what is written over here. Suppose there are W1 A1s. Right? So here what is it? 3A plus 2B divided by 5 is greater than equal to A to the power 3 into B to the power 2 to the whole power of 1 by 5. Correct or not? Right? Understood? What do we mean by that? We'll understand more after using it. When we'll be using it, we'll understand this more. Don't worry about it. How to use it? For example, this is a question. A plus B plus C is equal to 3 where A, B, C are positive. Then prove that A square B cube C square is less than equal to 3 to the power 10 into 2 to the power 4 upon 7 to the power 7. Okay. A plus B plus C is given to me. A plus B plus C is given to me. What do I want? If I want this A square B cube C square, what will I have to do? I'll have to do A plus A plus B plus B plus B plus C plus C. That's what I'll have to do, right? 3 plus 2, 5 plus 2, 7 divided by 7. That will be greater than equal to, this will give me greater than equal to A square B cube C square to the whole power of 1 by 7. Then I can create something like this. Only then I can create something like this. So my idea should be, okay, I want two A's. I want two A's, right? So let me take like this. I want two A's, so I'll write 2 into A by 2 plus 3 into B by 3 plus C. That means 2 into C by 2. What if I write like this? 2 into A by 2 means A by 2 plus A by 2. 3 into B by 2 means B by 3 plus B by 3 plus B by 3. 2 into C by 2 means C by 2 plus C by 2 divided by 7. 2 plus 3 plus 2, that's what it is saying, right? Divided by W1 plus W2. That means W1 times A1 is coming, W2 times A2 is coming, and denominator, in the denominator we'll have W1 plus W2. That's what we are doing. 2 into A by 2, total divided by 7, right? There are 7 terms. Now there are 7 terms. What are the terms? A by 2, A by 2, B by 3, B by 3, B by 3, and C by 2, C by 2. This should be greater than equal to what? A by 2 to the whole power of, A by 2 to the whole power of 2 into B by 3 to the whole power of 3 into C by 2 to the whole power of 2. Correct or not? And this thing to the whole power of 1 by 7, because 7 terms are there. Getting my point or not? Right? 7 terms are there, so this should be raised as, now what is this? This we know, right? This is A plus B plus C. This we know, this is A plus B plus C. Simple, right? So write it as 7. 2 into A by 2 is A plus B plus C. So this is given to us 3. 3 by 7 will be always greater than equal to A square by 2 square 4 into, okay, we have to get in 2 powers, right? So let's keep it 2 to the power 2 into B cube by 3 to the power 3 into C square by 2 to the power 2. And look, to the whole power of 1 by 7. Now this whole power of 1 by 7, I don't like this, so I am putting it this side. Here 1 by 7, so this side it will be 7. So now see, A square B cube C square, A square B cube C square will be equal to 3 to the power 7 into 3 to the power 3, that means 3 to the power 10, right? Correct? Now 2 to the power 2 into 2 to the power 2, that means 2 to the power 4, and denominator we have 7 to the power 7. That's what we wanted, the minimum value, right? This is what we wanted to prove. So approach is important, how you have to approach, that is what we are learning over here, right? That is what we are learning. Approach is important. When we get a question like this, how to break it into the form which we know, which is familiar to us. That is the most important thing which we need to learn while learning this chapter or any other chapter in mathematics, right? And approach builds with practice. Trust me, without practice it won't build. So please keep practicing. That's the most important thing which I'd like to say. Okay, next one. This one, see, it came in 2023 and we can simply solve this. We can simply solve this with what we learned just now. The thing is that we should be able to see that this A plus C plus A plus B plus C plus D is given to us, and their A, B, C and D are given to us in with powers multiplied with some exponents. Okay, no problem. So I need A to the power 5. So what am I going to do? I'm doing 5A. A to the power 5 I need, right? So I'm writing 5A by 5. I'm writing 5 times of A by 5. Why? Because this will create A by 5, A by 5, A by 5, 5 times, right? And it won't affect this also. Plus 3 into B by 3 plus 2 into C by 2 plus D as it is, no problem. Right, there are 5 A by 5s, there are 3 B by 3s, there are 2 C by 2s, and there is D. How many terms? 5 plus 3, 8 plus 2, 10 plus 1, 11 divided by 11. This will always be greater than equal to product of these. Product of these with the powers, right? So product of A by 5 to the power 5, because A by 5 is coming 5 times, B by 3 to the power 3, and C by 2 to the power 2 into D. D is also there, don't forget that, right? So what will you get? This thing, what is this thing? This thing is 11, right? 11 by 11 will become 1. 1 will be greater than equal to A to the power 5 by 5 to the power 5 into B to the power 3 by 3 to the power 3 into C to the power 2 by 2 to the power 2 into D. We want the upper term, so we'll send everything over here. So A to the power 5 into B to the power 3 into C to the power 2 into D is always less than equal to 5 to the power 5 into 3 to the power 3 into 2 to the power 2. Okay, always less. If the maximum value of this, what is the maximum value of this? This is the maximum value. This is the maximum value, and this is given to you in 3750 into beta, right? We have to find the value of beta. We have to actually find the value of beta over here. Okay, that's what. So this will equate 5 to the power 5, 3 to the power 3, 2 to the power 2, question solved. This is the maximum value, right? This is always smaller than this. So this is going to be the maximum value, and maximum value is given to us. So this is equal to 3750 into beta. So there will be some calculation. I think factorizing this will make it easier. 5 to the power 4, I think it should be. Just check once. So yeah, 5 to the power 5 into 3 to the power 3 into 2 to the power 2 is equal to 3750 into beta. So this is 337500, and beta will come out to be 90. We'll get beta equal to 90 simply. Okay, understood? Approach, simple approach. Whenever you see something like this and product is given with powers, in this case you have to use weighted AMGM. I did not use that term till now because I don't want you to think of AMGM itself in another way. Same thing only we are doing, right? Weighted means we are breaking the terms of AM and terms of GM, right, to get the desired form to solve the question. That's the only thing which we are doing. Nothing different. Okay. 90 should be your answer. Now there is one more important result or important result or remark you can say here. Remark is written, so I'll say remark only. Remark says that if between two numbers, if G is the GM of two numbers, A is the AM of two numbers, and H is the HM of two numbers, then A, G, H are in GP. Very important thing. If A, G, H are AM, HM and GM of numbers, that means AM is A plus B by 2, GM is root of AB, and HM is 2 upon 1 by A plus 1 by B. Okay, or again I'll write 2AB upon A plus B only, 2AB upon A plus B. Now it is saying that G square is equal to A into H. That means G means this is GM, so this is G. So square of this, what is the square of this, is equal to this AM into GM. That means this into this. So A plus B by 2 multiplied with 2AB by A plus B. And we can clearly see this gets cancelled, everything gets cancelled, AB is equal to AB. Both sides are equal. That means this is true. And this is true for positive A and B. AM, GM, wherever it is coming, inequality, believe that positive numbers, wherever the number should be positive, they'll mention it, or you'll have to see it that the numbers are positive. Okay, simple questions can be asked from here that AM and HM between two numbers are 27 and 12 respectively, then find their GM. We'll simply use the formula G square is equal to AH. That means G square is equal to AH also suggests this, don't forget this, that AM of a number, AM of two numbers or AM of given numbers, GM of given numbers and HM of given numbers, right? AM of given two numbers, GM of given two numbers and HM of given two numbers should be in GP. A, G and H should be in GP. Then only G square is equal to AH. No, that is why we are saying. Remember this, right? So, we'll directly use G square is equal to AH, G square is equal to 27 into 12 and this will give us G is equal to 18. Directly we'll get the answer in such cases. Find the minimum value of sum of three positive numbers if sum of their reciprocals is 9. If we want to make a question on HM inequality, then we'll come up with something like this. Now, so what do we do here? The minimum value of sum of three positive numbers if sum of their reciprocals is 9. Sum of their reciprocals mean, let's say the numbers are x, y and z. So, sum of reciprocals 1 by x plus 1 by y plus 1 by z should be given equal to 9. This should be given to us equal to 9. The reciprocal sum. Now, how will we use it? Minimum values of sum of three numbers. Sum of three numbers, that means we need to find x plus y plus z, the minimum value of this. All three are positive, so no problem. We can use the inequality. AM and GM, we won't use AM and GM now. Why we won't use AM and GM? Because here reciprocal is given, na? We already know that if reciprocal is involved, we can use HM. We get that hint already. So, x plus y plus z divided by 3 will be greater than equal to, AM will be greater than equal to HM also. So, HM is 3 by 1 by x plus 1 by y plus 1 by z. This is HM, right? So, x plus y plus z will be greater than equal to 9, 3 will go there, divided by, this is also 9. So, x plus y plus z is always greater than 1. So, what is the minimum value? Minimum value comes out to be 1. As simple as that. Okay, now very important thing, and many questions also come for JEE point of view on this particular notation, sigma notation or summation, right? Sigma notation or summation. Good, Devan, if you are preparing for RMO, this can definitely be a helpful topic for you. There can be many questions there again which can be asked, right? Very good. A little confusing, why? Not confusing, right? Not I'm trying to make it as less confusing as possible. If some part has confused you, revise that once again. Revise that once again, solve it on your own. When we try to, solve it mentally, that confuses us. When we have a pen and paper, we write things down, we'll write them in our own way. That is the point. That is the whole point. Then we'll be able to understand more clearly. Sigma notation means something like this. Sigma, sum. Sigma notation means sign of summation. That means we are summing things up. Okay. Sigma AK, when I am writing sigma, I am writing A and in the subscript I am writing K over here. Then over here I am writing K is equal to 1 to K is equal to N. What does this mean? This means that I am summing all the terms AK where K changes from 1 to N, right? Where K changes from 1 to N. That means what am I finding? I am finding A1 plus A2 plus A3 plus A4 till AN. This is what I am finding. This is what sigma means. Again, K is equal to 1 to K is equal to N. AK, that means A1 plus A2 plus A3 plus A4 till AN. I am trying to find the sum, and short form of writing this entire thing is this way, using sigma notation. Look here, AK, K is equal to 1 to K is equal to N, A1 plus A2, this thing. Now, look over here. Suppose if I want to write sigma of k, where k is from 1 to n. What would this mean? That k changes from 1, it moves with one step only, okay? It will move with one step only. It will not move with 2 steps. First k is 1, second k is 3, no. 1, 2, 3, like that only. One step. So what does this mean? K is 1, then plus when k is 2, then plus when k is 3, plus when k is 4, until when k is n. Sum of first natural numbers. And if we use the AP, we can easily find this to be n into n plus 1 divided by 2. Now, very important thing, sigma can be split, it can be distributed over positive sign or negative sign. If we have a plus or minus over here, then we can distribute sigma. That means if we have sigma of k is equal to 1 to k is equal to n, and inside we have ak plus bk, then we can break it as sigma of k is equal to 1 to k is equal to n ak plus sigma of k equal to 1 to k is equal to n bk. We can do that. Similarly here, if there is a constant, see here ak, k, this term depends on k and k is only with a, so c will come out. There is no role of C, C will come out of sigma. Please learn these properties very carefully. Video is not synced. I don't think so, beta. Okay. Check the internet connection once, please. For rest of you, I hope that it is synced. Alright. Now, next thing. Suppose if I have sigma of 3 times of A into I, where I changes from 1 to n. I changes from 1 to n. Now 3 into a1 plus 3 into a2 plus 3 into a3, this will come, 3 will come out. What will remain inside? a1 plus a2 plus a3. So there is no point of writing 3 inside the sigma. It will be 3 sigma a I. I changes from 1 to n. Simple. Now sigma of a constant number. Sigma of a constant number. Suppose if I am writing 2 inside sigma and here I am writing k is equal to 1 to k is equal to n. Now, there is no k with 2. There is no k with 2, but summation is there. So, 2 will get added n times. 2 plus 2 plus 2 plus 2 plus 2. This will just be 2 plus 2 plus 2 plus 2 plus 2, like that n times. So, it will be 2 into n. It will be 2 into n. Sigma of 1 will be n. Sigma of 2 will be 2 into n. Sigma of c will be n into c. That's it. Right. First thing, we can distribute sigma over plus and minus. Second thing, if there is a constant inside the sigma, take it out. Third thing, sigma of a constant term will be n into that constant term. If the iteration of sigma is from 1 to n. Okay. Not making this mistake, very important. Remember this, do not distribute sigma over multiplication, because see, what does this mean? This means a1 b1, when k is equal to 1 it will be a1 b1, right, plus when k is equal to 2 it will be a1 a2 b2, when k is equal to 3 it will be a3 b3, right. This is how it is going, this thing. What does this mean? Where else? What does this mean? This means a sigma of ak, that means a1 plus a2 plus a3, that means a1 plus a2 plus a3 till an, and multiplied with sigma of bk. Sigma of bk will be b1 plus b2 plus b3, like that. So it will be b1 plus b2 plus b3 and like that till bn. This will have a lot of terms, much more than this. These two are not equal. These two are not equal. Do not distribute sigma over multiplication and don't do this over division also. Neither on multiplication nor on division you should distribute sigma. Remember this, sometimes we tend to make mistake in this. Now 3 important things which will help us solve the questions based on sigma notation. Very important things. You can note them down if you need. Okay. So sigma k cube, sigma k, that means from k is equal to 1 to k is equal to n, that means sum of natural numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus like that till n. Sum of n natural numbers, we can find sum of n terms of an AP also. We can find this by finding the sum of n terms of AP, but best is to remember this. This can be easily remembered. Remember these. They'll be quickly, handily useful. They'll be very handy. You'll be, if you can use them in the sigma notation questions, if you remember them, right? Okay. Now, sigma of k, that means k moving from 1 to n, 1 plus 2 plus 3 plus 4 plus 5 plus till n. That means sum of first natural numbers will be equal to n into n plus 1 by 2. Sigma of k square, k moving from 1 to n, that means 1 square plus 2 square plus 3 square till n square. Sum of squares of first n natural numbers is given by n into n plus 1 into 2n plus 1 by 6. Sigma of k cube, that means sum of cubes of first n natural numbers, that means 1 cube plus 2 cube plus 3 cube is just square of this, n into n plus 1 by 2 whole square. It's just the square of sum of first natural numbers. Okay, we can remember this. Now, how do we use this sigma notation to solve our questions? Very useful, very useful. For example, if you see this question, 1 into 3, 3, 3 into 5, 15, 5 into 7, 35. 1, 15, 35, not an AP. Acha, is this an AGP? 1, 3, 5, 7. Okay, 3, then 5, then 7. Can't say. Right, not even in AGP it is forming. 1, 3, 5 AP, GP, nothing it is forming. What I need to do is, here simply I can get the point that I am supposed to use the sigma notation. Right, it is not AGP also. 3, 5, 7 not AGP. So what am I supposed to do? I am supposed to just write the nth term of this particular expression, this particular series. I just need to write the nth term of it, and on that nth term I can use sigma. How will I write the nth term of it? 1 into 3, 1, 3, 5, 7. 1, 3, 5, 7, odd number starting from 1. Told you in the starting, the general form is 2n minus 1. Or n is already there here. So what should I do? I'll use 2k minus 1, because while using sigma I'll use k. Okay, so 2k minus 1. When k is 1, I am getting 1. When k is 2, I am getting 3. When k is 3, I am getting 5. Now this term, 3, 5, 7, odd numbers starting from 3, 2k plus 1. 2k plus 1. This is my general term. This is the general term of this particular series. Can I say this is the general term? Right, this is the general term of this particular AP. Please try to understand. If there is any doubt, tell in the comment box. Getting my point, what I am trying to do? Achha, not Tn, we'll use Tk actually. Tk, because k terms, no? When we'll put T1, we'll get 1 into 3. When we'll put T2, we'll get 3 into 5. So this is Tk. I have write a general form of the terms coming over here. Now nothing. I just need to put sigma over Tk. K moving from 1 to k moving till n, because I have to find the sum of n terms. Correct. What is Tk? Tk is 2k plus 1, 2k minus 1 into 2k plus 1. Right, k moving from 1 to n. Now k moving from 1 to n, this will become 4k square minus 1. Right, this will become sigma of 4k square minus 1. K moving from 1 to n, and I can also write it as, I know that sigma can be distributed over plus and minus sign. So I can distribute it over here. Yes or no? Sigma can be distributed. Sigma of 4k square, I can say, minus sigma of 1. K moving from 1 to n, k moving from 1 to n. 4 will come out. 4 will come out constant. 4 sigma of k square minus sigma of 1. 1, 1, 1 n times minus n only. So 4, can I say 4 into sigma of k square, k moving from 1 to n, 1 square plus 2 square plus 3 square, sum of squares of n natural numbers. So 4 multiplied with n into n plus 1 into 2n plus 1 divided by 6 minus n. This is your answer. This will be the sum of n terms. This will be the sum of n terms. And when you'll simplify this, you'll get n into 4n square plus 6n minus 1 by 3, right? This same thing is coming. 4 by 6 became 2 by 3, n into n plus 1, 2n plus 1 minus n. And you can simplify this by taking the LCM. 3n minus 3n will go that side, right? This 3n will go that side. So you'll get 2 into 2n square plus 3n plus 1 minus 3, that will become n into 4n square plus 6n minus 1 whole by 3. Okay. Useful. How useful can sigma notation be? Right. Let's see one more question. Now we have to find the sum of 10 terms. Sum of 10 terms, but look at the terms 1, 3, 5. I know 1, 3, 5, as soon as I see it, I write it as 2k minus 1, odd numbers starting from 1. So I'm just simply going to write Sn I have to find, right? First I'll write the Tn, or I should say Tk, the any kth term of this, any term of this particular series. Tk will be 2k minus 1 whole square. When T1, that means first term is 2 into 1 minus 1, that means 1. Second term is 3. I mean 1 square, 3 square, 5 square. Now I'll put sigma. Sigma over Tk, k moving from 1 to n. So this will be equal to sigma over k moving from 1 to n, 4k square minus 1. So 4k square minus 1 plus 1 minus 4k. Plus 1 minus 4k will get, right? So can I write, here only I am writing, splitting the sigma, minus sigma k is equal to 1 to k is equal to n. I am just missing one step. I am just skipping one step. 2k minus 1, I am opening this bracket. Okay, I think I should write first like this. So I'll write sigma over k from 1 to n and sigma over 2k minus 1 whole square. This is what I'm doing. Now can I write sigma of k equal 1 to n, and here I'm opening it, so it will be 4k square, right, plus 4k minus 4k square plus 1 minus 4k. 4k square plus 1 minus 4k. Okay, I can split this again. Sigma of k equal to 1 to n, 4k square minus 4 into sigma of k is equal to 1 to n into k plus sigma of k is equal to 1 to n into 1. Here the 4 will come out. So 4 into k square, 4 into sigma of k square, that means 4 into sum of natural numbers, sigma of k square will become k into k plus 1. I'm sorry, n terms are there, so n into n plus 1 into 2n plus 1 by 6. So this will become 4 into n into n plus 1 into 2n plus 1 by 6 minus 4 into k. K moving from 1 to n, summation of k moving from 1 to n, that means sum of natural numbers, 1 plus 2 plus 3. So n into n plus 1 by 2 minus 4 into n into n plus 1 divided by 2 plus sigma of 1, 1, 1 coming n times, sigma of 1 moving from 1 to n, so it will be n. This is your desired sum of 10 terms. Now sum of 10 terms you have to find. Here n is 10, right? We have been putting k is from 1 to n, but actually n is given. We have to just find sum of 10 terms. So can we just put n is equal to 10? We found the sum of n terms. So we can put n equal to 10. Putting n equal to 10. 4 into 10 into 11 into 21 by 6 minus 4 into 10 into 11 by 2 plus 10. This is what I am going to get. Right, so 2 into what answer are we getting? The answer we can check. Answer we are getting as 1330. Okay, same thing. 4 into n plus 1 into 2n plus 1 by 6 minus 4 into n plus 1 by 2 plus 10. If we want to make a tricky question on sigma, it will look something like this. What will we do? What actually this means? First, we have to understand that what this means. What this question, how this question will be written down or understood or interpreted. This is actually sigma of k equal to 1. The k is moving from 1 to 20. And what is k? Here there is a sum of k terms given inside sigma itself. That means this means 1. When k is 1, only one term will be there. When k is 2, 1 plus 2. When k is 3, 1 plus 2 plus 3. When k is 4, 1 plus 2 plus 3 plus 4. When k is 5, 1 plus 2 plus 3 plus 5. So it is a big sum. It is a very big sum. Don't directly put k is equal to 20 over here. Very stupid mistake it will be. Right. So what are we going to do? We are going to write the expression of this sum inside the sigma. What is this? K terms, sum of k terms, sum of first k natural numbers, k into k plus 1 divided by k plus 1 divided by 2. 2 will take out, so it will become 1 by 2 sigma of k moving from 1 to 20 on k square plus k. This will remain inside, 1 by 2 will come out. So inside we will have k square by k. So what can we do? 1 by 2 sigma of k square by k. So that means sigma of k square plus sigma of k. Right, this will give us 1 by 2 sigma of k square 1 to 20. Sum of first n natural, first k natural numbers, first 20 natural numbers. K is moving from 1 to 20. So sum of first 20 natural, sum of squares of first 20 natural numbers. I'm sorry to say, sum of squares of first 20 natural numbers. K is moving from 1 to 20 and k square is there inside sigma. So this means sum of squares of first 20 natural numbers. That means 1 square plus 2 square plus 3 square till 20 square. What will that give us? 20 n into n plus 1 into 2n plus 1 by 6. So this will become 20 into 21 into 2 into 20 plus 1. That means 41 by 6. Correct? Plus sigma k. That means sum of first 20 natural numbers. That means 20 into 21 by 2. That's it. This is what I'm supposed to find. If we can calculate this, we'll get the answer. The calculation, I prefer that you guys do once on your own. Calculation also will get better, and if you're doing any silly mistake, that will also be observed. So this is becoming, you can see 420 into 41 by 6, and this is becoming 20 into 21 by 2. So yeah, this gets multiplied to 2870, and so final answer is 1540, half of this. Don't forget this half. That can be a mistake sometimes. Maybe this half is outside and a big bracket is becoming inside. So don't forget this half. Don't make that mistake. Right? Okay. Oh my God. Looks horrible. Does this look scary to you or different to you? Or is it normal? Is it normal? Now, JEE main question, right? Obviously, it will not be very normal. It will be a bit different. But we have to think that, sir, 357, AP is there, GP is not there, AGP is not there. That means AGP is not being created. Acha, what else can we think? These terms are increasing. So next time it will be 1 cube plus 2 cube plus 3 cube plus 4 cube. So I just need to think any general term of this particular series. Any general term. That means TK I need to mention. 357. 357. Okay. So 357, odd numbers starting from 3, 2k plus 1 simply. Right. For 357 I can write multiplied with 1 cube plus 2 cube, 1 cube plus 3 cube, 1 cube plus 2 cube plus 3 cube. So multiplied with 1 cube plus 2 cube plus 3 cube till k cube. Can we say that? Right. Divided by 1 square plus 2 square. So we can say 1 square plus 2 square plus 3 square. This will go on till k square. Have we written the kth term? No, we can even now we can simplify it more, because this and this we know. Sum of cubes of first k natural numbers, sum of squares of first k natural numbers. So this tk is becoming 2k plus 1 as it is, no problem. What will this become? Sum of cubes. So n into n plus 1 by 2 whole square, k into k plus 1 by 2 whole square. So this will become k into k plus 1 by 2 and the whole square of this, divided by k into k plus 1 into 2k plus 1 divided by 6. This is what we are going to have. And if we can simplify this, this will reduce to a very normal expression where we can apply sigma upon. Here we can apply sigma. So this is k plus 1 is getting cancelled 1 times, and 2k plus 1 we can directly cancel. 6 by 2, the 6 by 4 it will become. So it will become 3 by 2. This will come out to be tk is equal to 3 by 2 into k plus 1. Right? Tk is coming out to be 3k into k plus 1, or 3 by 2 into k plus 1, k into k plus 1 by 2, or 3 by 2 into k plus 1. So here we are going to apply sigma. Now we can solve this. This we know. Sigma over tk, where k moves from 1 to n terms, right? Sum of 10 terms we have to find. So k is equal to 1 to 10. So basically what are we going to do? 3 by 2 will take out, right? And sigma will be on k square plus k. K moving from 1 to 10. Okay. Sum of squares of first 10 natural numbers, sum of first 10 natural numbers. So what are we going to have? 3 by 2. Sum of squares of first 10 natural numbers will be 10 into 11 into 21 divided by 6 plus this sigma is distributed, right? Sigma k square plus sigma k. So sigma k will be n. N is 10. 10 into 10 plus 1, 10 into 11 divided by 2. This is going to be our final answer. Okay, this will come out to be, this will become 5. This is becoming 5. 3 2s are 6, 7s are 21, 2 5, 11 into 7. This is becoming, this will become 5 plus 55. Right, we can simplify this, no? This will come out to be, find the answer on your own once. (35 into 11), we are getting 10 into 11, we can take common also. There are many ways. Answer will come out to be 600. This will come out to be 600. You can see. not 600, it is 660 then. 660, sorry, my bad. Answer will come out to be 660. Same way, correct only. 3 by 2 into 10 into 10 plus 1 into 2n plus 2 into 10 plus 1 by 6 plus 10 into 11 by 2. This will be calculated to 660. Okay. This question, please solve and comment in the chat box. What you can do is, here 9, 12, 15, right? These terms are there. 9 is there, 12 is there, 15 is there. Multiples of 3, can you say? Multiples of 3 can we say? These are simply the multiples of 3, right? Or here one more thing which you can observe is, we can also get 1 and 6. How? See, sum of squares of first 3 numbers. What is the sum of squares of first 2 numbers? 1 square plus 2 square. So 4 plus 1, 5. 5, and here also some term must be there. This term also we can get along with this, or these will have to keep separately. First, don't think about this. First, try to make the general form of this one. First, try to make the general form only for this one. So 3n you can write over here. Right, this is 3n, n starting from 3. This is 3 into 4. This is 3 into 5. And these are sum of first 3 squares, sum of first 4 squares, sum of first 5 squares, and so on. So I can write the general term for you. I can write the general term for you. But you have to check whether in the general term these two also are fitting or not. Okay. So 3n, sum of first sum of first n natural numbers, sum of squares of first n natural numbers, right, divided by, here what do we have? 3n minus 1 or 3n plus 1, 2n plus 1. In fact, this is 7, this is 9, this is 11. 3n minus 1 won't work, right? 2n plus 1 will work. 2n plus 1 will work over here, right? This can be written as 2n plus 1. Now see, put n is equal to 1 or put n is equal to 3 first. Put n is equal to 3. 3 into 3, 9, right? 1 square plus 2 square plus 3 square, right? Or, and here 2 into 3, 6 plus 1, 7. This term is coming. Now put t is equal to 1. What is t1? t1 is 3 into 1 multiplied with 1 square, only 1 square, divided by 2 into 1 plus 1, that is 3. So we are getting 1. T1 is 1. And what is T2? T2 is 3 into 2, 6, 1 square plus 2 square, 5, divided by 2 into 2 plus 1, that means 5. That means 6. Yes, this general term is fitting for all the terms in this series. Now you can simply find your answer. This you know already. N into n plus 1 into 2n plus 1 divided by 6, right? This you know already. So you have to write it in terms of k now. You will have to write it in terms of k now. Okay, try this once. All the terms are fitting. All the terms are fitting. You can see this 3n, and this will become n into n. This sum will become n into n plus 1 into 2n plus 1 by 6. 6 has come here, right? Then we are cancelling 2n plus 1 and 2n plus 1, and we are getting n cube plus n square by 2. That simple we are getting, right? This is our Tn. Our Tn comes out to be n cube by 2 plus n square by 2, or not, no need even to split. So n cube plus n square, I think n cube plus what is this? N cube plus n square divided by 2. So if I'll put sigma over this, 1 by 2 will come out, and I'll have n cube plus n square, or n into n cube will become n into n plus 1 by 2 whole square. The sum of cubes of first natural numbers will become this. 1 by 2 has come out already. We are putting sigma over n cube and sigma over n square. So this is going to come up. Okay. And I think you can easily solve this. Not much of an issue for you all. What do we need to find? Sum of first 15 terms. Remember that. So finally n should come equal to 15. And the answer will be 7820. Find it and let me know in the comment section if you could solve it. Okay. Multiple sigmas. Even more horrifying. Sir, single sigma itself confused us so much. How will we handle multiple sigmas? We can handle them. We can easily handle them. Not much of a problem. But we have to work carefully. We have to use one technique which says that put your bracket, right? Sigma into sigma, no? So sigma n equal to 1 to, let's do it one by one. Okay. First, let's check this one. When I'm putting sigma of n equal 1 and to 10 multiplied with sigma of m equal 1 to 10 m into n. Here I have m into n. Acha, in this sigma, pay attention at this sigma first. In this sigma, m is moving from 1 to 10. Is n moving anywhere? Is it affecting mn? N is going to behave as constant over here, right? Because only this iteration of sigma, the sigma is only working with m. N is going to remain constant, m1. So n into 1, n into 2, n into 3, like that, right? So n will come out. So can I say that sigma of n equal 1 to 10 into n, right? Sigma of m equal 1 to 10 into n. So this sigma has come out already. So I think into I shouldn't use. This n came out. Now this is 1 plus 2 plus 3 plus 4 till 10. So this is going to be sigma of n is equal to 1 to 10 n times of sigma of m, moving from 1 to 10. 1 plus 2, 10 natural numbers, sum of first 10 natural numbers. So this is 10 into 11 by 2. Now 10 into 11 by 2 is going to come out. So this is 50, this is going to be 5, 11 5s are 55. So what are we going to have? This 55 will come out now. And what will remain inside? N is equal to 1 to 10 over n, moving over n, iterating over n. So n is getting added where n changes from 1 to 10. That means sum of first 10 natural numbers again, which will again come out to be 55. So my answer will be 55 square. This will again come out to be 55, no? No. 55 and sum of first n natural numbers, 1 plus 2, first 10 natural numbers, 1 plus 2 plus 3 plus 4. This will also be 10 into 10 plus 1 by 2, 55 only. So 55 into 55. Okay. Now next one. Yeah, 55 square. Next one. In this case, sigma over sigma, no problem. Here m and n, m was moving from 1 to 10, n was moving from 1 to 10. Both were moving separately. Here I is moving, k is moving from 1 to I and then I is moving from 1 to n. Both sigmas are dependent on each other. In this case, what can we do? What we know, we'll do what we know. So I from 1 to n, sigma of k, k from 1 to I. What does this mean? K from 1 to I. That means this sigma. If I put a bracket over here, that means this sigma, here k moves from 1 to I and gets added. That means 1 plus 2 plus 3 plus 4 till I. Sum of first I natural numbers. Can I say that? Can I say that? Sum of first I natural numbers. That's it. Nothing else. When I can say that, the question is, this thing we can do. So this will become sigma of I is equal to 1 to n, and sum of first I natural numbers means I into I plus 1 divided by 2. 1 by 2 will come out. Sigma of I equal 1 to n I square plus I. That's it. That's all. Correct? This I can do, no? Any problem? So simply this will become 1 by 2 will remain outside, and inside I'll have sigma of I square from 1 to n. That means n into n plus 1 into 2n plus 1 divided by 6. Sigma of I square plus sigma of I. Sigma of I square will become n into n square, n into n plus 1 into 2n plus 1 by 6. Sigma is moving from I to n. Remember, right? Plus I. That means sum of first and natural numbers. I moving from 1 to n, 1 plus 2 plus 3 plus 4. So sum of first n natural numbers. That means this is nothing but n into n plus 1 divided by 2. This is our final answer. This has to be our final answer. Yeah, this can be solved to n into n plus 1 into n plus 2 divided by, I think 6 we'll get. You can solve this. Take the LCM. We'll be able to easily solve this. Not very difficult. Or you can take n plus 1 common and then n into 2n plus 1 by 6 plus n by 2. That way, or however you want to solve. Right? But after this, you'll get the answer. Till here, you must understand. This thing you should understand, that how to break this. Main point over here, main key point over here is how to use the bracket. When we have two sigmas, how to use bracket and then break and get one sigma, this sigma, from using this sigma. First we find this sigma and then apply whatever expression we are getting after finding this sigma, will apply the outer sigma over that expression. Nothing very different or nothing special. In this case also, again, you'll have to put the bracket, right? So 1 is there, k moving from 1 to j. K moving from 1 to j, that means 1 getting added j times. So this will become j. When this sigma will open, this will become j. 1 is getting added j times. 1 to j, k is moving from 1 to j. 1 plus 1 plus 1 j times. So j. When we'll open this sigma, we'll get j. First we'll put brackets and outer bracket like this. So this will solve to j. Now we have bracket over here. J from 1 to I. Sigma over j. J is moving from 1 to I. 1 plus 2 plus 3 plus 4 till I. That means sum of first I natural numbers. That will be I into I plus 1 by 2. Sigma over I into I plus 1 by 2. I is equal to 1 to n. Again, I is moved. Now we can break this, right? 1 by 2 will come out and we'll have I square plus I. We'll have I square plus I. Now I square plus I, we can distribute this sigma over I square plus I. Sigma of I square plus sigma of I. We'll get sigma of I square will be n into n plus 1 into 2n plus 1 by 6, and sigma of I will be n into n plus 1 by 2, right? So your final answer you'll get as this. After simplification, you'll get this as your answer. Just remember this, how to apply brackets, how to use multiple sigmas, how to use brackets over while using multiple sigma notations. Okay. This question again, okay, let's come to method of difference. This question you can try once on your own. I'll give you a hint over here also. I'll give you a hint over here. Note this question, or you can try it on your own. You can comment the answer in the comment box. I'll give you the hint. So here what is given to us, a n plus 2. A0 is A0 and A1 is equal to 0. A0 and A1 both are equal and both are equal to 0. This thing right now, n is moving from 0 to infinity an. That means that there are infinite terms in this, and what you have to find is this. You just need to bother about this thing. So A0, A1 both are given as 0. An plus 2 is equal to 3n plus 1 minus 2an plus 1. This is the important thing that we need to use. An plus 2 is equal to 3an plus 1 minus 2an plus 1. This is what we are going to use. Now, according to this, what am I getting? Can I say that A, if I put A is equal to 0, what will I get? A2 is equal to 3 times of A0 plus 1, that means A1, minus 2 times of A0 plus 1. Correct? You must be getting the feeling, sir, this is 0, A2 is 1. Okay, that is not our objective. Even if we find A2 will not be able to move till A25, A23. Yeah, if we can make some pattern, we can. But one more simple decent approach which we can use over here, A2 is this. Now, what will be A3? When I'll put A as 1, so A3 will be 3 times A2 minus 2 times A1 plus 1. Similarly, A4 will be equal to 3 times A3 minus 2 times A2 plus 1. A5 will be equal to 3 times A4 minus 2 times A3 plus 1. And like this, An, this same thing, An plus 2 is equal to 3 times of An plus 1 minus 2 times of An plus 1. These are the terms that we are getting, right? If we substitute, if we use this particular given information, then these type of terms we are getting. Now, what if we add all of these terms? What will happen? Just try to identify what will happen if we add all of these terms. What if we add all of these terms? See, there is, if you see A2 is there, right? 3A2 minus 2A2, A2, 3A2 minus 2A2, A2 will get cancelled. So, A2, this A2, this 3A2, 2A2 will get cancelled, right? This A3, 3A3, 2A3 will get cancelled. Similarly, A4 will get cancelled, right? A5 will get cancelled. What will remain in the end? What will remain in the end? In the end, you just check on your own. An plus 2 will remain. This will not get cancelled. There is nothing ahead. An plus 2 will remain in the end. Tell me in the comment box. Are we getting this? An plus 2 will remain in the end. An plus 1 will remain in the end. Here, this will get cancelled. This 3An plus 1 will get cancelled. Right, what will we have? In the end, we will have An plus 2 plus An plus 1 is equal to this will also remain, right? 3An plus 1 will also remain. Yeah, this will be 3An plus 1. This will also remain. 3An plus 1 will remain here, and plus 1 will come n plus 1 times. So, 1 into n plus 1, n plus 1. What do we understand by this? An plus 2 plus every term will get cancelled. Finally, you will have An plus 2 plus An plus 1 is equal to 3An plus 1 plus n plus 1. Check once. Now, this 3An plus 1 and An plus 1 will become 2An plus 1, right? This will become 2An plus 1. So, can I write An plus 2 is equal to 2A times n plus 1 plus n plus 1. This will remain. What does this suggest us? How is this going to help us reach over here? That is the question. An plus 1 is equal to 2An, An plus 2 is equal to 2An plus 1 plus n plus 1. So, what if I want A25, what should I do? If I want 25, suppose if I do An plus 2 minus 2A n plus 1, this will come out to be n, this will be equal to n plus 1, correct. So 8 for 825, what will I need? N should be 23. So 825 into minus 2 times of a into 24 is equal to, will be equal to 24. I am sorry, 23 plus 1, that means 24, right. Right. Now you can manipulate this, and if you look at this, this is nothing but 825 you can take common between this term and this term, right. A, and here you can take 824 as common. Try this once on your own. Finally, you will remain with 823 minus 2 822. Finally, you will remain with 823 minus 2 822 multiplied with 825 minus 2 824. 825 minus 2 824, and this you can find. 823 minus 2 822 you can find, right. 823 minus 2 822, that means n is equal to 21, that means 22 will come here. This will become 22. What will become here? This will become 825, that means n is 23, so this n plus 1 will become 24. 22 into 24 should be your answer. Solve this once on your own, write all the steps, write all these terms, cancel the terms. Finally, what you are getting? A n plus 2 plus a n plus 1 is equal to 3 a n plus 1 plus n plus 1. So, n here a n plus 2 is equal to this expression, and a n plus 2 minus 2 a n plus 1 is equal to n plus 1. This is going to give you a constant thing. That is what we want. A n plus 2, now we can create A25, right? If we put n is equal to 23, this is A25 minus 2 times of A24 is equal to 23 plus 1, that means 24. So, A25 minus 2 A24 will come out to be n plus 1, and we can simplify this entire thing to this one. Now, the very important and last, also the last part, which is method of difference. How do we apply the method of difference to find kth term when difference of consecutive terms is given? This particular method is applied to find the kth term. And when do we apply this method? Very specific condition for applying this method is that your difference of consecutive terms is good. Good means it should be something which you can deal with. Maybe it is forming an AP, it is forming a GP or anything, but it should be something you can deal with. That is where we are going to use the method of difference. We'll learn this method. For example, something like this, 5, 7, 13, 31, 85. Now I can see over here, I am not able to see that there is no AP. I am not even able to form GP. Nothing. AP, GP, HP possibly, not possible only. So, what I can observe is 5, 7, 13, 31, 85. If I observe these terms, this two difference is 2. There, the difference of these two is 6. Here the difference is 18. Here the difference is 54. This is what I am calling good. This is what I am calling good. 2, 6, 18, 54. That means it is forming a GP. Here, in such cases, I can use method of difference. Remember guys, when to use method of difference? You have to use method of difference when the difference of consecutive terms is giving you a AP or GP. Simple thing. Okay. Now, how to use? The question is how to use the method of difference. So, we'll write sum of n terms. Sum of n terms, or yeah, we'll write sum of n terms. Sum of n terms is equal to 5 plus 7 plus 13. Simply write like this: 5 plus 7 plus 13 plus 31 plus 85. Right? It will keep going on till nth term. Right? Now again write the sum. Sir, again means write the sum, but with shifting one place ahead. So same thing I am writing, but like this: 5 plus, same steps you have to follow to apply the method of difference. Write the sum, write the same series by shifting one term ahead. So 5 plus 7 plus 13 plus 31 plus 85. And why am I doing it? To use the method of difference. Method of difference means difference in the consecutive terms is giving me something which I can solve. So that means I am going to use the difference 7 minus 5, 13 minus 7, 31 minus 13, 81 minus 31. This will form something, right? This will form an AP and GP. AP or GP. Check once. This will have Tn terms. This will also have, here it will be Tn and it will be Tn minus 1, right? Now subtract, so this side Sn minus Sn will give you 0, 5 minus nothing will give you 5, plus 7 minus 5, put a bracket, 7 minus 5, 2. We multiply R for AGP, right? In case of AGP, here we are not multiplying anything, we are just writing the same series sum by shifting one term ahead, nothing else. And we are subtracting now. 5 minus 0, 5, 7 minus 5, 2, 13 minus 7, 6, 31 minus 13, 18, 54 and so on. Now, how many terms does it have? It has n minus 1 terms. N minus 1 terms. And this plus Tn will become minus Tn. This plus Tn will become minus Tn. Now I can solve it. Now I can solve, that's a different case, but I can write Tn. This minus Tn will come this side, right? So it will become Tn. And Tn, find the nth term. That's what we are supposed to find. 5 plus 2 plus 6 plus 18 plus 54 till n minus 1 terms. What will this become? A into A minus R to the power n. What is R? 3 to the power n minus 1 divided by it's not 1, it's not 2 here. 1 minus R to the power n divided by 1 minus R. Right, this is your Tn, simply. N minus 1 terms are there, right? So 2 multiplied with, or you can write it like this also, if you want to write 5 plus 2 into 3 to the power n minus 1 minus 1 divided by 3 minus 1. If it makes you more comfortable, if this is making you more comfortable, 3 minus 1, 2, write it like this. This is the nth term. And can we check? T1, 5 plus 3 to the power 0 minus 1 by 2. 1 minus 1, 0. This will become 0. First term is 5. Second term T2, 3 to the power 1 minus 1, 3 minus 1, 2, 2 by 2, 1, 5 plus 2, 7. Yes, this is the nth term of this particular series. And if I have the nth term, here I can use the summation to find the sum of the terms also, not a problem. Nth term is this. Sum of first 20 terms of this series. We have to find the sum of first 20 terms of this series. Acha, AP, is there an AP? 5, 11, 19, 29, no. Sir, there is no AP over here. I cannot see an AP over here. GP, 5, definitely no, not possible. What else is remained? Method of difference. What else is remained? Right, this question came in 2023 only. What else is remained? I can either I find the differences, consecutive differences, and form some pattern there. So I can see 5, 11, 19, 29, 41 and so on. So this is 6, this is 8, this is 10, this is 12. Correct. Good. That is what consecutive difference is making me happy. This is making me happy. Why is this making me happy? Because I know this is an AP. Now I am just going to follow the simple approach. I will follow the simple approach and write the sum first. So sum of 20 terms we have to write. Sum of 20 terms. Okay. Sum of 20 terms is going to be equal to 5 plus 11 plus 19 plus 41 till 20 terms. Okay. Till 20 terms. And same thing, S20 only I am writing as shifting one term ahead. 5 plus 11 plus 19 plus 41 like this. 20th term, or shall I directly write T20 over here? T20, and I'll have T20. This will be T19. Okay. 5. Now this side I'll have 0. This side I have 5 plus 11 minus 5, that is 6. So I'll put a bracket 6. Here 8 plus 10 plus like this till T20 minus. Now in the end this will happen till n minus 1 terms. This will go on till n minus 1 terms. Correct? This thing will go on till n minus 1 terms. That means 19 terms till T19 only. Right? This will have 19 terms. This particular thing will have 19 terms. This series will have 19 terms, and minus T20 will get. We are getting minus T20. So T20, that means 20th term. Can we tell the 20th term from here? We can tell the 20th term easily, right? 5 plus, this will become 19 terms are there. Here we have 19 terms. So can we apply the sum formula? Or 19 by 2 directly we can write, or 19 by 2 into 2a, that means 2 into 6, 12, plus n minus 1, that means 19 minus 1, that means 18 into 2. This will be my T20, 20th term. But actually what is it asking me? It is not asking me 20th term. So even if I find 20th term, there is no point. Can I apply summation on 20th term? No, I cannot apply summation on 20th term. So it's better that I don't, what do we understand from here? That it's better we don't use N20 right now. We just simply keep it Tn. We just simply keep it Tn, so that we can apply the summation on Tn. Right? Because we have to find the sum of first 20 terms. So the purpose should not be to find the 20th term or Tn. Right? Purpose should be to find the Sn. Purpose should not be to find T20. It should be to find Tn. Okay. So I'm instead of 20 everywhere, we just wrote n. So this became 0, correct only. This has n minus 1 terms. This particular thing I'm removing. Okay. So this will become Tn now. This thing will become Tn now. And Tn will come this side, so Tn will be 5 plus. Now, sum of this series till n minus 1 term, n minus 1 by 2. This will have n minus 1 by 2 into n minus 1 terms it has, this particular part has n minus 1 terms, n minus 1 by 2 into 6, that means 12, plus n minus 1 minus 1, that means n minus 2 into d, that means n minus 2 into, what is d? 2. This is what you are supposed to do. Now this 2 will cancel, this 6 and this 2 also will get cancelled. So Tn will come out to be 5 plus n minus 1 will have here, and here we'll have 6 plus n minus 2. So now you are getting Tn. Tn will come out to be, this Tn, when you simplify this Tn comes out to be 3n square plus, this will give you n square, 6 minus 2, n square plus 3n plus 1. This will come n square plus 3n plus 1. This will come out to be n square plus 3n plus 1. Solve it once. Okay. Simplify it once. Finally, you will get n square plus 3n plus 1. This is your Tn, and over this you can apply sigma over Tn. That means sigma over n square plus sigma over 3n plus sigma over 1. Moving from 1 to n. Moving from 1 to n, and n is 20. Right? Moving from 1 to 20. Right? Here n moves from 1 to 20. So this will become 20 into 21 into 41 by 2. This will become 3 into 20 into 21 by 2, and this will become 20. 1, 1, 1 added 20 times, so 20. Finally, your answer which should come is 3520. Let's check. Yeah. Okay. Now one more method which is called VN method. VN method, generally directly I'll tell you with question, that VN method is used when such a situation occurs. When such a situation occurs, we'll use VN method. Now, how this VN method, how this method is going to help us, or when to apply this method? See, we have to apply this method only when the difference of the numbers which are in the product in the denominator is equal to the numerator. For example, here 2 minus 1 is 1, 3 minus 2 is 2, 3 minus 2 is 1, 4 minus 3 is 1. Let's look at this question. Now, how do we use the VN method? Sum of n terms we have to find over here, right? So 1 by 1 into 2 plus 1 by 2 into 3 we are saying, plus 1 by 3 into 4 we are saying, and this goes up to n terms. This goes up to n terms. How to use this method? First of all, observe that the numbers which are in the product in the denominator, same numbers can we use to get the numerator. The difference of the same numbers is there in the numerator or not. The numbers which are there in the denominators, can we use the difference of the same numbers to represent our numerator? Yes, definitely possible. 2 minus 1 is 1, 3 minus 2 is 2. So we'll write like this: sum of n terms is equal to 2 minus 1 by 1 into 2 plus 3 minus 2 by 2 into 3 plus 4 minus 3 by 3 into 4 plus 5 minus 4 upon 4 into 5, and this will keep going on till n terms. N terms means denominator what we'll have? N into n plus 1. N into n plus 1. Denominator will be this thing only. Nth term, how will the nth term look like? N into n plus 1. 1 into 2. And numerator will be n plus 1 minus n, which is 1 again. Right? 1 by n into n plus 1 can be written like this. Now see, the beauty of this method is that everything gets cancelled just because we are writing it like this. How? 2, we can split this 2 upon 1 into 2, that means 1 upon 1 minus 1 upon 1 into 2, that means minus 1 by 2, plus 3 upon 2 into 3, that means 1 by 2, minus 2 upon 2 into 3, 2 upon 2 into 3 minus 1 by 3, plus 4 upon 3 into 4 plus 1 by 3, minus 3 upon 3 into 4, 3 plus 1 minus 1 by 4. So here we are getting 5 upon 4 into 5, that means 1 by plus 1 by 4 minus 4 upon 4 into 5, that means minus 1 by 5. You can see what I am trying to say is these terms, all these terms will get cancelled. All these terms will get cancelled. And here what we will have, n by n plus 1 upon n into n plus 1, that means 1 by n minus 1 by n plus 1. This will also get cancelled. What will remain? Sum of n terms will be 1 minus 1 upon n plus 1. Right? Beautiful method. But specific condition to apply this. Remember, generally these type of questions, when in the denominator you have products, there it is believed that you can use this method to solve your question easily and quickly. Okay. 1 minus 1 upon n plus 1 will be your required sum. This will be your sum of n terms. Okay. So, in this case, 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, but numerator we don't have 4. So what we'll do, if this is Sn is equal to, what we'll do, 1 by 4 will divide and will multiply 4 upon 3 into 7 plus 4 upon 7 into 11 plus 4 upon 11 into 15. Right? This is how we can write it. Check once. We have divided by 4, multiplied by 4, and can we apply VN method over here? Yes. The numbers which are in the product in the denominator, same number if I subtract 7 minus 3 gives me 4. So I can apply. Right. But the point is, what will be over here, what will be the last term? 4 by 3, 7, 11. How should I write it? 4n minus 1, 4 into 1 minus 1 is 3, 4 into 2 minus 1 is 7, 4 into 3 minus 1 is 11. So 3, 7 and 11 I can write as 4n minus 1. Now what about 7, 11 and 15? 7, 11 and 15. 4n minus 1 is this. This is 3 plus 4, right? So 4n minus 1 plus 4. That means 4n plus 3. Right? 7 is 3 plus 4, 11 is 7 plus 4, 15 is 11 plus 4. So this term, this term is 4 more than this term. 4n minus 1 plus 4. That means 4n plus 3. This will be my required. Now I'll have to sum this up. Now sum of n terms is equal to 1 by 4. So what am I going to do? Here I'll write as 7 minus 3 by 3 into 7 plus 11 minus 7 by 7 into 11, 7 into 11 plus 15 minus 11 by 11 into 15, and this keeps going on. So here what will I have? 4n plus 3 minus 4n minus 1. That means 4, right? 4n plus 3 minus 4n minus 1 divided by 4n minus 1 into 4n plus 3. Now I can visualize everything. See, sum of n terms 1 by 4 over here, 7 by 3 into 7, 1 by 3 minus 1 by 7 plus 1 by 7 minus 1 by 11 plus 1 minus 1 by 7 plus 1 by 7 minus 1 by 11 plus 1 by 11 minus 1 by 15, and it will keep going on. What will remain? 4n minus 1 upon this thing. That means 1 upon 4n plus 3 will remain. Everything else will get cancelled. 1 by 3 and 1 by 4n plus 3 will remain. So what will I have? Sum of n terms will be given by 1 by 4 multiplied with 1 by 3. 1 by 3 minus, this thing will be minus, right? So minus 1 by 4n plus 3, right? The previous term will also get cancelled. 4n plus 3 upon this, that means 1 by 4n minus 1 minus 1 by 4n plus 3. What will we have here? 1 by 4n minus 1 minus 1 by 4n plus 3. 1 by 4n minus 1 will get cancelled and 1 by 4n plus 3 will remain. So this will be my desired sum. That's it. You can take the LCM and simplify it. So sum of n terms, let's see what is it coming out to be. Yeah, 1 by 4 into 4n minus 3 minus 3, 4n plus 3 minus 3. So 4n will remain here, 4 will get cancelled, n by 3 into 4n plus 3, that's it. This is your required sum. How easily we could find it using this approach. Now you can also apply if three terms are given in the product in the denominator. You can also use there, not a problem. How? Here 2 into 3 into 4, so 4 minus 2 you can write, not an issue. 4 minus 2, you can write it as 4 minus 2. Sum of n terms, I'll just give you a hint, try to solve it on your own. 4 minus 2 if I write, and here if I write 2 into 3 into 4. Only the difference of extreme terms should be in the numerator. So difference of extreme terms is 4 minus 2, that is 2. But 2 is not there in the numerator. What should I do? If 2 is not there in the numerator, I'll create 2 in the numerator. That's what I can do. I'll create 2 in the numerator. So 2 divided by 2 into 3 into 4 plus 2 divided by 3 into 4 into 5. So we have finite number of terms. So we'll write 2 divided by 100 into 101 into 102. That number of terms are given already. We don't need to use n. This entire thing is equal to k by 101, we'll write that later. Here 1 by 2, here what we are having, 4 minus 2 I'm writing it as 2 into 3 into 4 plus 5 minus 3 upon 3 into 4 into 5. Right, next term, what will I have? Plus 6, sorry, my bad. Plus 6 minus 4, we'll write 6 minus 4 upon 4 into 5 into 6. That means, I can write as it is. Here what will be happening? Here 102 minus 100 will be upon 100 into 101 into 102. This thing. Now, if we'll split it, here also terms will get cancelled. 1 by 2. Look, 4 upon 2 into 3 into 4, that means 1 upon 2 into 3. Minus 2 upon minus 1 upon 3 into 4. Here minus, sorry, plus 1 upon 3 into 4. Minus 1 upon 4 into 5. Here plus 1 upon 4 into 5 is coming, and then minus 1 upon 5 into 6 is coming. So these terms will get cancelled. Here what will get cancelled? 1 upon 100 into 101 will get cancelled. What will remain? Minus 100 upon, minus 1 upon 101 into 102 will remain. This will remain. So my required sum is equal to 1 by 2 into 1 by 6 minus 1 upon 101 into 102. This is my required sum. And this exactly is given equal to k by 101. Right? This is only given equal to k by 101. So when we'll simplify this, let's see what is it coming out to be. Yeah, 1 by 2 into 1 by 6 minus 1 upon 101 into 102, that is what we are getting. Okay, and that is equal to k by 101. So we get k equal, and we want to find 34k. So first we'll find the value of k here. 101 will get cancelled, and 34 into k will be 34 into 143 divided by 102. I think it should come out to be 286 then. Right? It will come out to be 286. Do we have that in the options? Yeah, 286 is the correct answer. 286 is your correct answer. Okay, so I think that's all from my side. It has been a long stretch of time, but I would say that the chapter is important. Practice some more questions, revise these questions. If you are not able to watch the entire lecture in one stretch, watch it with gaps, but practice all these questions on your own. Write them out down and try to solve them on your own. When I show you terms cancelling, no, it feels that yeah, it will cancel. But once you do it on your own, then you'll realize that where the problems might occur. It is a very calculative chapter, and for the calculative chapters, you should always practice more, right? So sequence and series, again important also. From last 3-4 years it has been observed that many questions come from this particular chapter. Don't take it lightly. Most of the information, most of the concept, almost all the concepts that can be asked in terms of mains or advanced are told to you. Major questions or many variety of questions also we have done in this session. You have to practice more now with the questions you can find on internet, on your modules, whichever coaching you are using, or the same questions also, if you can revise and solve once on your own, it will give you a better grip at this chapter. All right. Okay then, one more last and important thing. I'll tell for all of you, that please subscribe this channel, whichever class you are from, right? 11th or 12th. If you are going to prepare for JEE, if you are currently preparing for JEE, all these sessions, all these lectures are going to help you a lot in your preparations. So subscribe this so that you get, constant notifications for these lectures, which are and the upcoming lectures. There'll be more lectures, there'll be more sessions on more topics which will help you for your preparations. So that's all from my side. Don't forget my name. My name is Ayush, and see you once again. Thank you. Thanks a lot.